Yeah, so, hold on, let's switch over there. Good morning, everyone. So, wow, what a night. Oh, and is that thing on battery? I'm hoping not. Oh yeah, it is. Okay, so, before we get going, I'm gonna have to mute this laptop. There we go. And I'm gonna have to, now we're gone. Okay, let's switch back to here. So, more setup stuff. We now have 4 cameras going. More than I probably need, but you know, when one runs out of battery, I can always switch over to another one. So today, I'm excited for which camera are we on? This one. I'm excited for what we're gonna do today. So you guys were asking in chat about why I have two, or how I can show the Prusa i3 assembled and the non-assembled one. I got 2. Joe Prusa actually sent me 2 machines. I was surprised. Apparently he told me beforehand, but I was still surprised to see that. He sent me 2. He sent me one completely assembled one in the as shipped assembled version, and he sent me another one, a full kit. So I'm gonna pull those up, and while I do that, I'm gonna switch the battery of that camera because that one is dead. Alright, so we've got the Prusa i3. There is the kit. That thing is actually quite heavy. And there is the fully assembled one. It's probably just the same weight, it's just, it feels much heavier. Okay, battery in, battery out. New battery in. And I just have to quickly re-enable the camera. Just 1 second. Oh, that one's already working. Okay, so that's the second camera. Yeah, so what we are going to do today is we're going to start out with the fully assembled one. We're going to unbox this one. We are going to get it printing. And then while that is printing, it should be around noon, around lunchtime. I've got something planned for lunch. Oh, we're gonna see. It does not involve frogs. No frogs were harmed in the making of this video. Yeah, but this one first and then the kit. So that's gonna be open-ended. I hope it's not gonna take until like 2 a.m. again. Apparently the estimates for this one are between 4 and 6 hours. So with you guys in chat, I don't know how much of an overhead that will create, but we should get this one done in, let's say, around 5 to 6 hours. So let's get this one out of the way first. Yeah. Yeah. So before we get into this. 2 more things. 2 more. 1 more. 2 more things. Well, I hope Nightbot is working. I just had him join the channel. He should be, you know, auto moderation for caps lock and stuff to keep the chat a bit more organized. And also, I set up stream tips. So if you want your name to be like all up in the screen, donate it that much. You know, I guess that's what live streamers do. You can also do that, and it should be in the video description, linked in there. And while I won't be able to display the message on YouTube live yet, apparently that is Twitch only for most software platforms that people are using, I am going to read it. For example, yesterday night before we actually started streaming, Tom O'Sullivan donated 20 euros, so huge thanks for that. You don't make it easy for yourself. Looking forward to the stream. So with those words, I guess let's dig in. I'm hoping I'm not going to get confused with all the hotkeys I have on the keyboard over here. I don't know if you can see these. GPS keyboard, and I basically wrote on the keys as far as what those, what each of those do. So I can switch cameras. I can do all sorts of stuff. Hopefully a bit quicker than you know, switching manually and not having the labels on there. All right. So this is our first box. Now you might see it's already open. Joe Prusa, he actually wrote me, okay, I'm nervous now because apparently I make people nervous. Maybe. And he had me check that the correct type of manuals were included, and I checked, and they are. And I also checked the printer itself, just to kind of get a feeling for what we're about to get into. So, except this is the. You can only see the starting soon logo. I hope that YouTube is showing it just fine for me. I don't know, might be a problem on your side. Hit refresh and that should be better. Alright, so this is the original Prusa i3. Angus in the house? Oh there. Hey Angus. So this is the genuine Prusa i3 from Josef Prusa himself. So in case you don't know, there are i3 machines, or i4 as they're calling them these days, already everywhere. Now, what they are referring to is the i3 platform. The basically have a sheet in the back, and then the z-axis bolted together to that, and then the x-axis perpendicular to that, obviously. But they are not what I'd call a real Prusa i3, because Josef Prusa is a guy. He is a real person, and back in the day he made the first Prusa Mendel, I believe it was called. Basically a cells Mendel that was a bit easier to build, and then did the cells, the Mendel i2, V2, I don't know what that name was exactly, then the i3, and now the i3 Mark II. And I don't think he's been selling the Mark II, but he was selling the i3 or the i2. He wasn't selling the i2, but he was selling the i3. I actually recommended that to a few friends, and they are super happy with it. And now that the i3 Mark II is out, he sent me one fully assembled one and one kit version to finally show you guys and test out, I guess. So this is the machine itself. So it is relatively compact if you look at it, especially once you compare it to last weekend's Dynamo 3D. Did we do that last weekend? No, we assembled the Atom. The Atom is even larger. Let me get you guys a good view on that. So it is a relatively compact machine, and a relatively simple one too. So it's got the x-axis right here, which is still blocked by the belt clamp right here, and the y-axis, the heated bed, also blocked by a belt clamp right back here. And yeah, really simplistic design, more or less. As far as components go, let me just show you around real quick. Power supply on the side with a receptacle, IC receptacle, and the on-off switch right there. And then I'm hoping I'm not going to break more than necessary. Basically nothing on the bottom, so you can see the basic idea. You've got the aluminum frame sheet right there, and then these threaded rods going to the front and the back, and then the linear rods sitting on top of that. That is basically the same way any i3 is built these days. And then on the side we've got the electronics compartment. I hear there is some sort of a genuine Rambo in there. I guess we're gonna see that in the live build. There seems to be some sort of a hinge right here. I'm gonna have to check that out. Does it open? Apparently not. There seems to be some sort of a genuine Rambo in here, which... Can we... There we go. Which is always good to see, to get real hardware and not some knockoff in there. So there is what seems to be a calibration. No, it's packing list basically. Oh, that is nice. Let's see, you guys, and if you can see this. So I'm hoping the focus is right here. But basically a packing list, where assembly list more or less. Firmware flash, printer communication, SD card in it, fan trigger at 50 degrees, so the hot end fan, heat bed 97 degrees in 8 minutes, hot end 240 in 1 minute 50. That's all okay, so I guess that is somewhat automated. Then you've got the heating graphs down here, and the what is it? The heating bed for the heating graph for the hot end right here, and then the heating graph for the heated bed. So I would assume this is, you know, individual for every machine. Let's just double check the serial numbers right here. So it's got a sticker back here, which I probably can't show you really well because I have to balance it. Right there is the serial number, probably made in Prague. That's Czech Republic. There's the serial number. There's the serial number up here. A testing protocol from 9th of August. So these are pretty fresh machines. And that seems to all be in working order. Did I change the cameras? Yes, I actually changed the cameras around quite a bit. I've got pretty much the same camera over top right there. That's Panasonic G7. Then I've got the second camera over there. That is my regular video or regular content lens basically. It's another G7 connected with these. Maybe I can show you guys there with all these Media capture things. They are horrible. They are cheap, but they are so horrible. They don't work. Don't buy them. Buy something real. Yeah, that. Then I've got the webcam. I've got all sorts of stuff, and still with the Zoom H4 recorder. That seems to be working really well once you get it running. Yeah, hardware in here is Rambo based, so it is a Atmega 2560 chip. But we're gonna see in the assembly. I think there are, the Atmega based boards. 32-bit is nicer for a Delta. I would definitely say go with 32-bit. For a Cartesian one, they're kind of good enough still. The only thing I'm seeing is price-wise, it's not a real deal. The 32-bit processor are exactly the same price, pretty much. Sometimes they're even cheaper because Atmegas are just, obsolete hardware basically. They're just making them because there's still demand. But of course, for 32-bit, you need to find the right firmware. Or you need to have the right firmware. That zoom picks up every bang on your table. You know what? I might actually try to move that up here on the overhead boom. Just to make it a bit easier on your headphones. Yeah, but let's dig in a bit further. So we got the printer itself out, and I know there are two things wrong with this one, which should be really quick fixes. More on that in a second. Hoping that didn't blow anyone's headphones off. Yeah, the assembled one is 999 euros. The kit version, I believe, is 789 euros, which does include sales tax, but does not include shipping. And they shipped from Prague, Czech Republic. Okay, so that should be it. We've got the packaging list again. So this is the actual, thanks Thomas for packing that, on August 23rd. So that is really fresh. Congratulations on getting the original Prusa i3 Mark II assembled from Josef Prusa. And that's a bit more full, and that is it. Let's move this guy somewhere where it's not in the way totally. Yes, it does have a genuine E3D V6 in there. Let's see if I can. Wow, you really can't see it. Ooh, and it's the new one. It's the new V6. We're gonna see the all the glorious details of what the V6.1, I believe it's going to be called, from E3D is going to be, because it is quite an improvement in my opinion over what you've been seeing being sold or being used on other platforms and being sold by E3D. And of course, it's a genuine part, so that's always better than getting a rip-off. So right there we've got some filament included, so that is a full 1 kilogram spool. PLA black, made in the European Union. So I think I should be good on filament. And a Prusa research box, so this is where the aforementioned manual comes in. So we've got the 3D printing handbook, which is a user manual for 3D printers, the original Prusa i3 Mark II Kit 1.75. or the assembled one. So I guess that is what we're going to go by. Yeah, safety instructions, printer kit, Mark II printer. It does only support 1.75. So far that looks fairly comprehensive. Printer unpacking and proper handling. Yeah, so first steps. I guess that's what we're gonna go by. Oh, look at that. Nightbot is working. Yay! Okay, so let's start with that. So I did tune down the camera's contrast setting, so it should be a bit easier to read if it's sharp enough, which it does not look like. But I believe these are also online in one form or another. So, price for this one, get it on, please don't buy it on eBay. Oh, apparently Nightbot nukes links, wow. The genuine one can be bought at PrusaPrinters.org. Let me just put that, or Prusa3D.com, that's the link. I'm going to put that right here so you guys can hopefully read it. Wow, and of course it is too low in the frame. That is awesome. Prusa3D.com. That's the original one, straight from Joe Prusa, straight from the maker himself. All right. Setup before printing. So we are starting with the first steps right there. So that feels like 2 sheets, but it is not. It is just thick paper. All right, proper handling. Grab it like that. Do not grab it anywhere else, obviously, because you might bend stuff. Do not forget to remove all the green zip shipping helpers parts. I think someone was asking about these things right here. So there is a clip right here, right there, and down here on the belt. And I can already feel this belt is loose. So something loosened up. As far as I know, it's the bed clip on the bed's undercarriage. So let's get into removing these. And these are just little screw clips that keep the Z-axis rods from turning. Yeah, so one more thing I guess I should point out, this design is of course completely open source. That is something you rarely see to that extent these days. So it's not just, fakey open source. Yeah, we're kind of publishing a few design files and then doing like non-commercial Creative Commons for only the frame sheets and nothing else. This is actually, I guess it's pretty much as good as what Luxbot is doing with their open source stance. We're running into trouble here. I can't get this clip off. Do not forget to remove them. So this one is screwed and the thread is, wow, that's loud. And the thread is actually stuck in the plastic part. Let's try the other one and see if that one goes better. Yeah, so I believe the manual should be online. I did check it before I started here, but there's also not instructables, but I fix it like it's the same software that Joe used to create some basically step-by-step walkthroughs. Wow, and this one is not coming up either. So yeah, you guys saying Cartesian, open source, good price. This is actually, even though some people might say otherwise, but I think this is pretty much the hottest release of 2016. The genuine Prusa i3, like I said, I've recommended the predecessor to this machine to a few friends and they are super happy with it. I got to play around with it a bit, but not enough for a full review. But from what I've seen about this machine so far, this might, don't use a hammer, no. This might be like your not just when it comes to price per performance, but also when it comes to absolute performance and just overall experience. I think this might just be my new favorite. There we go. My new favorite printer. But of course, we'll see. We'll see how well it actually does once we get to the printing part of the stream. Alright, so that's the first clip. The second one should come out a lot easier. There we go. Oh, and the belt's coming along with it. Second clip, and the third one is down here, which is a two-part clip. We should be able to just pry this one open. So this one has been shipped by FedEx, I believe. It took them exactly 18 hours from departure at the at Joe's lab in Prague to actually arriving here, which is freaking insane. I gotta say, 18 hours between countries. That is absolutely insane. All right, so we've got the clips out. Clips out. Attach filament to the holders. Yes, we don't need that. Actually, so I did check beforehand, and I noticed there were a few things wrong with it, to be exact. So first off, if we can't lay it on its back really well. Let's see. Well, we kind of can if we do it like bending wire is not what you want to do to a brand new printer. Okay, let's do it like, wow. Okay, so first issue, you can't really lay it down flat. There we go. That looks better. Okay, so first problem I saw was switching cameras. Does the screen skip a bit for you guys? It should be relatively smooth. I'm pretty sure the encoders are well set up and not like overloaded or anything. Yeah, but first issue is this Y belt. This Y belt right here is like super loose. So it's going to the motor back here, directly to the pulley. And then it is going over to the idler on the other side, and that one is just fixed, and then to the belt clamp on the bed right here. And what I believe happened is this clip on the belt it didn't do its job well enough, and the frame is not warped. The camera has a fisheye lens on there, which makes things a bit distorted looking. So I believe this clip slipped right here, so we should be able to retighten that up. Maybe move it back. Oh, where were those notes about proper printer handling? That looks like it's not doing anything. All right. Yeah, this clip right here. Let's grab the webcam because we have a webcam. So there is a how-to camera. Don't worry, this is going to be like the last time you're going to be seeing this crappy Logitech webcam. I ordered a new full HD one just to give you a bit better quality right there. So there's the belt clip. This is the idle loop. I know the German word for it, but not the English one. And there is this is the motor side, and this is the side from the idler. So this one is wrapped around this upper pin, and the other one is wrapped around the lower pin, and they are actually just grabbing into each other on the belt teeth right there. So these slots right here are actually what keep the belts in place. So yeah, no, chat. I assembled this one just now. It's that quick, really. Trust me. So I guess what I'm gonna need to do is take these out of the clip right here and reinsert them with the proper tension. So it looks like this lower one right here is all fine. I should really grab a different lens on that one. I believe this lower one is fine. I'm just going to pull this upper one out, and I will grab some pliers for that, which are not included with the kit, so I'm going to grab my own. Wait, what did I just say? They're not included with the kit? No, they're not included with the assembled one. You do get pliers and a bunch of tools with the kit version. All right, so what else was I gonna say? Yeah, for everyone writing in chat, last time we kind of had the issue that ooh, wow. Okay, I see the problem now. Look at that. Okay, so one of these pins actually broke off. Okay, okay. Where did I put it? There. So, yeah, that is a bit of a problem. If this webcam would actually expose correctly. So that pin right here, that pin is gone. So unfortunately, we don't really have a closed belt loop anymore. Looks like I'm gonna have to reprint this part. You know what I'm gonna do? I am going to assemble the kit and then print this one as the first part. Grab the one from the kit. We could actually do that. Yeah, that sounds like a good idea. So let's do that. Super glue. Super glue. Sometimes, sometimes the best solutions are so... Where's my buttons? There's my buttons. Sometimes the best solutions are so easy. It might work with super glue. I'm just gonna try that before we move on. If this doesn't work with super glue, I'm just gonna grab the one from the kit, and then while I'm building the kit, print a new one on the Atom 3D actually. Super glue. There you go. So I'm just gonna grab the second one, the second belt out as well. Zip tie the ones together around the leftover pin. I could try that, but I don't think it would be particularly pretty or functional. I'm just going to see if I can zip tie this one together. Let's see if I can get you guys a wow, that actually works. Amazing. But you can't really see anything yet, but yeah, we are... Whoa, this one is coming apart at all the wrong places. Okay, so let's get some... I'm hoping this one is open already. If not, I'm going to have to poke it. Oh yeah, so this is a brand new bottle. Hey! Ooh, let's hope I'm not making a mess here. German super glue is probably awesome, super awesome. Well, it's... This stuff is from Megasonic Germany. This is straight up China import stuff. Ooh, that might have been too much. Keep super glue in the fridge, keeps it liquid. Good tip, thank you. Keep super glue away from fingers, keeps them from sticking together. So I'm gonna wash that off with some acetone in a second. Because even though if you wipe it off, you still get that smeary, hard shell on your fingers. I'm not going to wipe the table because I have no idea if that's going to dissolve anything. Okay, so you probably can't see all that much on the webcam. But I'm trying my best. Okay, this is not going in well. So super glue actually needs a very thin layer to work properly. That looks good enough, but it's still rocking around. Super glue needs a super thin layer to work well. And I'm not seeing this happen right here. I'm not seeing this thing fitting in properly again. So yeah, that is not going to work. Transport damage, yes, definitely. Yeah, I think Joe Prusa is kind of around somewhere. He might be watching, he might not be watching. Why is the camera switch not working? Oh, wrong window. He might be watching, he might not be watching, but they are definitely going to have to change these transport clips, because this wasn't even a super long trip. Like I said, 18 hours for shipping from Prague to here, which is like, for me, if I drive over there, it's a 3.5 hour drive. So if this gets shipped internationally, I think it would see some more, or some harder loads too. So fortunately, this thing comes off with 2 screws right there. Let's just switch this one over. So there are 2 screws that screw directly into this aluminum sub plate right there. So we should be relatively good if we just take the other one from the kit. And the other thing that I saw was that the front, LCD is loose. So there's a zip tie holding this onto these front bars right there, and that completely broke off, so that is just completely loose. We're gonna strap a new zip tie in here and we should be golden. So let me just grab this one for reference. This just slides into the plastic part and then wraps around the 2 M8 rods on the front here. I'm gonna really quickly grab some new zip ties, and then that thing is fixed, and I'm gonna grab the new one from the kit. That might have been really loud for you guys. If it was, I do apologize. I just grabbed all my zip ties, just to be sure, just to have the right one. And I keep banging the table. So these look like they might be just the right size. Might have an open bag of them somewhere. These are larger ones. Let's just use these. It looks heavy. It is actually surprisingly light if you compare it to other printers with that build volume. It's got some really thick plates right here. These are 5 or 6 millimeter plates on the back, and the okay, so that's not. I keep pressing the wrong button. Okay, this main frame plate here is around 5 or 6 millimeters, and the bed subframe, which you guys can't see right now, but is this plate that the heated bed sits on. That is made from the same material. I think they're actually cut from the same slab of aluminum on a laser or water jet cutter. It might be laser. It's probably laser. Yeah, so for the LCD up front, let's get it oriented back in the upright position. Right there, you can see this one is just completely broken off and loose. And if I zoom you guys in, there's these 2 zip ties that are just stuck through here and then get wrapped around the M8 rods and zip tied together. So that's going in surprisingly well. You know, for both of these issues, I think I can just blame. Was it FedEx? Was it UPS? I don't know. But I can blame the shipping company. Plus, of course, to a certain extent, the shipping design from Joe Prusa. I mean, of course, it is a fully built machine. It is a machine that is not like made with a full box frame, which would give it some superhuman strength, but you know, it's this relatively, you know, comparatively, if you compare it to a full-on box frame, it's a relatively floppy frame because it's only connected to the y-axis on 2 points. So it's got some nuts down here that basically just press against the frame. But once you set it on a table, it is a surprisingly stiff and surprisingly accurate machine. And of course, you know, having that relatively slender frame does keep cost down and, you know, build times, hopefully, for me. Okay, so those are 2 zip ties reinstalled, and that LCD display looks mostly super solid. There's some dirt up here that might have been from my fingers. Let's just wipe it off. There we go. And oh yeah, I know you guys love seeing this. Oh yeah, here we go. Probably gonna scratch it. How are you supposed to get this? How are you supposed to get this off? Come on. They assembled it with the protective film in there. Ah, there we go. Okay, this one is stuck pretty well. That was way less sexy than I expected. Apparently Joe's writing on Twitter. I should pull up my Twitter just to have an overview on that. By the way, cameras. That's really difficult. I'm at Tom's 3D Pre on Twitter, and I do post a bunch of stuff on there. So if you want to follow me there, go ahead. That would be awesome. Joe Prusa, I forwarded it to Tom Niels. All right. Yeah, how to install the belt is in the build manual, so there's a quick update from Joe Prusa. Awesome. Okay. Now that we have this one as fixed, one more thing I want to show you. So the zip ties right here. So these were, I guess these were, which side can I sit it on? So apparently these zip ties right here, can you see them? These are attached to the, oh, now I see. That doesn't do a whole lot. So over here, there is a zip tie that is tying the bed undercarriage, this part right here, to the linear rails right there, which should keep it from sliding around a bit. On the other side, it's a zip tie tying the linear bearing to the undercarriage, which doesn't do a whole lot, so that's not really keeping it in place. I guess that should have been like over here or over there somewhere, just so it grabs onto it. But in general, that probably was part of the issue why the belt clamp broke. So for anyone asking, the belt clamp is actually oriented, with the layers exactly aligned to how it broke. So yeah, that definitely contributed to it breaking off, but I don't think the design would have worked any better, or would have worked at all with the, with the print direction oriented any other way, or you'd just have to peel out tons of support material. Of course, you could design it differently just to have that pin strengthened a bit. Maybe just make it bigger. That would already help, or put a screw through it or anything like that. That would probably already be enough. A download? Someone just had technical issues, I guess. Well, that's not working. Okay. We got that, we got that, we got that. So yeah, I wanted to remove these zip ties that hold the bed in place. This one is mostly sliding around anyways. This one isn't doing anything at all. You see, you can just move it around like that. Yeah. Definitely something to be improved on, but so far no big deal. I'm just going to grab the new part. Of course, I mean, if this happened to you, if you were buying the assembled version, you'd get a new one shipped out, I'm pretty sure. Okay, so, as you can see, there was already filament inserted, so black PLA in the extruder already. It's a quick release, so once we heat that up, we can pull this out. And if you look on the bed, on the heated bed, there is already a part printed. So there's this base line around here, which I guess shows some of the belt tensioning right there, and the bed calibration as well. Okay, so it's got no belt, obviously, and this is just the wire dragging on the rear here. And that is, I mean, that is awesome how well it's working. So, or how smoothly it's rolling. So you can see this bed is relatively even or pretty evenly calibrated. So this one looks very, very smooth. And just to update you on what this printer does. So there is, wow, this one is tiny. I hadn't seen one like that before. So if we take a peek in here, let's slide you guys in a bit better. Okay, so we're now out of focus. Awesome. Yeah. So we've got a genuine V6 behind the sensor here. Again, this is just the real E2D deal. And then there is this tiny 8mm, 6mm. It's tiny. It is very small. And it is actually a, wow. I don't know if you'll be able to make this out, but this one is actually labeled Prusa. This little tiny sensor right there. So just to give you a comparison, that seems to be an 8mm sensor. I don't know where you'd find these. This is what, let's slide it out again. This is what a typical, this is at the same perspective there. This is the sensor on the i3, and that's what a typical sensor looks like. So, wow. That looks pretty nice and tiny. And what the Prusa i3 is doing is, let me just band this guy real quick. There we go. So what this printer does, it has mesh auto bed leveling. So it's actually, you know what? If let me there we go. Maker's Muse is now a mod. Just, you know, you can never have enough mods. So what this printer is doing, it's not only doing the traditional probe a few points and then, I keep pressing the wrong button, probe a few points or 3 and then like calculate a plane and adjust for that. This one is actually probing a bunch of individual points and then adjusting for each area between those. So it's not just for the whole bed, it's for actually for every little section like that. And then also, I believe it's these points right here. It's also compensating for misaligned axes. So for example, if you, how could you misalign this? You could have the z-axis tilted backwards. That doesn't, okay, so that's the only one that it's not covering for. But for example, if you have x and y slanted, so if you misalign the bed like this, it's actually got these probe points right there, or the screw points. I don't know which ones it's probing to. But it is compensating if you have a non-square x and y axis set up. So it's doing all that by itself. So before we move on, let's just get this one off. So there's your leveling indicator, more or less. This one is sticking really well. So the one thing I don't want to do is, there we go, damage the PEI on the very first thing I do with it. As your Prusa logo, apparently they changed the filament mid-print, so we've got the orange base coat and then the black on top. And then up front here, this is something I've been waiting for. So typically when you print something, when you have something like this, you'd set up your slicer so it does a what's it called, a skirt around the part where it basically, with a distance of 5 or 10 millimeters, lays down one line of filament to prime the extruder and hot end. And with this one, apparently what they're doing is they are leaving the skirt out, and they're doing a prime line up here, because this is not your real build area. This is just in the corner, and like that you only lose this exact area up here. And if you're doing a skirt, you actually lose, practically, if you want to fill up the build area, you lose that area all around your build area. So that is a very nice, effective, and reproducible way of priming your hot end. Awesome on that. All right, let me screw down a bit more here. Yeah. Chat delay, yes, chat delay should be a bit better. I did switch over YouTube to the low latency mode. Last time it was around 30 seconds delay from, basically the video feed was delayed 30 seconds. I would see the chat in real time, and then you guys would have a 30-second delay until you saw my reaction. So I'm hoping that's going to be a bit better today. Okay. So I have the search open right there. Okay. Am I going to compare the kit and the assembled one? Well, they're going to be the exact same printer. It's the exact same parts. It's just, one comes assembled. One's a bit more expensive. This one is $999, and the other one is not assembled. And you get to assemble it yourself. $739, I believe. Okay, so got that done. I did bang on the table again, right? Audio lag is doing a lot better. Yes. Let me just show you real quick. So I had... Now the webcam is not working. Why is this webcam not working? So I've set up this screen where I actually had all the video sources on, and then did the calibration right there. So yeah, that was my occupation till like 2 a.m. last night. I did try to get all the issues sorted out before I went to sleep last night. Okay, so Haribo Saftgoldbeeren mit 25% Fruchtsaft. 85 grams, so that's like a meaty-sized packet. Nice to see. Then we've, I guess he's just trying to one-up A3D there, including like those little tiny 3 gummy bear packets. Then we've got the spool holder. I believe this sits on here somewhat like this. I will need to consult the manual. Oh yeah, this is tight, and I'm assembling it the wrong way. So probably this way. Yeah. One there, one there. I should read the manual, right? Do I need a manual? There we go. So there's your filament holder with the 2 prongs sticking out, so you can just jam a filament spool in between there. We got glue stick. I guess this is one that Joe found out works well. PI actually works well for a whole bunch of materials. But of course, there's always going to be that odd one out that needs the glue stick. Then regular old power cord, actually the correct one this time, and a USB cable, which looks to be a really long one, and a solid one. That is nice to see. As well as a bit of little tiny accessories. Let's see, so we've got 2 alcohol wipes. I have no idea how long that's gonna last, which is why I have the big bottle right there. That definitely blew someone's speakers out. And we've got the SD card, so that is actually a micro SD, a 8 GB card, in an adapter that is awesome, as well as a fine acupuncture needle. I guess if you ever need to, you can poke around your hot end with that. Looks weak for a filament holder? Nah, it works. Other Wait, other direction? You're saying like that? That doesn't make sense. I guess you're saying like that. Okay, you could do that. But I believe it would work either way. Yeah, PI is not quite the same as Captain. I do agree with that. It is the same family of materials. It is roughly the same group of polymers, but it is not completely identical. Plus, the main difference you really see with PI versus Captain is the way they're sold. PI is usually sold in a thicker sheet that, you know, works as a unit, and it's got this slightly greenish tone to it. While Captain, you will usually get. Where is my big Captain roll? There it is. Captain, you will usually get in these thinner silicone adhesive things that, for me at least, like to come off the best. So these thin Captain films, they don't have the structure to really, you know, stay one, and then as soon as the print pulls on one corner, the entire thing comes up, while still being stuck to the Captain tape. Next with Tom does shots of booze and assembles the kit. I don't think that would go that well. So these two things, well, this one I can keep. The other one I will throw out. There goes the super glue. And for now, because we don't have the correct bed part, I will just move over to the kit, I guess. Captain is a pain to get perfect on the bed. Well, once you figure out the right technique, it's actually surprisingly easy to get, you know, to get evenly onto a bed. Is it only 6 kilograms? It does feel slightly heavier than that. Okay, but for now. Okay, so this box is definitely heavier than the assembled one. So for now, let's move on to the Prusa Research original Prusa i3 kit. Let's do it from this perspective. The other box for the assembled one actually didn't have any sort of lettering on it, which I guess means that this is really their kit they want to sell. This is their main product, I suppose. Real deal with the is it the Aria Dragon? I don't know. Open source hardware, Prusa3D.com. There's the URL, and this one is proudly made in the Czech Republic and packaged and assembled and printed on the Czech Republic. This is. No, that was not the case. So yeah, this is, like I said, again, this is the real deal from Joe Prusa. Let's see what we get here. Yeah, that was that one back here. That was not the kit. That was an assembled one. Joe actually sent me two, which is awesome. I did not expect. Apparently he wrote me, but still surprised by that. All right, so we've got. Zoom. Come on, zoom. What? How to hotkey. There we go. Another packing list. So I guess I moved this one over to the assembled one as well. Another packing list. Frame, press print number label, electronics box, fasteners, rods, tool, motors. All motors are labeled. I don't know why that is bold. Glue stick. So the same accessory pack like that. Power supply, European power cord, LCD heat bed filament, assembly guide, online manual. Yeah. So I guess what this is suggesting is the online manual. That's the one that you should really be referring to. Again, that is the one that has the iFixit style instructions on there. So I guess we should just start digging in. So filamentum addictive polymers PLA extra fill, whatever that means. Metallic gray, working temperature 910 to 210, 750 grams. Your piece of creativity is here. Nice. Then we have more filament. I do not know if all kits come with 2 spools, but the packaging. Let's get this out again. The packaging space does look like it's made for those 2 spools right there. So another filament PLA from apparently Prusa. This seems to be a tan color. Someone correct me if I used the wrong shade name for that. I'm sure I did. So there's packaging material. Oh, we don't need that. So these 2 I checked beforehand. So we've got the same 3D printing handbook we got with the fully assembled one, and we've got the assembly instructions for the 1.75mm i3 Mark II kit. I don't think they actually make a 3mm one. So again, there are your step-by-step instructions. You actually need to go through the entire thing. That will be quite substantial. Why does it have 2? GXS assembly. Okay, so it's chapter-wise. Okay, that's quite a bit to do. Butterscotch. Okay. Maybe. I'm just gonna take this one out of the box. There we go. So that is the color of PLA. I don't think they're including that exact color with every printer. It might be like a random choice thing, but... Ooh! Hold on a second. Well, what do we have here? Another box of filament. So at this point, I really don't think that much filament is actually included. Oval? Step 1, eat candy. I'm hoping there's going to be another bit. Oh yeah. Oh yeah. There we go. Eat candy. So we've got the Goldbeeren and we've got the Saftbeeren. So the fully assembled one came with the soft Goldbeeren, and the kit version came with the original Goldbeeren. So I kind of really want to have a look at how these filaments look. So this one is called Rapunzel Gold, or Silver. Sorry. Ooh. This looks like some next level stuff right there. It's got this weird ridge right there. We're gonna have to see how well this prints. This looks pretty fantastic. Probably out of focus again, but this is like a really silvery. It's almost like aluminum powder colored. And this is extra film metallic gray. Sugar free. These are not sugar free. Why do you keep saying this? So this one has. Okay, so this is the Czech version. Sugar, 77% sugar. And these are also 77% sugar. So don't get me with that sugar-free crap. By the way, Chad, while we're unboxing these things, where are you guys from? So, time zone wise, it would make sense that someone's staying up late in Australia, maybe New Zealand, Asia, Europe, all over Europe. Europe should be awake right now. Maybe Antarctica? I don't know. Where are you guys from? Just let me know. Robot. Yeah. That looks like the exact same color. Taiwan. Greetings. Wow, USA. That is some dedication. So that's gonna be at least like 4 a.m. or something. Holy smokes. Okay, 2 metallic silvers there. France, Netherlands, India. Wow. Greetings to my German homeboys. So as expected, a lot of you from Europe. I guess that just makes sense. Dallas, Texas, -7 hours. Yeah, that's again, that is some dedication right there. And Canada, wow. I'm constantly amazed by. So we probably missed Miss Joe's comment. I'm constantly amazed by how late people stay up to watch these kind of things. Serbia, well, I'd have to list out all the countries. That would be quite a bit of work. Planet Earth, yes, that is. I know that place. It seems to be like really chill at times. Okay, so we opened up that bar spool thing. Slept just a few hours. So we've got all the linear rods in here as well as the cable chains managers or tubes basically. Yeah. Yes, the power supply does have the mains pre-wired and a connector on there. Let me just get this one off. So it's got actually everything you need on there. Let me just show you a few details there. So zoom in right there. So we've got the Meanwhile clone or TLPZ. I guess that is also just your generic Chinese power supply. 12 volt, 20 amp, 240 watt supply right there, and then there's a IEC plug with an integrated fuse. Focus. IEC plug with an integrated fuse and an on-off switch. On the other side, the 12 volt output cables are pre-wired. They have some wire end crimps on there. That is awesome to see. So this is mostly just plug and play, so no dealing with mains power right there. Get that focused up again. Hopefully right there. That looks good. Okay. Linear rails. Are these stainless? These look like they're stainless or regular carbon steel. Hopefully hardened. That's going to be something that you're going to see in the long run. So let me see if I can get this stuff organized. So like last time, I'm going to keep all the raw materials over here. That's the Dynamo 3D crate. Awesome trash case. So your main M10 threaded rods, some shorter M8 ones. I believe that was kind of noisy. And all the linear rails. That actually was the one from the assembly one. Okay. Yes, the power supply cover is 3D printed. It is some of the best print quality I've seen on kit parts so far. Even the, where is it there? Even the load spot parts look worse than that. So, good job on that. I mean, print quality on 3D printed parts mostly doesn't matter. Because if they're designed well, they're designed in a way where you don't have to have like the super smoothest surfaces. But it's nice to see that the manufacturer actually uses his printers and tunes them in a representable way for the kit parts. Okay, so stepper motors. These are, I've seen this on the kit one as well. So these are actually Prusa Research labeled. Where's the focus? They're Prusa Research labeled motors. So I believe they're getting them like as a blank black motor and then laser engraving them. That is pretty awesome. You know, to have the motors custom labeled for Prusa Research and then the positioning for them. Awesome. So there's left, there's right. There's focus. Nope, there's no focus. There you go. Yeah, 1, 2, 3, and labeled motors. So this one is labeled Y, this one is labeled E, and the X. Yes, so we've got all motors. Z left, Z right. These look like standard sized ones. Probably around 40 Newton centimeters, and these are relatively small ones, probably like 28 or something. Should be enough. Should be enough. Okay. So that's a big box. Yeah, so the belt clamp is a screw down the center. Yes, the belt clamp with a screw down the center would be awesome. Now these motors right here, they are not custom made. You can actually buy them with what was I going to say? With a spindle already attached, instead of having the smooth shaft and then the smooth shaft with a coupler. So I believe these are the way to go for Z-axis, because you know you save yourself the coupler, you save yourself the hassle of having to compensate for any misalignments. They are always aligned properly right out of the box. There's no Z-wobble, no nothing. But I mean that they are a bit more expensive than just your regular motors plus couplers plus fitted rods. So let's see, because everyone's asking how much power this draws. 12 volt, well, it does not say. So this is the MK2 heated bed. So this is a one-piece bed, so you're not going to be using aluminum or glass or anything on top of this. This is just one solid piece of FR4, so the typical PCB core material. And then the heating traces on this side, yes, so side up has the heating traces in there. You can kind of see them underneath the PEI sheet. And the bottom is just a plain copper area with the thermistor taped on here. I would have liked seeing this one soldered on. Just, you know, add some solder points and have the thermistor soldered to the PCB and then the wire soldered, so you get maximum thermal transfer. But this should be fine, you know, aluminum tape plus Kapton plus the what is this, PTFE wire, I believe. Yeah, that looks good. That looks really good. Plus solidly soldered wire connectors right there, plus an LED. You know, Chinese kids typically don't use that much solder because it's kind of hard to do right. Okay, there is the heated bed. Now the main frame, extra PEI spare sheet, free gift, use only as a replacement. So I don't know if that actually comes with every printer, but there's your extra PEI sheet. We're not going to use that. It already has the one on there, so we're not going to put two on. That is interesting. So we've got another testing protocol. That is really... Let me just check that against the other one we got here. The solder does not desolder itself. Typically you're going to need past 200 degrees for lead-free solder, because you know you're not allowed to use leaded solder anymore. But I'm assuming this is lead-free solder. and that only melts at around 250 degrees, and you know, typically you're not going to push this past 120, so you should be totally good. Same with the hot end and thermistor connections, by the way. The thermistor connections are typically like way out from where the heater block actually sits, and the heater block just barely gets up to the temperature where the solder would melt. Plus, with the wires that far out, you know, I've always soldered my thermistors, no problem there at all. Okay, so we've got, this is the one from the kit, and this is the one from the fully assembled one. We've got a test protocol for the machine, which is interesting, because I'm not sure how you'd actually have a test protocol for a I'm not sure how you'd actually have a test protocol for a kit machine, for example, with stuff like x-axis movement, y-axis movement, and so on. I'm assuming, and this is just wild assumptions right now, I'm assuming and this one is done with a dummy machine where the electronics are basically connected to all the parts that would typically be in a printer and just get tested that way. Let me just label these off so I don't confuse them, but I mean they have the serial numbers on there anyways. Kit and the assembled one. Okay, so that is tested. Will I show the videos by setting the software? I will show, there's the official answer from Josef Prusa. I will show you the entire assembly plus everything you need to do afterwards, so that we hopefully get the first print out by the end of the day. Of course, I mean, the end of the day is sort of a flexible term, and I'm just saying that I got a happy printing signed by some, you know, I actually need to switch cameras. There we go. Happy printing with a, you know, signed frame. I have no idea what that signature is going to be. I do assume it's from Joe himself, but to be honest, sorry, can't read that. Okay, so we got the main frame parts. I'm just going to stack the heated bed on top of here again, just to save some space. Yep. Yeah, so because this stream is going to get recorded and put up as a video, and we're not going to have the chat with that, I'm just going to, you know, talk about like the main points that are being made in chat. So the machine is being connected to a dummy, or the electronics is being connected. Let's start it over. The electronics board is being connected to a dummy machine and then completely tested. So that completely makes sense to test it. I mean, a lot of printers you're going to get from China, they're also going to be called i3, will not even have their PCBs electrically tested because it adds cost. And why would you want to add cost? But this one, I guess, is as much tested as it gets, and especially for a kit that makes sense, because if you run into issues while assembling it, you don't want to have to look for where your issue is coming from. So external use, only 2 more alcohol pads plus a plus the, oh, that's out of focus. Why is that out of focus? That should be better. Plus the acupuncture needle again. So I'm hoping we're not going to be needing that. And here come the bags. Okay, so this looks much more like what I want to see in a kit compared to last week's Atom. So if you remember, the Atom had a whole bunch of ESD bags, gray ESD bags that you couldn't really look into, and then labels on the side, and it didn't have it sorted by theme, by basically how far you were into the build. It was, this bag is M3 by 8mm screws, and this bag is bearings, and that kind of made a quite a big mess once you actually started assembling things, because you'd have all the bags open, you'd have to sort your parts and look for them everywhere. So this one is, as far as I can tell, you know, of course not the tools, but so these are actually sorted by which step of the assembly you are in. So there's your there's your step number 2, y-axis. There is your step number 3, x-axis. And it actually lists out all the parts. That might be somewhat blown out. And what, guys, I'm actually going to turn down the aperture so that I don't have to refocus as often. There, okay, so now I should be able to just hold this in camera a bit better. All right. Yeah, so y-axis plus all the parts listed out. That is awesome. So I'm hoping that's going to work out well. So I am going to just, start each step and then open up only this bag and leave the other ones alone. That's pretty nice. Now that I turned the aperture down, let's get you a bit more light in here. There we go. So it should make up for it. I'm really looking forward to this build. And we've got one more box. And then the kit box is all emptied out. Yeah, Prusa. Prusa research guys do think about the people assembling them. The cool thing is the obvious thing is it's not the first printer kit there. Wow, that's bright. It's not the first printer kit they're selling, so it's they definitely sold the original i3 before, and of course collected a whole bunch of feedback with that, and now with the MK2, it's just gonna get better, I guess. ELE, electronics, y-axis, power supply and heat bed plus a few wet. What is this? What is this? I do, wow. Okay. So we've got these two things that look like they are filament, like they might be 3mm filament, but they are relatively soft. I think this is some semi-flex filament. I think these are wire stiffness that you feed along with your wires to keep them from bending out of place. And that is awesome. If you guys seen my how to wire your 3D printer, that is exactly what I recommend for you to do. But of course, I'm hoping that's what they are. I'd love to be right in this case. Okay, so that is the kit all assembled out. It really doesn't look like much. It doesn't look like a... Okay, you guys really can't see anything there. Let's switch back. It really doesn't look like a whole lot to assemble. It's your basic Y, X, Z axis. Let's sort that out a bit. Then the E axis, or extruder basically. Where's baggie number 6? LCD. Then you add like a handful of screws for the power supply, and then spares. So I guess these are if you like lose a few. These are spares, so we're not going to be needing that. So 2, 3, 4, 5 stop. Looks awesome. Okay, but yeah, that is going to be what we're gonna start on after we fix the assembled one, like we said. So let's get this. I'm running out of space for you guys. All right, let's get the extruder part. Let's get the one spare part, x-axis, y-axis. So it should be in here. It is not. Let's get this. Ah, there it is. Okay. I missed that. Okay, so there is the part we need in its full fresh glory. Yeah, that's the one that broke on us, and that's the one that we're just going to transplant to the fully assembled one and get it printing. They are printed in ABS. Yes, makes sense. Though that they are if you have a detailed look at these, probably. Let's see. There we go. These are printed rather fast, so you can tell the infill isn't really all that solid in the center areas, and it's sort of squished on the edges. So yeah, that kind of explains why they aren't that strong, but I mean, if they're strong enough, I'll just get this camera worked out so I don't have to constantly refocus it. That would be really nice. 25, or let's bump it down to 30. Okay, I might have to come around and increase the ISO. So they should be PET. Well, E3D actually print all their stuff in E3D Edge now, which is a PET type, which I kind of like. I mean, ABS does have its own flaws. It's mostly a very robust plastic, but it can be very finicky to get really good and stable prints out. So, but I mean, if you print ABS well, it's gonna work just as well. So, sub felt peanut probe. Not a fan. So, I'm interested here. Okay, so there's your genuine E3D V6 with the little Teflon tube pre-cut, fan, felt pads, wires, all very, very tidy in here. I don't think that was in here that big, but should be good. Handbook, assembly instructions. So let's grab the assembled one. Yeah, I think this part should be like the first print. As much as I want to print a frog, I also need that replacement part for the kit. I'm just not gonna have anything to assemble. Okay, so let's switch this one back over here. So the LCD is fixed. And I believe this includes some hex keys and stuff. Yeah, there's one, but I'm just going to use my own. This is an M3 screw, so we're going to need a 2.5mm key. Oh, there you go. Yeah, start the print in the background. That's what I'm going to do. Did you get the glue stick in the package? Yes, this glue stick was included with the fully built kit one, and I believe there should be, I don't know, there might not be one included for the kit version. Ah, so that is interesting. Let's grab the webcam. So over here, where's the lens? There is the lens. There you can kind of see it. So this over here is the part that we want to replace, and it actually goes all the way down to the heated bed. So there are these, you can kind of see them right there. So there are these nuts, these inserted nuts in the PCB, and that is actually what this part screws to. So it doesn't screw to the aluminum frame. It actually screws directly down into the heater PCB. That is interesting. Yes, you can still add glue stick to the PEI. In fact, stuff like glue stick or hairspray or 3DEs or whatever else you can pretty much add to any surface that isn't already like I keep pressing that button. That isn't like already a liquid-based coat, because that might come off. But if you've got like plain glass or PEI or Captain or whatever else, PET maybe. Oh, no. That's awesome. Now the part's stuck. That's great, but it's kind of not the way I need it. Yeah, awesome. Yeah, but you can add glue stick or hairspray or any of the liquid coatings to practically any surface. Yeah, some people actually reported honey to work, which seems weird to me. There's your two nuts, there's the replacement part, and I'm hoping I'm gonna... Which way was this on? I feel like it doesn't really make a difference. It does. I think it was on this way. Maybe? Okay. Assembly instructions. Should have it in there. There we go. There's the part, and we are orienting the opening towards the single bearing. So yes, this way with the solid part facing upwards. The only question is, do I need to print this in ABS, or will I get away with PLA? Yeah, so apparently hairspray works well. Well, depends. I've tried hairspray, and it didn't work at all. I've tried a few different hairsprays, and you know, one was working better than the other, but still not like really well. I guess it's like additives and whatever else they put in there to make it, you know, hair friendly and stuff. The one thing I can say that works well is 3D lac. This is, you know, obviously also a sort of hairspray, but it's branded as 3D lac, as a specifically made hairspray for 3D printing, and that stuff actually works extremely well. That stuff works on cold surfaces. It works very well on cold surfaces. If you only want to print PLA, you don't need a heated bed for that. You also don't need you know, any special bed coatings. These are sprayed on plain glass, and it works. But the one problem I found with it was you do have to sort of apply it before every print, so it does add a bit of an overhead to your workflow. But if you don't have a heated bed, I think that is one of the best ways to get stuff to stick. Okay, so I'm just going to eyeball this one because this side really doesn't matter all that much yet. Hoping you can kind of see what I'm doing here. No, I'm going to add the webcam in a second. Here we go, and then pull this one sort of tight, I guess. There we go. Let me just add the webcam over here, maybe? Over here. What component of the hairspray is most important? No idea. Not a chemist. That's sort of better. Okay, so that wraps around like this and then forms a loop. Now I don't think there's anything okay, now of course just set the camera on the assembly instructions. I don't think there's anything anything specific to this, but let me just check the assembly instructions just to make sure. Okay, so assemble the belt in the y-axis. By the way, you guys can follow this along on the online instructions. I believe Joe might be able to post a link there. I think those are the ones that I'm going to be following along, but I'm still going to have this one open to make sure, you know, you guys have sort of a reference where we're at. Okay, so we basically form a loop again right here, hold it with the pliers. Obviously you would want to do this in the partially assembled printer, but I'm not going to take this y-axis out right now. Form a loop, slide it down, then guide the belt around the bottom pit in the second picture. Okay, so I guess no other way of tensioning it. Can the motor be tensioned? No. So that's interesting. That's going to be the only way of tensioning this y-axis belt. Copper fill, bronze fill, and all that sort of stuff, yes, definitely works well. There's nothing you really have to keep in mind with the E3D brass nozzle. Stuff like carbon, I would be careful with, or carbon or Kevlar fill. That's something that's going to be coming up, I guess. Stuff like that, I would be careful because it can abrade your. Wow, that was surprisingly easy. Carbon can abrade your brass nozzle, as E3D have shown. I've got some manufacturers saying, yeah, you can print carbon with our brass nozzles, but I wouldn't really risk that because it's gonna wear out your nozzle in no time. Carbon is a really nasty material. I know if you try to listen to that. Wow, if you try to mill carbon fiber, you need specialized tools. You need specialized dust containment. It's really nasty stuff. Off. Okay, that is the belt tensioned. All right. I think we should be good to go. That's like, wow. Okay. We ship Tom Harden's nozzles to. Oh yeah. There it is. There is a Harden nozzle included. I do have one from E3D as well. This is a 3 dot, so I think it should be like the standard. Awesome. Okay, let's move on in the 3D printing handbook. Setup before printing. So printer assembly, we did that. Setup before printing, a zoom. Yeah, my minion didn't make it today, unfortunately. He was like, I want to come. And haven't heard of him since. But yeah, that's that. He was going to come, but didn't make it, like I said. Set it before printing. Place the printer to a horizontally stable position. Best place is the workbench where there is no risk of draft. So we've got that. Attach the filament holders to the upper frame. Let's just double check that. Okay, so the image is actually showing it with the filament in the back, so that's exactly what I'm going to do. And I think I should insert some filament right there, and I want this to be the filament that I want the holder to be made out of. So that would be, I guess, edge. Simplify 3D don't have that set up yet. I'm gonna use Cura just to stay open source. Chat, let me know which filament should I use here. I've got edge. I've got a whole bunch of PLAs. I've got polycarbonate, which would be probably a bit overkill for the first print. Nylon, T-glaze, Invent. Oh, this is Triton. Sorry. Triton. What's this? This is I believe this is in PLA. This might be the Invent. I've got some plain ABS. Edge. Edge would probably be my favorite. Well, which one should I use? Edge. That's E3D Edge. And that's my Twitter notification. engine. The orange one in the middle. Which one? This one? Unfortunately, that is, I believe that is Amphora. Just check. Yes, that's Amphora, but that's 3mm. Edge. Okay. So let's do edge. Now, I've got these filament holders set up so that I would just be able to, like, pull it down into a printer and these would turn, but just gonna take this one out. There we go. So, as you might be able to tell, that is not made to be taken out. Okay, so we've got E3D Edge spool works. This is Dark Crystal 12. Let's just pop this one in here. I'm kind of worried that there is no solid connection between this holder and the other one, but I'm guessing this is like on there as stable as can be. So this doesn't look like it's gonna come off. So push that in here. Good enough. Good enough. Turns well enough. Heat transfer with the hardened nozzle. Not a problem, actually. The heat transfer in the nozzle is so little that you won't really notice any difference between a brass or a hardened one. They're both, they're actually not that far apart as far as heat transfer goes. So not a huge difference at all. Okay. You guys want to see the printer, right? I'm thinking about where I'm going to put this one while it's printing, but I guess I'm just going to put it right here on the table, because I'm going to do something else while this thing is printing. Yeah. Okay. Files. So we are going to need. Joe sent me a link. Awesome. Joe already sent me the STL file link. Let's press a button and hope that works. Yes, that works. Niels, yeah. Niels hits it. That wow. He keeps sending pictures from the beach, as does my dad. So I'm here building printers. I mean, I'm enjoying it. But I could so use a beach vacation right now. So why belt holder? That's the part we need. Let's just get this one to wherever. Why belt holder? Now the other thing we're gonna need is a print profile. I'm just gonna check if it comes on the SD card. If I can remember where I put that. Let's Twitter again. Maybe just send me the profile. That would be nice. Nope. And drivers. All right, that is awesome. Life support at its best. I did warn Joe that I might need some life support, just because things tend to get a bit chaotic. But yeah, so far that's working really well. So let's switch you over to the site again. Okay, so drivers and manuals, version 173, most recent version for Windows. Calibration G-code should be all calibrated right out of the box. Cura settings, there is the Cura settings. So let's just get the drivers package. New Slick3R build. Okay, so I suppose Slick3R is still Linux. Okay, now here. I suppose Slick3R is still Prusa's preferred printer or slicer. Sorry. But yeah, that should be the latest one. Let's see what that does. Setup, yes. English. So this is the first time I'm seeing sort of a full setup package for a printer like that. Usually the manufacturer just gives you like a config file for your slicer and maybe says, hey, okay, use Repetierhorst or use Horst. Use Repetierhorst and then use this SlickThreer or Cure profile. But yeah, this looks pretty sweet. So we've got Windows drivers. We got okay, I better keep these checked. Utilities, and it's actually pre-configured for the original Prusa i3 Mark II. SlickThreer, yes, let's install that. Test objects, and Pronterface. Okay, yeah, install, let's see, backing up old settings of SlickThreer. Okay, so I've got, I'm hoping this isn't using the standard SlickThreer folder. Because that is linked over all my computers and does actually sync to my desktop as well. Isn't it just pronounced like slicer? Yes, it is, but I'm so sick and tired of having to... Why does this not work? But I'm so sick and tired of having to like say, okay, slicer, you know, not the one that's, you know, the one with the 3, you know, not just, you know, the family of software, just the slicer software. How do you differentiate between saying this is a slicer, because Cure is also a slicer, as is Scanforge. That's also a slicer, and there isn't only just slicer. There's also Cure. There's also Simplify 3D. So what I do, I say Slick3R. So whenever I say Slick3R, you know exactly what I mean. Okay. Plus, yeah, lead speak. It's ridiculous. Switch over right there. Welcome, software install. Okay, let's install the original Prusa i3 Mark II. So signed drivers. Wow. Open tutorials, open sample modes to print. Let's just see what the experience is like. Less awkward. I can also rotate my Zoom H4 so that you don't get that weird stereo separation. Okay, so there are all these sample prints, I guess just suggested STLs, model on Thingiverse. Yeah, okay, I don't need these at all. So there are the manuals that you can have. Okay, that also looks good. So I'm guessing, let's get this stuff out of the way. Wow, this is working hard. I'm guessing I do have firmware updater. Okay, so this is a specific one for the i3 for Prusa, I guess. Color print, swapping filaments during the print. That's exactly what we saw on the sample print right there. Does it require a Windows PC or is it OS X? It's actually OS X and Linux and everything else compatible. And then we have netfab insta. That's probably a translation error or wrong language. And we have the Prusa i3. Wow. So if you guys get audio crackling right now or anything, I'm sorry. I don't have like a monster PC. This is all running off of my laptop right now. Yeah, so this is the pre-configured SlickThreer from Prusa. So we got a few different detail settings. 0.2 normal, yeah, we're gonna use that, and also for finer nozzles. What's going on there? Oh, looks like I gotta ban someone. Yay! So the question is, if I report, does that also? Nah, that doesn't ban. That's too bad. Ban. Block. I'm hoping, yeah, so that's deleting. Yay! Yes, OS X, Linux and everything, so pre-configured thicknesses. Then we've got some pre-configured filament profiles with the colors. I don't think this is a standard slick-through feature. Now the closest one I guess would be, well, you know, Edge prints really well with just your standard ABS profile, so I guess that's what I'm gonna use. Prusa PET. I'm just gonna use the ABS profile just because it, yeah, just because it's really simple color print default. Prusa ABS, just because it's really similar to what the to what Edge requires. So let's get in here, reprint, and get the, what was it called? Y belt holder, this one. So that's that. No default? Use C-Hop profile. Okay, I'm gonna do that. Guys, I do read chat. Use Prusa i3 profile. Was that? Okay, so with Z-Hop, so that's the one we're gonna be using. Let's just check the print settings real quick. Layer height looks fine. First layer height, yeah, I'd usually increase that, but I believe the printer is actually really good as far as the Z calibration goes. 4 layers, 3 layers, top and bottom, sounds fine. 2 perimeters. Infill 10%. I'm actually gonna up that quite a bit to like 25 and make it honeycomb. Top, bottom, rectilinear, sounds good. And maybe even bump this up to 3 perimeters just to be safe. And this might actually change the camera. So, okay, it works fine. There you go. That we do need, and yeah, that should be perfect for this exact part. Okay, got the honeycomb infill going on, got 3 perimeters, top, bottom, shell, perfect. Put a good camera on print. Yes, I will actually put my my main camera on the print and keep that going while I do something else in the background. Okay, so filament is exactly 1.75. Yes, it is. This stuff is extremely precise. So we should be fine there. Now, I guess we're gonna use an SD card. We're gonna use the SD card, which I put somewhere. Unfortunately. There is a box. Okay. SD card, pop that in. No support? No, that should not need any support material, even though, what's the right button for this? Even though this has, you know, round corners, it shouldn't be an issue. Plus, Edge prints kind of well in that regard, so we should be fine. So let's get this over to the Prusa i3 Mark II. Wow, look at that. That's some test prints right there. So dual color Marvin Adelinda, that's the dragon on the package, I believe. Why do I have to keep banning people? V2 calibration. Okay, so we're just gonna save that as Y belt holder edge. Exported. Wow, you can eject those? I don't want to do that. Perfect. Yeah, Phil just wastes filament, but since this is going to be a part that is going to be sitting in the printer for, its entire life, I don't want to take any risks basically. So, yeah, 25%, whatever. Yes, I could use more mods. Okay, now let's turn this guy on. this out of the way and see if we get any smoke. So power switch over here, it is already plugged in. LCD seems to be working. And it is quiet. That is nice to hear. So the printer's powered up. It's not making any noise. Just turn this around a bit. It's not making any noise so far, which is awesome. And what I'm going to do is I'm going to move over here, rotate this monitor a bit, and hopefully not crash anything. Okay, Prusa i3 Mark II ready. That's good to see. So I guess we can just say... Well, okay, so one thing we need to do first, according to the manual, is to wipe this thing down with some alcohol. Which I am going to do. I did bang on the table again, didn't I? Run it through its self-test. I guess I should be reading the instructions, right? I just want to get a printout. That should be really nice and clean. And get this area in the front as well. Super fancy toilet paper? Nope. Just regular old toilet paper. Self-test kit only, so we are good right there. Set up before printing, AC power cord, firmware version. I guess this is perfectly fine. Self-test error messages, kit only, calibration. Calibration failed, bed leveling failed. Kit only, calibrate Z. You know what? You know what? I would basically say I am not going to back of the printing plate too. Nah, I am not going to calibrate Z because this the sensor and hot end assembly should be relatively close. So I'm just gonna go ahead and load some filament in and start a print and just see how far it gets and how well we're gonna do. So we're still on. Okay, we're still, nope, we are not. Okay, we are live again. So I had that coming for me. As you can see on this exact frame, I touched the capacitive power button on my monitor, which is also the USB hub for the second camera, and I believe the H4 as well. So I kind of just turned off half of my streaming setup with that. Okay, we're back. Let's go quickly rearrange my windows. Hold on. Okay, we're back. All right. Let's get this one over here again. So. Yes, I disappeared and I reappeared. It's sort of like magic, but sort of not. Okay, I'm hoping you guys can kind of see that. Let's get the webcam. The webcam might not see that much. The webcam actually does not work. There we go. You guys probably can't see all that much on the webcam, but it's better than nothing. Okay, preheat. preheat to ABS temps. Let's do that. So we've got a little LED light in the back here that's shining right underneath the connector. You can see that glowing right back here. And yeah, it's preheating. It is heating up relatively quickly. And there's the hot end cooling fan. Right over here. So that's, as the test report says, that turns on at 50 degrees Celsius. As soon as the hot end gets above that, works perfectly. There is a bit of a warning right there, caution hot. And I can feel the heated bed getting warm already, but it might take a bit to get up to the full 100 degrees Celsius. So while that's heating up, let's prepare the filament right there. I am actually not going for ABS on the first print. I am using the ABS profiles. I am doing the ABS heater procedure, but I am using E3D Edge, which is sort of like, you know, can mostly be printed on ABS settings, so that's exactly what I'm doing. So PLA is coming out really nicely there. And of course, you guys are going to see the exact inner workings. Let's clip you right to the heater bed. Camera shouldn't care. You're going to see all the inner workings of this machine as we're going to build the full kit version later on. I feel like I should grab some tweezers and pull that out. Perfect. You have to load and unload filament in the menu? Yeah, maybe. But I guess it works that way as well, right? There's the edge. Camera melting. It's just a cheap Logitech webcam. Print from SD. Now, if this print doesn't work, or it fails quality-wise or something like that, I do think it's not going to be the printer's fault. It might just be, you know, me using the ABS. Did it actually start flickering? I don't think so. It would actually be the profile not matching up with the E3D Edge we've got on the printer up there. I need to run calibration Z. Okay, so if Joe says I need to run the calibration, I guess I do better run the calibration. I don't actually want to mess up I don't want to mess up the PEI switches on the first print. Okay, Calibrate Z is located in the calibration menu, so let's follow that. So calibration right there. Move it up to the end stoppers, so I guess all the way up. Sorry Joe, live streams get chaotic. I guess that is why we're kind of nervous. So the printer is moving up all the way. Let's just switch you guys onto the other camera. If this would work. Okay. And in the meantime, of course, menu reset. So up to the end stopper. So I guess I should actually let the motor skip right there, so they. Bang onto these. Okay, click when. Whoops, sorry. Yeah. Click when done. Please clean the nozzle for calibration. Yes, we're gonna do that. So that is clean. Yeah, that is so clean. Are left and right Z carriages all up? Yes, they are. This one looks good as well as this one, so that's actually with these screws, almost. This one could go up a bit further, but we're gonna call it close enough. This one is they're the same height. Oh, okay, I see that they are actually this back here. That's where they're running against the. Where they're running against the screws, and the display reset while we did that. Yeah, people do not read instructions. I don't read instructions either. Most of the time. Okay. I should let it skip. Yes, I did let it skip, and it's all the way up. And now the printer is moving down. So there's that. There is the calibration running. It does sound somewhat rough. Like something's loose somewhere. We're just gonna compare that to what the kit sounds like. Better to do it hot. Well, it's not actually using the nozzle position. It's using the sensor right next to it. This guy over here. So that one probably doesn't expand at all. At least it shouldn't. Okay. So that was the calibration right there. Let's just check the manual if it says anything else. So calibrate Z. So the flickering is actually from the light. It's not the camera cutting out. Calibrate Z, moving up, click when done. Please clean the nozzle. Mesh bed leveling. So it is not necessary during the calibration process. So I'm thinking I do not need to do the mesh bed leveling. It is the same procedure which is performed before every print. Okay, so it does do that automatically. Load the filament. Okay, we did that. First layer calibration kit only. Don't need to do that. I don't know how much you guys can actually read, but well. Fine-tuning the first layer, we're not going to do that. We're going to go to a proper print right away and printing. So watch the first few layers, print to control. Okay, so now that should have, yeah. So saying now we can just print. Let's do that. Let's get into the menu again. Print from menu again. Print from SD. Wire belt holder, and of course now the bed has cooled down, so yeah, which means I am going to swap this setup around a tiny bit, and since it is 12:04 right here, which is, you know, supper time, I am going to prepare supper while this print prints, but like I said, I'm gonna have something for you guys to watch as well during that time. So let me just move the camera around. So ideally I want this one over here. I'm hoping, since this table is all smooth and solid and stuff, it should keep its calibration if I just slide it over here for the most part. This box out of the way. One and two. Just to keep you guys from getting nausea or something, you shouldn't have to watch this. And there is the B cam. So you guys should be able to follow along pretty closely to what the, well, maybe not. Maybe I should change the battery on this camera again. I don't have a power adapter yet for that second one. I should get one. Then I'm gonna have to reset the video feed. Yeah, that one's still frozen. I can smell the heat. Okay, it's going. Okay, I can smell the heat from the hot and from the heated bed. It's not. It's slightly. You know, it doesn't smell bad. It's just, you know, it's your typical PCB smell thing. All right, got that. So while that is heating up, let me check if I can get you guys a view on the LCD while it's printing. That should be good. There's the LCD. Hoping that's not going to get in the way. I don't think it should. Yeah, it's just a warm smell. G-code for auto calibration on the bed leveling. That is already in the G-code, I hope. Oh yeah, that is wonderful. That is well documented. Just while that's heating up, it's not all the way heated up anyways. Let's hide that. It's going to show you the start G-code. So first layer temperatures set there, then the bed first layer hot end bed temperature, then it's waiting for the bed to heat up, then it's waiting for the hot end to heat up, then it's homing, and then it's doing the G80, the mesh bed auto leveling 8. That's basically your auto bed calibration that that makes sure your bed is all smooth and calibrated out basically. The camera still looks kind of dark to me. Don't see? It looks like it reset. Sure wasn't what I wanted. So. Yes, I am using default ABS settings. Should be just fine for Edge. Should be just about perfect for Edge. Edge, like I said, Edge does print with ABS settings pretty well. That's how I printed it on all the other on all the other machines that I printed. That I printed edge on yet, and that worked pretty much perfectly. So yeah, you can see my creepy blurry face in the background there. So what the hot end seems to be doing is something that the knobhead suggested. That is actually piking the nozzle ever so slightly above the heated bed, which should form a plug in the nozzle and keep the filament from oozing out. So I'm just going to use the little webcam right there to show you. So there's the nozzle piked, and it's heated all the way, but there is no filament oozing out because the filament should harden enough against the bed to form a plug and keep more from oozing out. This camera sucks. There. Some hair on the belt in the middle. I do not see that. Oh, the lower one. There we go. This one. That might just be cutting residue. That's like, when you cut the belt, this is actually fiberglass reinforced, so the fibers do stick out, which is completely normal. So my question is, where do I best position this thing? I guess over here. Haha. Looks like the Harder needs a PID auto tune. 257. Here we go, 99 out of 100. Tension is real. Bed heating, yeah. So it's I guess it's got a cool down on the bed, how long it actually has to hold its temperature to accept a stable temperature reading. There we go. You see that? That is actually doing the auto calibration right there with a heated bed, which is awesome. Because these heated beds, even though they are thick FR4, or even though if you have an aluminum bed or a glass bed, they do ever so slightly warp and deform when they heat up compared to when they're completely cold. So there's your hot end priming procedure. That looks awesome. And there we go. That's printing. That is looking rather good. So of course, the thing is, edge is mostly transparent, so you're not going to see all that much. I hope that's as good of a shot as I can get you guys. All right. A higher angle on the camera, I don't think you're going to be seeing all that much if I actually lift it up further. Should have picked a better contrasting filament. Okay, yes, I could have used the green edge. That is true. Smaller aperture to get more in focus. Yeah, but you really need to see more. What about the kit? Yes, we are going to assemble the kit after this print is done. Just, you know, get this print out because I do need it. Ban Nightbot. Actually, so Nightbot is a service that I set up. That one is, I think it should be marked as mod or something, but Nightbot is my own service. I guess I should have mentioned that. So Nightbot does do some basic modding, or modding as far as moderation duties go, and also does do those cyclic messages. It is my service. I did set that up, and stream tip and whatever else Nightbot is saying, that stuff actually works. So yeah, if you guys want to, like I said, want to help me pay for Bratwurst, stream tip is the way to go, or Patreon preferably. That might be too small to see, but that's just right. All right, I am going to grab lunch. isn't that like soothing and relaxing to just watch a 3D printer do its thing? Only got a PayPal receipt? Wait. Nope, that's the wrong button. Okay, so the two stream tip donations showed up. I think that should have showed up somewhere like around there, this region of the screen right up there top. It should give you an on-screen gratitude thing. So thanks for the 2 donations so far, actually. Okay, lunch, supper, whichever you want to call it. I still need a plate. Have a fork? Well, I grabbed one. Okay, so the printer is looking excellent. It's pizza time. Well, I'm not in Italy. I'm in Germany. Actually, I'm in Lower Bavaria. So what we're gonna be having is Nürnberger Rostbratwurst, Bratwurst with sauerkraut. And Deviloi mustard and salmon. So I don't know if it gets any more German than that. And of course, I mean, since we are doing like 3D printer stuff here, I am going to cook those on my Cerberus Reborn heated bed. Let's just see how that goes. Power. Yes. Okay, so the bit of background on the Cerberus Reborn. So that is a custom Delta design of mine, and one of the core elements is its heated bed, which is a 650 or 600 watt. At least that's what it says on the heated bed. Silicone heater, and I did have it go up to like 200 degrees already, so it should be fine to cook some würstel on there. So there's one. There's two. Okay, now this one doesn't have an LCD, it has a smoothie board in there, so I could connect to it with Ethernet, but I do need to hook it up to my computer because I only have one Ethernet outlet down here. So let's do that. will need to disconnect the mouse. That's okay. Now let's see which camera blacks out when I plug this one in. None. Okay. Let's get this one connected. Let's just do here. Es fehlt das Weizen. Yeah, you are right. There is no Weissbier here. We actually don't have any Weissbier around here. Plus, of course, I still need to assemble the Prusa i3 kit afterwards. So, oh, I see Nightbot is doing its job. That's awesome. So apparently it is configured to it is kind of configured to quote Duke Nukem randomly, which I mean I appreciate. Yeah, you do see any emotes? Well, they got deleted. Nightbot is actually pretty quick on the delete or timeout hammer. So that's 3 emotes right there. Apparently that is okay, but if it's like any more than that, it will delete the message. I do see the message deleted. Little snippets there where the original message used to be, but I'm not sure if you guys can actually see that. So on the server support, I just turned up the bed to 140 degrees. Let's see what sort of maybe turn on the power supply. What sort of cooking power that amounts to? Yes, this printer will receive a review afterwards. I do still have to catch up on the Atom 3D 2.0 review, and yeah, that one I don't know if I'm gonna manage to do that one next week, but yeah, definitely coming up. Maybe in 2 weeks or so. Yeah. So this one is not heating up. I don't know if I set that correctly here in Kira. Let's see if we're even connected here. Oh, we're not connected. Why are we not connected? So that's on. I'm hoping I didn't mess up my Cerberus Reborn while I was gone. Blower not needed? No, actually it doesn't look like it's needed. The this fan right up here, this is the part cooling fan. It does not. Okay, now it's connected. The part cooling fan does not turn on for ABS as it should. ABS does not need a cooling fan. In fact, very often a cooling fan for ABS will be detrimental to layer adhesion. So yeah, for this one it's not turning on. I guess you could use a cooling fan for edge if you really wanted to, but like I said, it's really not needed at all. And if I could only get this printer to turn on. Sometimes the smoothie board is a bit finicky when it comes to wanting to connect. Actually, I think I do have a power meter on the on this room, but with all this stuff, I mean, this entire stream is running off of a 3-year-old laptop, so that thing draws like 30 watts maybe. The printing is around 200 or 150 to 200 probably. The lights are all fluorescent, so they don't really draw that much power at all. Maybe like 150 total. Hey, thanks for the tip. Thanks for the tip. I'm actually figuring out this is not real time for me. The tips are not showing up in real time, which sucks. Autofocus off. Yes, this is a completely manual lens. Now I'm seeing the tips. Why am I not seeing the tips? Alright, let's go through those. Like the show, very edutaining. Thanks for the €10 tip. From Anonymous, hi Tom, great channel. Did you ever try to use carbon enforced filament? I always wonder how much stronger it is compared to normal filament. Maybe this would be worth its own video. Yes, it would be, and actually I do have a bunch of different filaments. I do actually have a few different filaments that are carbon reinforced, ready to go, so I am going to try those. I just now got in some some hardened nozzles, so I'm not going to be ruining my brass nozzles while I try this. So yeah, that should be one of the next topics. The problem is just I've got so much stuff to do. I've got so many videos to create. Oh, that I can't really, make the ones that I want to make. It. There's so many reviews, so many videos that I kind of have to make. And carbon filaments are definitely one I want to make. I just don't know when I'm going to get around to. Okay, so a bit of a problem. This one does not connect all that well through the extensions and hubs. Why do you not work? Guys, I'm hungry. I'm hungry. Stream next Sunday? Yes, oh crap. Which cameras are still going? Is the audio still going? Okay, my monitor just went black. That's not a good sign. I'm hoping this is going to connect eventually. Stream next Sunday, yes. I do plan to. I do plan to give you guys a basics walkthrough of just showing you how a part is modeled typically and how the rest of the workflow looks like. Just something like 1, 2, 3D design or something, and then give the entire walkthrough of slicing settings, and everything on the printer itself when it comes to SD card or USB direct connection, and just make an overall Q&A sort of thing. Okay, so it appears we are connected now. 140, just 140, or 160. Let's do 160 degrees. Now the bed's heating. Here we go. So I do not have a I was gonna say I do not have an infrared thermometer down here. But I mean, we can feel it. Fusion 360 is Fusion 360 is like a paid program, right? It's not like one of the free to use things. Because I always keep seeing the hey, you can use you get a 1 year free trial of Fusion 360 with the printer bots, for example. So let's just see. Yeah, this is heating up now. Free for 1 year. Well, okay. So it is basically a 1 year trial you're getting. Free for makers. Okay. Someone suggesting FreeCAD. I tried FreeCAD. I seriously tried FreeCAD. I can't get used to it. I mean, I'm all in love with open source software and stuff. It's just I'm used to Autodesk Inventor. I've used that. I've used SolidWorks while studying. That was like the de facto standard, and I'm deeply in love with those professional CAD solutions. And I guess I'm just spoiled. But FreeCAD just feels like so extremely clumsy all over the place. Just setting up constraints for 2 lines took me like 5 minutes, and in SolidWorks it's just click, click, boop, there you go. The only problem with SolidWorks, of course, is unless you have like the super stripped down student version, it's utterly expensive. It's like 80,000 euros if you want to get the full package. So yeah. Printer, why are you doing this to me? Okay, so apparently I set up the Is that better? Okay, so here's the problem. Now I did set these up with hotkeys on the keyboard. So up here everything is like lettered out and correlating to which cameras I can switch to. The only problem is I put some of these on the number row. So whenever I hit 0, that turns off the auto mute. Whenever I hit 9, that turns on the auto mute. So I did just type out M999 to reset the smoothie safety features. So I guess that was my fault. So this seems to be getting up to temp really well. We are at. Oh, it does not. Oh, no. Okay, let me full reset this thing one more time. Don't use SketchUp. Yes, I do agree with that. I mean, I did try SketchUp as well, but it was like the worst. It's all over the place when it comes to the stuff you actually want to do. Onshape, I did try Onshape. I overall it feels like a super nice CAD tool and not a toy, not like SketchUp again. The only problem was it was super buggy for me. I tried Firefox, Chrome. I think I even tried Edge, but that was a mistake. It was extremely buggy for me, extremely slow, and I have a 50 Mbit down, 10 Mbit up connection here, so that shouldn't be the problem. I guess I do have to revisit it eventually, because it feels like a really good tool to use and like a really powerful CAD tool and not just a stripped down toy, more or less. I'm hoping I didn't change around too many things there. 4 is this button, which I don't know what does. If it does. So if I press 2, Yeah, Autodesk offers free student license for almost every product they have. I know, I've used them, but the problem with free student license is, you know, you get used to the tool, you start loving it, and then you all of a sudden don't have it anymore. So that's always something you got to keep in mind. And SolidWorks does the same thing, by the way. They give you student licenses or hugely discounted fuller student versions because they want to tie you in. They want you to use their software, and they want you to pay for it once you actually have a job that can afford those licenses. So that's always a double-edged sword. Yes, I need to eat, but I also need the Service Reborn to heat up. Because I guess it's a bit of my mistake. I did configure the new smoothie heat up timeouts, and I did configure them too aggressively. So right now it's keeping me from heating up the bed to the temperatures that I want. Okay, but it seems we are at 140 degrees, so let's go up to 160 degrees. So by the way, the recommended temperature, does it say on the package? No. But the, you know, Grill Pros basically tell you, okay, the recommended temperature for sausages is around 150 degrees Celsius. So I'm heating up the bed to 160. Like I said, this thing has done 200 already. I'm heating it up to 160, and I'm hoping that should be enough to get these brown. Okay, we're at 160. Let's see if this works. Unless I cut myself, of course, but well, that doesn't look too promising. That is, I mean, you can't feel the heat, but it's like, it's not sizzling. Nope, it's definitely not sizzling. So let's turn that up some more. Let's do 180. What was that question? Those do look tiny. Yes, they are. I mean, of course, perspective, but that's a small pen. These are Nürnberger Rostbratwurst. It's kind of, you know, our sort of sausages. You know, you can't have more of those. They're smaller. You know. Pan not touching the bed. Yes, yeah, it's not the best pan, I know. And that Nightbot reminds me I should go refresh the Steam tip page. And Max, thanks for that €1 donation. I really enjoy these streams and your socks with sandals. Yes. Actually, my camera's gone. Beacon, that should do. I'm on screen cap. Hold on. I pressed the wrong button again. So we need to go back to Beacon. There we go. Okay. Socks and sandals. I'm wearing blue socks today because everyone was complaining about white socks with sandals last time. So I guess blue is sort of better. I'm hoping. As well as Duplicate, thanks for the €17.86 donation. Small donation to keep ever growing workspace and studio. Yes, there is a lot of stuff going on here. and I feel like I'm getting good use out of it. Okay, it's hot. Okay, so the sausage part over here, it's not really. Oh. Okay. Okay, that's not what I want. So, you probably can't see it underneath there, but there was just a huge bubble coming up where the heated bed separated itself from the aluminum plate, so that bed is gone. That sucks. I don't know if you heard it, but it was a sound like there was some water boiling somewhere, and that was the adhesive bubbling up. So that experiment just failed, unfortunately. I'm gonna have to call this one quits. This bed is fried, and it does smell. So yeah, that kind of sucks. But by the way, another version. Yeah, that was it was about that size of a bubble, which just bulging out to the bottom, and okay. Fortunately, I mean, I did show this one last stream. I do have another heated bed, spare. They sent me to for whatever reason. So I'm gonna take this one off, put a new one in, and then maybe try it on the bare aluminum next time. So. These are, I mean, these look dead. So what I'm gonna do is I'm gonna head upstairs. I'm gonna fry these on the stove like a normal person, and then I'm gonna come back here and basically have lunch with you guys. So I'll be right back. I'm gonna leave you with the printer, and hopefully that thing doesn't finish. Nah, it's not gonna finish before I come back. And I should open up a window, because burnt silicone heated beds don't smell nice. Who would have thought? Alright, so I'm gonna be back in 5 minutes or so. Don't leave. Don't leave. enough. Yeah. No Weizen, just the black gold. Okay, quick update on... Where's Tom gone? Where was I? So a quick update on what's happening here, just to recap. What happened so far? Now, this is the Prusa i3 Mark II genuine model from Joe Prusa, and I can actually see the print better on screen than I can from over here. So there seems to be some stringing going on, but that is okay because this is completely the wrong print profile. This is the standard ABS profile printing E3D edge. Yes, it is printing too hot. But that's okay. I'm just gonna leave it going like that. We are printing a replacement part for the... Did I not turn this off? We are printing a replacement part for the kit version of the i3 Mark II. The printer you're seeing in front of you right here is the pre-built one. Joe Prusa sent me these last week, or this week, or last few days, and he sent me two machines. He sent me one completely built one, this one, and he sent me one complete kit, which you can see in parts over here on this end of the table once I get this printer out of the way. The assembled one unfortunately had a broken part that we are reprinting. Using the part from the kit as a spare for now. So the part in here is the one from the kit, and we're printing the spare for the kit to replace that. So this one came ready built. This one came completely ready built, ready to go. Only thing we had to do was to do the calibration, and that was it. Or the automatic bed calibration. That's what we wanted to say. That was it, and now this is working. So, like I said, this was completely built. The kit we're gonna build after this print finishes, so that I can get this printer off the bench and use that space for the actual build of the i3 Mark II. Yes, the print does look stringy, but like I said, we're using the wrong settings here. What's it, by the way, for everyone that's eating along? Yes, the fan up front here, this is the part cooling fan. This one is not spinning because, yeah, it is using the ABS profile, and typically you don't want to use a fan with ABS filament. I guess we could use it for the edge, but like I said, it's fine. Yeah, typically E3D Edge doesn't look that stringy. It is. PT is always going to be a bit stringier than ABS, but it's Edge. Like I said last stream, I think E3D did an amazing job with making Edge print as well as they did. No, I did not use a FlashForge DreamerYet or any other of the FlashForge clone machines, basically, or the original designs. I did review the Malian M150, which is like a super cheapo Chinese i3-ish printer, which didn't fare that well as expected. It's like a $250 machine. But for any machines that I have not tested, I can't say anything about them because obviously all the information I have is the data sheet and information from other users, and unless I test it myself, I don't really have anything reliable to speak for or against those machines. Yeah, so PEI tape. This is what's using. This is using This is using a PEI sheet on the bed. Mine came with a spare. Right there, that's what it looks like right out of the box. If you would apply it, it's got the 3M468 transfer tape on the back. Plus the thicker PEI sheet on the front. The bed comes pre-applied with the PEI, and yeah, PEI in my experience requires a heated bed. So for it's scrolled up so far. I don't know who asked it, but whoever asked if for a printer bot simple you should be using PEI. Well, yes, but only if you have a heated bed. If you have upgraded to a heated bed as well. If you did not, then PEI is not going to give you any sort of adhesion at all. So there's a bit of a better overview of the machine. Ooh. I'm just noticing a nice detail. It's a direct drive extruder. It's got an original Prusa i3 motor on there. And yeah, so question, Edge review release date. I really can't talk about release dates because like I said, I got so much stuff to do. Heated beds cheap on eBay. Well, the problem is cheap heated beds often suck. So what is it? I had like a dual heated bed somewhere with the original red Prusa PCBs. Just really thin 1.4 millimeter. Rip? Why? What happened? Did anything happen? I don't know. The thin PCBs really like to bend and warp. They don't really have the power to really heat up your heated bed to any decent temperature in a decent amount of time. So it's typically going to take like 20 to 30 minutes to get to 110 degrees. But the worst part about them is they bend. Because they are so thin and they often use cheap FR4, they really like to flex as they heat up. My first printer, a Prusa i2 that I built for myself, that was the first machine I built for me. That one used a really cheap bed with glass on top, and it had a 3mm glass sheet on top, and it still bowed down for just the heating of the first layer, and then bowed back in the opposite direction for the second layer, that the first and second layer would actually separate. So it took me a really long time to figure that out. After a while, I actually measured how much that bowed, and I think it was like 200 or 300 microns back and forth. So just from one side of the heated PCB heating up, it flexed that much. So the one thing that I can still recommend is silicone heaters on aluminum. That's the one thing I know that will always work if you get like good milled aluminum, or for smaller beds, just like the metal lining. Just get like a cheap rolled aluminum sheet that will work way better than any PCB plus glass on top or anything. I actually can't read that. So that's on 87%, which means we should be coming up on the kit build relatively soon. So that I can move this thing out of the way. Hunted on the bed might cause some rather strong adhesion with edge. I was worried about something like that. We're gonna see. I'm gonna let it cool down. I'm gonna let it cool down all the way, and only then try to remove it. Like I said, this is the ABS profile. So the heated bed did get a bit warmer than usually you'd print edge, both on the heated bed and the hot end. Yeah. So the question that came up was, is it a V6? Yes, it is a genuine E3D V6. Again, just to point it out again, this is the real deal i3. Not anything that you'd get from China that is also called an i3, but it says, it even says on the freaking stepper motors, this is the genuine original Prusa i3 Mark II from Josef Prusa. And it also contains that genuine original E3D V6. It's even the newer version, which I believe is going to be called the E3D V6.1, which uses cartridge thermistors. I can actually show you on the camera there. So this is what that might be somewhat small, but that's what the new thermistor assembly looks like. So there's just a small set screw on the bottom right there, and then the thermistor cartridge popping in just there. No more screws plus washers plus all kinds of stuff. It's just one steel or stainless steel cartridge, just like the heater. It slides in, gets locked in place, and then boom. Release date for the new E3D V6. I don't know if I can talk about that, but I know if you buy an i3 Mark II, you're gonna get one. I mean, it might be the most expensive hot end you've ever bought, but that's one where you could acquire it. They might actually be shipping it like that already. I don't know, ask him. But that's definitely like the next iteration of the E3D hot ends. Rumored silicone cover. I know they exist, but I don't know how much I can tell you guys. I definitely know more than you guys, but I have no idea whether E3D are gonna butcher me for that or not. Like we're 94%. So screw-in thermistors, there is a problem with them. The thing is, a screw-in thermistor is not a screw-in thermistor, it's a screw-on thermistor, and very often it's just going to be like a basically, you know, a thread on the end that just holds it to the piece, and then this block on the outside that just has a traditional thermistor potted in. So those will often get you wrong readings, more or less, because the block on the outside cools down so much more than the heater block, which is aluminum, then the block is brass and often has a bad thermal transfer. I'm really not a huge fan of them. Plus, it's kind of hard to find ones that are really going up to the high temperatures that you can get with a traditional thermistor or the PT100 sensors. So can you upgrade? Let me just check my EPE box. So this looks like a traditional V6. Let's just compare that to the other one. So the heater block has become a bit longer. So obviously that is a used one. The heater block has become a bit longer on the new one. And that extra length is exactly where the thermistor sits. So it might be pretty hard to really get it at the exact same spot. The one spot that I could see where the new thermistor cartridge would fit in would be right above the, so there's the heater cartridge right above the heater cartridge right there. But then again, you do have the issue of how do you fix it in place. It might be rather difficult. Of course, I mean or just get the upgrade kit. And that new cartridge system gets you the option to upgrade to a PT100 or a. Please make screen bigger. I would have to move the other camera closer in again. I'm gonna do that in a second. The cartridges do allow you to swap up to a PT100 or a thermocouple or any other temperature sensor. They do sell them in the same form factor, so that's an upgrade path you're opening up with that. This is a 3-bearing X-axis. The bed is also 3 bearings, so yeah, that's the best I can do camera-wise for now, and we're done. So let me just show you around the print real quick. Am I still zoomed in? Oh, okay. So there is the print finished. How-to buttons. That's the first one, so we can move the camera away. There's that print. It is rather stringy. Yes, it was printed with temperatures that were much too high or slightly too high for edge, plus retracts and stuff weren't really calibrated, but it does look solid nonetheless. That's exactly what we were going for, right? Focus, there we go. So yeah, surfaces do look a bit rough. Again, I'd blame that on the temperature, but it should be very usable. So Joe advised me to just leave this thing and let it cool off on its own before we start trying to tear it off. So that's exactly what I'm going to do now. Yeah, more retraction, I know, I just used the ABS profile. Okay. Removing it from the print will be interesting. Yes, it will. We're just gonna have to see how well that goes. Okay. Faster retraction is better always? Pretty much. Okay. Just use a hammer. Yeah, I don't think so. So yeah, these, I mean, people commenting these standoffs will break off. That is exactly what happened with the. Nope. How to buttons? I don't know how to button. That is exactly what happened with the one that came in the kit. Mouse not working. Okay. That's exactly what happened with the kit, but I think, or in my experience, the E3D Edge does have much higher layer adhesion compared to ABS. So this thing should hold up no matter what. PTG sticks to cement like the MK2. Yes, that's kind of what I'm worried about as well. But we're just gonna have to wait and see. Okay, so I was trying to switch cameras. Frequently answered questions display. Yes, that would be nice, but who would manage that? So I'm just gonna put this one in. Whoa, I'm not gonna move it. I'm gonna put it in the corner. Yes, I know I could be using studio mode and not do this live, but hey, why not do it? Why do it off camera when you can do it live, right? There we go. There's a bit more brightness for you guys. All right, it is after all sunny outside. If I look out the window. Okay. Yes, I did print this. I did build this print in less than 15 hours. Okay, so let's move this one out of the way. I believe the hot end should be cooled off. Wow, that power supply is hot. Or at least it's sort of warm. So it's at 60 degrees, which means we can turn this thing off. The edge is not going to jam up in there, and even if it does, we can still pull it out. So we can move this printer out of the way. Wondering how much can you actually see? Okay, you can see the olive oil bottle over here. Just move that out here. So it's out of the way. Yes, I did not even start to build. I did want to figure out the stuff with the assembled one first, just so that we, wouldn't have anything to go back to and leave unfinished afterwards. Okay, so this is like the official. You won't have a problem. This is like the official start of the build right now. Okay, so if you want to time me, I believe I am going to take a bit more than the 4 or 5 hours that are estimated because I have you guys to take care of, But yeah, and I purposely didn't. Well, I didn't have the time. I did not prepare for this build too much. I did have a rough look over the instructions, but I didn't read them and memorize them by heart yet. So let's get into it. So step 1, all the tools are included. That is great. So we've got the tool bag over here. Let's open that up. No soldering is required and no wire crimping is required. That is awesome. I mean, I wouldn't mind crimping. I wouldn't mind soldering. But I would look at a kit manufacturer with a bit of a, give him a bit of a weird eye if they would require you to solder on a printer kit. So yes, 3.5 hours in. Let's start. I mean, I did the full unboxing and first print on this one. That's not too bad, right? I've had unboxings take longer than that. There's your ball and hex key. There's an extra set of smaller hex keys without the ball end, and that is it. So we've got some small needle nose pliers. We've got a small screwdriver. Let's move you guys over here so I have this camera as like a detail cam, what I did with the webcam last time, more or less. And maybe turn on the exposure a tiny bit. There we go. That should be in focus. Okay, 2 wrenches, 13 and 17 millimeters. These are going to be used for all the threaded rod connectors that are going to be used for basically the bed undercarriage, Y-axis subframe, and yeah, screwdriver for screw clamps, I suppose. Okay, so this is kind of cool right there. We are horribly out of focus, I believe. You can. Yeah, look at that. Focus. So I keep buying all these lenses with like f2.0 and f1.7, but I guess it just means we get no depth of field unless I step them down anyways. So there's your, if you've ever built Lego, that's gonna be something you guys will appreciate. So you get the sheets on your labels, on the packaging labels right there, and those basically are your references for what the individual parts look like and what they are. So they've got the names and the sizes in a 1-to-1 scale right there. So that's awesome. Thumbs up. Critical parts like zip ties have a spare included as a backup option. That is good to see. Switch that over. No need to worry if you mess up during the assembly with the extra parts added. That is nice. So of course zip ties you can't reuse, but nuts you can unscrew and redo. Zip tie you do have to cut off. So there's a spare bag included. We did have that one out before. That's belt piece. This is no. It's somewhere over here. So there's an entire spare bag. Nut insertion tips. So if you want to get your nuts in properly, if you want to get them in as deep as you can, then you should put a screw in them and push them in basically backwards. Good tips right there. Thank you. Perfect screwing tips. I can use those. And of course, if you want to view the high resolution images, go to manual.prusa3d.com and you guys can actually follow along. Where's the URL? There, up here. You guys can actually follow along on the Dozuki guide right there. I put the spares under the bench. You might be right. So the first step is actually step 2. It's the Y-axis assembly, and that is bag number 2. So I'm really starting to like. I'm really starting to like the assembly so far, because like I said in the start of this 3.5 hour long unboxing, you do only get the parts you actually need for that step. So this is step 2. It correlates with the manual, and you've got all the parts for that step 2 and only for that step 2 in there. So you're not going to be, you know, digging through bags of parts and you know, have everything out there. You only have the stuff you really need. Get the necessary tools. We need these two, we need this one, and we need the hex spanners out of the box. Get the 3D printed parts, and it's the same on the 3D printed parts actually. So I love Nightbot. So same on the printed parts. There's the spares bag. We've got baggie number 2 that has the printed parts for the Y-axis assembly, and only for the Y-axis assembly. By the way, I did miss a tip on stream tip from Brian Welch. I woke up early for a run and happened to see your Twitch or tweet. Okay, this printer I was thinking about getting, so I will be watching you most of today. Also, your lunch looks delicious, even though it didn't work out on the 3D printer. Yes, thank you for that. And thanks for your donation. I'm hoping that's going to get me through the build and keep me powered up during the rest of the stream. I'm hoping this is not going to be like another 15-hour thing. Okay, so we've got 4 identical y-axis corners. I mean, we can always take a look at the assembled one for reference if we need to, but I don't think that's going to be necessary. And I'm going to try to build it with as little cheating as possible. Okay, so there's all these parts, and there's one part missing, and that is the exact part that we're going to need. That is the Y belt holder. So let's see if this one is cooled down already. I can hear it coming loose. So we need to get this one off the bed before we can start printing. Is it important to sniff all the parts? Yes. Yes. Oh! So how am I supposed to remove this? Is it stuck? Yes, it is. I was warned about this, but a bit too late. Actually, only after the the first few layers were already down. So okay, so as I can see the edge lifting, I am going to grab this thing. These are sold as Japan spatulas, more or less. That's good. So you don't want to cut into the bed or want to actually get your peeling tool digging into the bed surface, because that's gonna ruin your PEI sheet. These things are not that solid, even though they do last long if you take care of them. They won't stand up to as much abuse as a sheet of glass or just a plain aluminum surface with some sort of adhesive on it. So that came off really nicely, and there is, well, I can feel some slight marks on the surface, but that might just be residue from the print. So we're good there. So we've got our spare part. No special included. There might be one included. I'm not sure. But to be honest, I rarely use these specials. Spare PI sheet is €8. That is incredibly cheap. Thumbs up for that. So that might be an option for you guys looking to get a PEI sheet for your own printers. But I typically don't use specialists because, you know, if you tune in your print settings right, it's going to come loose as the bed cools down anyways. So there goes my coffee. So we are going to need, for the y-axis, rods. So basically the support for the y-axis, the long M10. Drop that, okay. The long M10 rails. Okay, so these parts aren't labeled, but I guess you can figure out what they are, even without the without any sort of label on them. So M10 nuts. Let's dig in here. These are actually flat nuts or half-height nuts, as far as I can tell. Because obviously you aren't going to tighten them to the full spec torque, which would be quite a lot for M10. So you don't need the full strength of the full height nuts. There's your nuts. Really, really flat and squishy, but also rather large because they are M10 after all. Focus there. Oh, look at that. I've got my dumb troll. Dumb troll is actually being really helpful right now. So there's your Q&A module. Bother dumb troll if you if you're seeing recurring questions, he might be able to answer them. So use the M10 nuts, M10 washers. So all the nuts, all the 14 nuts. So that's, again, I love that about prepackaged stuff. All the nuts, all the washers, and the two M10 rods. And place washers, Y corners, and PSU Y parts on the threaded rods as shown in the picture. Okay. Okay, so let's try that. And actually, it's blocking the view of your build. What is this? Okay. Why is my mouse not working? Thanks for the input. I'm actually going to move that up here because we don't need that down there. I am going to pull up the high-res instruction manual for the MK2. Again, that's what was it, prusa.com/ or manual.prusa3d.com, because these images in here are a bit too small for me to reliably make out, for example, which way these should be oriented. It might be this or this way. I believe it is with the nose sticking out to the end, so like that, but I do not know for sure, so high-res images it is. And what's actually kind of cool is you get the, let's switch you over to this one again. You actually get, that's F5, okay, so that does refresh at the same time. Yeah. So you actually get the image, the finished high-res image of what it should look like when it's done, and I think that's all I'm gonna need to build off of. You know what, Joe? I'm gonna make you mod, so you should be able to post full links. So yeah. The design file for these are open source, yes, and not just some fake, hey, we're going to publish them eventually, or non-commercial licensed open source. This is true, real, 100% open source to the core. I feel like I should actually use my cordless drill for this, because, you know, screwing on all these nuts might turn out rather tedious. Sure, between a washer after counter nut and the y-axis corner. Okay. Light 6? No, it's a full V6. Okay, I'm gonna grab a cordless drill, even if it might be a bit noisy. Again, this video is not sponsored by Bosch. I mean, if anyone from Bosch is watching, feel free to sponsor me. But I just like their tools. Okay, I'm on the search window again. There you go. Please go step by step. It will save me a lot of time. Yes. Screw the nuts on and place washers, Y corners. I will do that. I realized on the Atom 3D, it actually, print just came off the bad noises. I did actually make that mistake on the Atom 3D build, and I assembled quite a few things wrong. So I'm hoping I'm not going to make the mistake again. So chat, please let me know if. Am I missing a step? I don't think so. Please let me know if this thing is too loud for you. I can mute you in the meantime if it's really bothering anyone. That's satisfying. throw the manual away. I'm definitely not going to throw the manual away. It is rather necessary, or rather helpful to have one. So there's the two. Then on one side we're going to add one more nut. Make sure you don't forget a washer. Yes, there are two washers in here. We got the nut and the washer and the black part, like that. And another washer and a nut. So basically under, nope. No washer there. We're gonna need a frame corner right there. So I'm gonna take a peek at the finished one again. These are four identical ones in these, but okay. So these two fit together. They fit into each other basically. So there's a little ridge there, and this one butts up there. And you also need to make sure that these are oriented correctly. So actually, exactly the other way around. And on the back here, one nut. That stuff just fits together really nicely. Cheating? Yes. That's cheating. I know. Using a cordless drill is definitely cheating, but I honestly don't care much. I've assembled so many threaded rod frames by now, I can't do it by hand. It's just too tedious. So the question is, does this need a... make sure there is no gap between the parts. They have to fit together, so they do. They fit together exactly as shown. And then I guess we're going to tighten. Do we have to tighten these up already? I'm just going to tighten these up so they are snug. And if they come loose, we can always retighten them afterwards or readjust them. So this is not like so tight that they will actually deform or break. So we need one measuring tape to adjust the distance between the end of this orange part right here, the y-axis corner, and the first nut after the first washer after the double nuts. I'm slightly out of focus, ain't I? There we go. So this distance from here to here needs to be 100 millimeters. So I am going to get a measuring tool and do that precisely. Okay, so there's your precision measuring tool right there. Nah, just kidding. Calipers. That's what we want to use. So let's set those to 100.0. I don't know how precise this needs to be since the Mark II does have that sweet. Oh, I'm way off. Does have that sweet auto. What is it called? Auto squaring feature for X and Y basically. So if you mess up on these and actually build the frame slanted, so with no right angles between X and Y, it should correct for that. And logic tells me the correction for X and Y should actually be much more lenient on the sort of artifacts it creates. That was probably the wrong word, but it should be much more effective in correcting for those imprecisions than even something like bed leveling or z-axis correction. Essentially, it's the same thing, because you don't have a hot end that you end up putting at an angle. You're just moving the x and y motors accordingly. You know, essentially I skipped to step 10 already? Come on, nah. Essentially, you know, the auto axis calibration is just a more refined take on core XY or HBOD geometries. And they are doing pretty much the exact same thing, more or less. All right, so this is as precisely as it's gonna get. So these two are locked. Let's get the next one. So I guess this is one of those tedious steps that you're not really looking forward to, but you have to do. Tips are working. I guess if you're saying that, I should double check the stream tip page, because that thing doesn't auto reload. There we go. All right, so wow, did I miss a few? All right, Army Gunsmith channel. Thanks for the hard work. Please keep it up. Enjoy the beer. Oh, I don't have beer, unfortunately. I don't have any beer in the house, actually, so I'm gonna have to disappoint you in that one. Then Martin Anderson, 5 years. Thanks for that donation. And Raymond Clark, did I read that one? I do not know, but thanks for that as well. Always appreciate it. Always helps me stay stocked up on bratwurst, and unfortunately no sauerkraut today, but yeah. Okay, so questions in the chat. Are these M8 rods? No, these are M10 rods. The y-axis actually uses M10 as a structural part, so this is going to hold the frame right there. So imagine these like that, and then the frame is going to get jammed between these nuts. It's going to stay upright. There are some M8 rods that are responsible for, you know, some minor structural things. But the actual z-axis is using proper linear. What am I saying? Is using proper spindles made for linear motion, so not some threaded rod, as would be typical for a printer that's called a RepRap. But they're the real deal. I can pull one out here and show you. Just to the side. So these are integrated stepper motors that have the. Let's just put that over here so it's in focus, sort of. So these are motors that have the spindle integrated into their shaft, basically. So they don't have a separate shaft and coupler and spindle and all that kind of stuff. It's just all one part. And yes, auto leveling is cheating, but I mean, cheating never felt better than that. Plus, I mean, I don't want to get into bankers and managers and stuff. I mean, talk to them about cheating. It's all about the results, and that's the only thing that matters. And for that matter, auto leveling works insanely well and functions. There's no black piece. Yes, that's a nut. If you're referring to that. And yes, you can get those stepper motors separately. A lot of places sell them, and they are sometimes relatively expensive. But this one is they're relatively expensive. But if you find the right place, you can find them relatively cheaply. Actually, not much more than the motor plus a coupler plus a spindle. Okay, the two nuts have to be tightened against each other. Counter did that. Now the other thing we have to do. Guess this is. Oh, we're gonna adjust this later. For the initial position of the Y counters, you can temporarily mount the rod. See step 10. Wow. Adjusting the length of the Y axis stage. Okay, so we're gonna adjust it afterwards. And for now, just put these on with a nut. washer, the part, and the nut. Joe Prusa just said, I will send you €1 for every step of the manual you followed. Yeah, thanks, man. I can use the motivation to stick to the manual, but it is very much necessary for any printer. I guess the manufacturer knows best, and if anyone knows what they're doing, then I think it would be Joe Prusa and his team. Did you know that Joe Prusa was actually is actually like a 57-man team, Prusa Printers, or Prusa3D.org? What's the official name? That is amazing. 57 people working on the genuine Prusa printers, and basically doing research, doing engineering, doing all the packaging and what else to make these printers, and everything else that is also related to manufacturing and getting these printers out into the world. Also, E3D, I talked to them recently. They're an amazingly large company as well. I don't think they're like at 50 people yet, but they're like 30 or something. That's wow. It's always amazing to see how much and how quickly the companies we know as like a 2 or 3 man team, how quickly they grow and become a real business. So Neil, actually, if Joe offers you a job in Prague, I'd definitely take it. Prague is a beautiful city. I've been there on a few occasions. You definitely like it there. Plus, the people are super nice. Some of them talk German, but Prague isn't Germany exactly. Hey, can I get a thumbs up from everyone who still remembers the Prusa DJs time when you could find the Prusa files on actual PrusaDJs.org? Those were the times, and seeing how much we've moved from that and how much we progressed from that is still amazing. Okay, so we mounted these in their roughly approximate times, right, in the roughly approximate positions right there. These are adjusted properly. We mounted these over here, and now we can move on. Awesome! So these are done. Let's move on. So one thing I have to note is these blackened, I don't know if that's a technical term, but these blackened M8 and M10 rails, as well as these tools, they always have that greasy finish on them because if they don't have any sort of surface coating that will prevent rust. So the blackened surface actually holds some oil, and that gets on your fingers. So I would have preferred seeing like stainless here, or just your regular chromed finish on the wrenches. Just makes it a bit nicer to work with. But I guess functionally either one is fine, and I mean the black ones do look nicer. Zinc phosphate, yeah, there is a name for it, but it's kind of the oil that's stuck to these is kind of nasty. And you can kind of see it come off, more or less. It's just a really sticky, gooey, oily stuff. The black ones look cool, yes, and typically from what I've seen, the black ones are actually more expensive than the than even stainless steel ones. Okay, so we've got the. Isn't this amazing? Just one more time I want to point this out. So we've got these two parts finished. We've got the M10 rods, the base Y-frame, and there are no parts left over. All the parts that we used or that we unpacked are used in this part over here. So that is sweet. So right now we're moving on to the to the M8 rods, and you know, basically we're gonna need all of these in the end at some point, and we're gonna need all of these when we're done with them. So no leftover parts, no digging through parts either. Latex gloves, I could grab some gloves. Yeah, that would be, that's actually a really good idea. Thank you, chat. Yeah, sometimes common sense comes in the form of a YouTube chat. Also wear a latex mask? What? It is, you know, actually if you're doing a lot of DIY and okay, these are kind of worn out already, but if you're doing a lot of DIY stuff and work on cars or on other stuff that might get dusty or greasy, gloves, super cheap, super effective, and they just keep your fingers clean and protect them as well. Handling tiles and stuff can be sharp, can have sharp corners and stuff, so you really don't want to overextend your luck there. Okay, so more nuts on these. That might have been too far. So we're gonna assemble. Let me just show you what we're assembling here. So we've got, wrong way. We've got two assemblies right there. So this is one with the M8 rods, and there's the other one with the M8 rods. I'm just gonna start on this one. This is the Y stage rear. So the back cross member between the Y rails, basically. So this one is going to be where the motor mounts to, and the other one is going to be where the idler and LCD mount to. So are we not putting, because I'm going to leave the washers off for now, on the ends at least, because these will mount into the M10 rails like that. So once we need those, I'm going to put the washers on and add the nuts on the opposite side as well. Ensure the correct orientation of the Y motor holder. The precise precision doesn't matter at this time, so it should be somewhere in the middle of these rods. Okay, let's do that. So washer right there, and for the first one it does not matter yet because we can always, oh, that's tight. We can always reorient it. So if you've got a tight plastic part like that, you can just screw it on as well. There you go. Just looking, it seemed like I was running out of battery, but you're not. I know. Do not use spinning tools with gloves. That is a good tip, but this is a cordless screwdriver. I think I've got that one under control. If it was a lathe, if it was a drill press, if it was a, well, angle grinder, not so much, but anything that can catch your fingers or catch onto the glove, that's going to tear out your finger if you get the glove stuck in the in your rotating tool. So good tip there, but for a cordless drill, it kind of doesn't matter. Not that, by the way, that is not legally binding advice. If you rip off your finger while using a cordless drill because you wore gloves, don't hold me responsible for that. Anything I say on this stream is not legally binding and shouldn't be used as like proper advice or something. Yeah, so 32-bit and Marlin. I've seen a port from ST that are porting Marlin to their own 30. That's the wrong hole. To their own 32-bit platform. So what I keep hearing, again, I am no programmer, but what I keep hearing is Marlin is in kind of a, these all have the same length, right? Is in kind of a desolate state. That would mean, or that basically has it badly programmed and not really worthy of an upgrade or a rewrite or anything. But again, I am no programmer, so I can't really judge that. For all I know, with the current Marlin state, it's not really a good choice for Delta 3D printers because it has to do so many cheaty things to even get a Delta working, to get those calculations going. But yep. Sure, the correct orientation of the Y motor holder. You can just rotate that. How would? What? Yeah, but this one apparently, as Joe was saying, this one uses a modified Marlin. I'm guessing all open source, and if the Marlin devs want to, or actually they are actually what is it? Porting or integrating the mesh bed leveling changes upstream. I've actually tried to use that on a printer already. Didn't work so well, but my fault, I guess. But yeah, there's the link for the Prusa firmware, and half step right so we don't see your hands. You know what? I'm gonna move the camera over here. How about that? Yeah. All right. So, quick question for you guys: how is it possible to misorient this part? Quick mystery session for you. So the manual actually says ensure the correct orientation of the Y motor holder. So I'm guessing, I don't know, but you know, you can flip it like that. You can flip it like that. Then you can flip it again like that. So I don't know how you can misorient a plastic part like this on two rods that are symmetrical and identical. Seems weird. Seems weird to me. Now I shall move on. What's my? Okay, so we've got the next ones, which are the Y belt idler. Yeah, I guess the one big problem I have with Marlin on washer. I guess the one big problem I have with Marlin on the AVR processors is that AVR is just such a legacy platform. You know, it's the 8-bit platform that Atmel came up with like 1980s or something. And it's not really a current processor platform anymore. And if you even look at it price wise, a 32-bit processor isn't actually any more expensive than an MK2 2560. It's pretty much the same price, if not cheaper, for a 32 processor in the same form factor, in the same yeah, for the same type of application as we are using the MK2. So I don't really understand why so many people are hanging on to the 8-bit platforms when 32-bit is so affordable, at least hardware-wise. I guess software is always going to be software is always going to be a different story. Software is always going to take a lot of work, a lot of bug testing, a lot of porting, if you really want to port Marlin, but it kind of feels wrong or, you know, outdated. Okay, so we got these two done. The idler for the Y belt. Screw nuts in place, washers on the Y idler. I think I did that one correctly as well. So let's move on. So now we are going to assemble the full-on. Yeah. So now we're going to assemble the full-on Y-axis stage. So basically we need these two parts and these two, or these 4 M8 rails, and they will assemble into this sort of a, this is out of focus. That's better. And we will assemble them into this cross pattern, as you can see here. Okay, so this one points out like that. All right. Use M8 nuts and M8 washers. Got those here. Y-axis stage front back. Get that, insert and lock it with washers and nuts like in the picture. The Y-axis rear stage has to be closer to the double nuts. That is this one. Low power support? Yeah, but compared to 32-bit boards, you're not really using any less power. You got a 5-volt board. Again, you've got those super wide structures. I don't think a 32-bit processor uses any more power, if so at all, compared to an 8-bit AVR. Got that. So this one goes in here. I'm gonna have to move these in a bit further. You're gay. By the way, Joe, if you want to hit that those 3 dots right next to any offending comments, I did update you to, or upgrade you to mod status, so you are free to ban people as you wish. I do trust you that much to basically co-run the stream. I mean, it's always better than having trolls in your live chat, I guess. Yeah, so again, cost-wise, if you design the same boards with an 8-bit or a 32-bit CPU, they are going to come out to pretty much the same price. The only difference is the 8-bit boards do run at much higher volume, while the 32-bit boards are still very much experimental, more or less. So it's just a thing of volume. If you make, I don't know the exact numbers, but if you make 5,000 of an 8-bit board, that is always going to be cheaper than just making 500 of a 32-bit one. Oh, do I really have to reach over and hit that ban button? Come on. Deleted. Block. Yeah, Joe, just ban them outright. I think you can you ban them? You should be able to. My English is so good. Well, thank you. I do attribute that to the microphone, which does work particularly well in this situation. I never thought just having the Zoom H4 recorder on desk would work that well, but it does. So yeah, I think, in my opinion, it's almost as good as using the full-on clip-on lavalier microphone. But of course, that would wire me up. So yeah. broke out the bike gloves, broke out the actual working gloves, so I don't get this greasy stuff that's stuck to the blackened parts all over my fingers. So let's double check this. The rail with the belt idler right here goes in the top slot back here, so right in there. So a whole lot of nuts. I mean, this has taken me back to the salesmental times. Did any of you guys remember the original salesmental? Have any of you been around for that long? Because it wasn't fun. It wasn't a fun build with I think we counted them. It was like 800 or so, or 1,200. I don't remember exactly, but it was a whole bunch of, I keep forgetting the washers. There was a whole bunch of fasteners, mostly M8 rods, and just that triangular frame that was super tall but not really stiff. Just not a good design. Not a good design. Yeah, Roadlink. Roadlink, I hear a lot of great things about Roadlink. And I do realize I'm jumping between topics here. But yes, I did hear a lot of good things about Roadlink. The only problem is wireless lav setup costs 800 euros or so, and that is, I don't know, that is a bit too expensive for me. It's just a tiny bit, tiny bit. I do have the idler holder upside down. Yes, you are correct. I do have the idler holder upside down. Now with the manual, while I do have to praise the way the kit is laid out, you know, again with all the bags properly labeled and sorted and basically structured by topic. The images in the manual are rather small, so if you look at these, let's see if we can get in focus there. If you look at these, you can't really tell which way this part right here is supposed to face, this way or, oh, how do I put this? Difficult, there. This way or basically this way around, with the rounded part up or down. That's something you do need to refer to the high-res images on the web to really make out. So let's reassemble these. Is it alright to store plastic just on the wall? What about humidity? That's a question I pretty much answer every stream, because I do have this, you might see in the background here, over there. I do have all my filament out on the wall. Then again, this is a basement room and there is a dehumidifier running most of the time, just, you know, keeping the entire basement at a constant humidity. So I don't really have a problem with humidity in the filament. Unless it's nylon. Nylon always soaks up all the humidity I have around, but stuff like PLA, PET don't really seem to make that much of a difference if I keep them out. E3D actually did some studies on edge, or on their edge filament, that cover how the filament degrades when you're storing it wet. When you're printing it really wet, they actually soaked it in water. Nobody saw that, right? And the one thing that changed for them was how well the layers adhered to each other. And well, that and how and how tough the plastic in general was. If it had water in there, it would break in a more brittle way than when it was printed completely dry. Okay, Y motor stage closer to the double nuts, we got that. Then we've got the idler holder oriented the correct way around, we got all that. So far, it is incredibly important that the axis is perfectly rectangular at this stage of construction. All rods need to be perfectly straight and level. If not, you're going to have trouble calibrating later on. Okay. That is a good tip. Yeah, as you can see, this one does come out of square relatively easily. So the question is, how do I get to tighten these up already? No, I do not. Okay, so I guess this is as flat as it's gonna go for now. So I guess we can move on. Next step, preparing for the y-axis stage. So we are going to insert the frame actually. For anyone asking, again, this is just while I dig this thing out. This is the power supply that comes with it. It's the same one on the kit or the ready assembled one, and it's got this 3D printed shroud with an IEC connector, an on-off switch already wired in and connected, and then on the opposite side it's got the 12-volt wires coming out, so you're not going to be dealing with 120 volts at all. You're never going to deal with a wire, or never going to wire up a wire that carries mains voltage. So that is sweet in that regard. Okay. Proudly made in Prague. So let's insert this frame into the rod assembly. Yes, that socket has a fuse built in. It's like a little glass fuse. I don't think it actually needs that because the power supplies typically are fused as well, mostly electronically even. But I mean, it's a nice touch, I guess. Okay, so this is standing in here pretty well. Did you adjust the width by inserting it into the frame? Well, the manual doesn't actually say to adjust the width yet. And that is what I'm going to do now, I guess. Tighten the M8 nuts gently or you'll risk damaging the 3D printer. So these have some room to move, to expand and contract. There we go. So I guess now I can insert this guy in here and tighten it up. So the jam nuts on the back here are already tightened up, so they should work just fine. So I'm guessing I should press this one down onto the table to get these in the slots lined up. But when we're done with that, we're gonna attach some felt pads to the feet on the corners here. Which on the assembled one we do not have on the frame. So if we double check the assembled one, yeah, so this one does not sit on the table with the frame. It only sits on the table with the rod ends, or with the y-axis ends. The frame is actually completely suspended between these 2 points on the ends here. What type of paint is this on the metal frame? It's like a black, silver, metallic powder coating, aluminum. Okay, so this is, square them up, page 7, step 8. Yes, that is the exact step that I'm at. Insert the whites as close to the Y corners as possible. Oh, okay, I see what you mean. Okay, so what we need to do to square this thing up, or to well, it's not really squaring it, it's adjusting it. We're gonna insert the frame into these ends right here. Okay. And then, make that one square as well, sorta. And then we're gonna tighten this thing up. Oh, if I can get it up here. Then we're gonna tighten up the ends to make them the exact distance these two holes in the frame are. So like that, and now we can tighten these. Now that's a bit funky, but with a bit of face holding and stuff, I guess you can do that just fine. Okay, so that looks good. That's all in there really well, and these could use a bit of adjustment to the other side. So of course this is going to scratch out the paint from those mounting positions in the frame, but yeah, you're not going to see that anyways. Okay, so now we can just tighten these up. The frame is not holding it in place, so that should be perfect. Okay. Out of the way here. Okay, here. I feel like I'm doing something wrong. I feel like the frame should just be holding on up on its own, but I guess I'm doing this right. This is super perfectly in there, so I guess it's results that count. Let's see. Yeah, this is perfect. So I'm gonna take out the frame and tighten up the other one as well, because that should be fairly square at this point. Yeah, price is actually, I keep saying 739. I think that is the price for the kit, and it's 9.99 euros for the assembled one. Which again, I would agree that is a good price for. Hoping I'm not getting grease on my shirt. That is a good price for a printer like that. Well, good as in not as in if you have to pay that much, then go for it. But actually, really good value compared to the other options on the market. I think the Mark II i3 is like one of the, I don't want to say most innovative, but it's still your classic i3, but it's got so many cool features like that entire bed mesh leveling that was developed by Prusa. Oops. That was developed by Prusa, if I'm not completely mistaken. It's just it brings so much new to the table that you're not getting with any other kit built or store-bought 3D printer at all. So I think that it's $739, and it's cheaper than most other brand name printers, even compare it to an Ultimaker, compare it to MakerBot even, or compare it to Lulzbots. It's a completely different price segment than the other big names are targeting. Okay, that's good. I'm just going to tighten that up real quick. Yeah, so the thing is, there is a there is a bit of a false economy with Chinese printers, with Chinese parts in general, because very often you're going to see i3 labeled kits being sold for much cheaper than this, and probably a third of the price or so. The only problem is those kits do not contribute anything to the further development of these printers. They are often government subsidized, so they are being sold at less than what they are worth, especially when it comes to shipping and stuff. And often you do spend more time making those kits work than what would typically be the value of your time. So if you spend 3 or 4 days fixing all the bugs with a Chinese kit, I don't think that's worth it if you save a few $100 on it in up front. That's perfect. Let's try the other end again. And that is perfect as well. So now we can insert this. This is the wrong way around. Yeah, plus adding parts like hot end, etc. Yeah, it's a hot end, good example. Same thing with buying a E3D V6 J-head clone thing. Okay, that just fell in the wrong way. Versus buying the real deal. The real deal works. I can attest for that. The real E3D V6s work extremely well. But buying an E3D V6 clone, I actually have a few here. They're just not up to the same standards that you get with the real product. I've, a few people have reported yesterday they do work. They even work with PLA relatively well, but you have to, spend that entire time remaking or rebuilding the heat break and actually, polishing that in the inside or completely returning that entire part. So for me, that wouldn't be worth it. That would not be worth it at all. Are we not installing the frame yet? We are not installing the frame yet. Come on. Now that I want to get this thing in. Follow the manual, yes. I wanted the frame in here. Okay. Too bad. Thanks for that hint. You guys keep distracting me. It's all your fault. Nah, but seriously, keep asking questions. You're keeping the flow going. It's the stainless steel tube, and it's also stuff like thermistors and heater cartridges that are not up to spec. All right, so we got that. Rotate and repeat. So we've got this part right here assembled. It's mostly squared. This does look square. And yeah, I was just trying to see how well it fit in here. Okay, so the frame definitely fits in there. Perfect. Tighten the M8 nuts gently. I did that. Identifying the length of the rods. Let's go on with that. The threaded rods will flex. I actually just tested that on the assembled one, just trying to push it down to the table, but it did not, or not noticeably. Particularly because there's not going to be any force on that frame this way in regular printing. So the force you're going to see is going to be like that from the x-axis moving, and maybe up and down from the z-axis, but mostly it's going to be like this one pushes down, this one pushes up. But that's just not going to be an issue in real use. Even if it feels flimsy, even if it feels like it's going to be rocking back and forth, it's not going to be detrimental to print quality at all. Okay, so we're going to be using the mid-size smooth rod. And we are going to insert the smooth rods into the y-axis stage. So that sits up here. clicks in place. So there is a little divot down here, which I do not know what they are for, but they're in there. Okay, so these are inserted. Let's get the correct one inserted on the opposite side as well. There we go. Okay, insert the two, adjust and tighten the M10 nuts. So we're gonna adjust the length of this, of the Y-axis subframe essentially, and I feel like this one might all be tightened up already, so, or might all be in good shape already, so I'm just gonna be tightening this one because also this is already adjusted in length with the 100 millimeters right there. So let's open up this one. Retain the 100 millimeter distance right there. Okay, I am doing that, so I'm not opening up these. There shouldn't be any gap between the 8 millimeter rods and the Y-axis corner. So basically, this part up here, or this one down here probably shows it better. This one is flush, this one is not, so these should be all the way in there. LMATUs can slide in there, and we can increase the travel without shipping new rods for customers who were upgrading from the MK1 to MK2. Okay. Is there another Tom and chair? I don't know. Hole is for the cable ties. Oh, there they are. Okay. So if you look inside here, you can see there's a cable tie slot that goes all the way around. That's just the hole in between them that we're seeing, or the hole that's poking through to the surface where these smooth rods fit. So Joe, do you know what sort of rods these are? Because they look like they're a plain steel without any sort of chrome plating or anything on them. I hope they aren't like some plain stainless steel ones. I'm thinking that they might be hardened regular carbon steel, which would be okay, but of course you would have to keep an eye out for rust and stuff, but I might be wrong there. Okay, so this one is adjusted. And this one should be adjusted as well, so there's no gap on either side right here, so I'm going to retighten these up. I guess you have to be careful not to just tighten the outer nuts, because that will tilt it backwards. So I am mostly going to tighten the inner one right here. There we go. Well, the problem is the touch bit doesn't work with gloves, so I can't do anything over here. And my mouse somehow stopped working. Haha. Okay, so these are all tight now. Just tighten this one up as well. All right. Step number 10. Done. Remove the 8mm rods. Got that done. Next up, we will prepare the heated bed subframe. So this part right here, this is the same metallic black matte finish as on the mainframe. And I gotta say, these things look pretty darn nice with that silver sparkle stuff in there as well. Yeah, these do look really well made. Nice focus. Tom never makes a mistake. No. I do stuff on purpose. Marker identification. There's the marker right there. There's a little extra divot on the edge, so we're going to orient it like this. This one is not on the opposite side. This is just on one side. Bed frame is twisted. Ever so slightly, yes. What type of paint? Powder coated, I guess. It is aluminum, as far as I can tell. So yeah, it's definitely powder coated. Don't get the Mali on M150. Watch my review of that. That's not a printer you're going to be happy with. Yes, it's cheap, but it's just not a good printer. When placing the bearing on the Y carriage, make sure they are oriented as shown of in the picture. So if you take a look inside these, let's just focus you guys in as closely as possible. So there are 4 rows of balls in this linear ball bearing. So depending on how you orient these, you can get completely different load ratings on the entire bearing. So if you orient them like this, you're going to have 1 row on the top and on the bottom. You probably can't see the top one all that well. There is a row straight up on the top, so if you apply a force from the top like this, it's going to go straight to the top row and transfer into the rail. Now if you rotate them like that, where you have them angled at 45 degrees, you're going to get much less of a load rating out of each row, and you are going to load the surface of your linear rails much more than you should. So just a little hint in there is nice, even though I don't think it actually makes that much of a difference, but it's still nice to keep that in mind. So that's actually what the manual says. Make sure that they are oriented that way. So we've got that. We're going to keep that in mind with the assembly right there. Before the start, pay attention to how the finalized part should look like. Check location of the position marker on the Y carriage. That is up here. Make sure there are one of the balls. It's extremely important to have proper orientation. Marker on the right side. Marker on right upper side while looking on the Y carriage with bearings located down and side with 2 bearings at its top. So this is going to be with the bearings below them. Like that, I suppose. Okay. Place zip ties into the Y carriage as shown on the pictures. Place the linear bearings in cutouts. So we are going to marking on the right upper side while looking on the edge with the bearings located down and side with the 2 bearings. Yeah, okay. So the bearings will be facing towards the tail right over here. So questions for you guys in chat. Now that we're already discussing custom and low-end printers, have you guys backed any Kickstarter 3D printers? Have you guys, actually gone in and backed one of those $150 or $200 3D printers and actually received it? And then the question also is, how much of what was promised did you actually get? Were there any holdups? I mean, I guess a 1 to 2 month shipping delay is kind of expected with Kickstarter, but was there a larger holdup? Was there any shady stuff going on where all of a sudden the manufacturer disappeared? Oh yeah, peachy, haha. Yeah, just like that. Because that is something I feel is putting both a bad rep on the 3D printer community, and at the same time, dumping prices for regular manufacturers. And in all sorts of ways, expecting unrealistic expectations for real printers, creating a bad rep for not delivering, for being cheap stuff, and all that sort of stuff. 13 hours, 45 minutes remaining. I'm hoping this is not going to be another 15-hour stream. My voice would not be thankful for that. Yeah, you can definitely 3D print a house with the PG printer. Okay, orientation is correct. Bearings are down. Now all I have to do is rotate these bearings to the correct side, up and down. And we've got the next step finished. So like that. Now these bearings do come with like a shipping grease or shipping oil in them. I typically like to replace them with something a bit more substantial, like a real grease, but we're just going to see how well this works. I guess it should work just fine. Just something to keep in mind for the long run, for just some long-term reliability. I'm not using the included tools here. There is a small needle nose plier included, but I'm just going to use my bigger one because I like that one better, to be fair. The metal housings flex. I don't think they're going to flex that much with the with just zip ties on there. Shouldn't be an issue, and even if they do, it's always going to be the rod on the inside that's keeping the shape. That keeps the shape in the right shape. Keeps them round. So now comes the part that we actually printed on the ready build i3, and I feel like I do have to clean this one out just a tiny bit before we can install it. So yeah, Tico and Micro 3D. I actually saw the Micro 3D in operation at some point. It did print, it did function, it was delivered. Though I feel it's like it's much more of a toy than you'd expect. So what I think is going on with the Kickstarters is basically everyone seeing how successful Printabot was, how successful they even are today in the long run, how much of a business they grew out of it, and then think, hey, we can do that too. We can do the same thing. We can be the next Printabot. But I think Brooke did a whole lot more to make Printabot what they are today than what a lot of these Kickstarters do. A lot of them just try to sell cheap machines and make a quick profit out of it without really thinking about the long-term strategies other than maybe, okay, we need some money to make these, to actually produce the Kickstarter rewards. So pre-orders maybe? Yeah, Kickstarter's up front that you're gambling. They won't take responsibility for you losing money on your pledges. They're saying, hey, but take it up with the manufacturer, because we're just an innocent little platform. We're not the manufacturer or anything. So why would we be responsible? Okay, I'm just checking with this belt how close or how tight this thing is. And it's pretty tight. It should hold up pretty darn well. I guess it's almost as. Oh yeah, look at that. That's definitely holding up. It should hold up at least as well as the original one, which broke during shipping. So that's not really like a big challenge. Okay. Be aware of the orientation of the belt holder. Yes, the closed part goes towards the double bearings. Now let's see if we can screw through these, or if these strings make that too tight. Right, and here's a little screw baggie for the y-axis. There we go. Yeah, so the electronics in here are. You know what? Let me see if I can find them in this pile. Clearly, there's the case for them, LCD, and where did I put them? Either way, these are like a Rambo-ish based. Again, genuine parts from Ultimate Machine. I believe they are slightly custom because the software included does have a custom firmware uploader with them. But they're still based around the classic AVR platform, the classic Atmega 2560. Unless I'm wrong, please correct me if I'm wrong. Yeah. So resin is actually resin is, I think, one of the next big frontiers that 3D printing will encounter and conquer, basically. That, and of course, I mean, resin is always going to be a high-end process, just because if you want any sort of resolution, you either need to go really slow with a laser, or you need to go with a high resolution projector, and that stuff is expensive either way. So that's going to be like your high-end option, and it already is for really high detailed parts. And the other thing is dual material and water soluble support material for FDM machines. That is, in my opinion, what's going to really propel FDM-based 3D printing forward by miles, by an enormous amount, because you're all of a sudden not limited by geometries anymore, by having some sort of geometry that works for 3D printing. Because let's be honest, the support material generated by Slick3R, Cura, or even Simplify 3D, it's still a clutch. It's not what you really want to use. So once we get PVA supports, or what is it called, E3D scaffold, and 3D printers that actually have a dual extruder and dual hot end setup that works really well, that's gonna be awesome. Nightbot, yeah, Nightbot is here again. So just as a reminder again, Nightbot is my little friend. I did set up the Nightbot service as like a moderator tool, more or less. And as a reminder, I did set up StreamTip. If you want to send some beer to my way in the form of a little donation or anything, you can do that. And yeah, always appreciate it. In a way, auto level forces you into bed type choices. Yes, it does. But it forces you into the right choices that you want to make. Basically, the beds that auto leveling works well with are the beds that you want to use anyways. I don't think glass beds are that. Wow, these are tight. I don't think that glass beds are. Do not tilt the rod. Okay, are still state of the art. Are still up to what we need these days. Especially when it comes to heat transfer and this is getting looped up. Heat transfer, reliability, sensor support, that sort of stuff. Okay. Yeah, so aluminum or PCB heater like this thick PCB should be the way to go. Okay. This is slightly tight on the end. Slightly blocking up, but should be okay. Yeah, I've seen Zortrex prints. They're amazing. Just straight up, they're really good FDM prints. But I'm not quite happy with how closed the Zortrex platform is becoming, or has become. I believe that they use their own slicer even. Filament cartridges and stuff, that's always something you should keep in mind. Best experience with the original ZABS. I feel like there are better and more open versions or alternatives out there. Okay, assemble the Y carriage rods. So we did that. We've got the bed undercarriage assembled. We've got the bearings in. We got the belt holder, the smooth rods in, and now we're gonna set this aside and work on the bed lower frame again. "20-tooth pulleys. These look like 16, I believe. If anyone wants to count, be quick about it. Yeah, this looks like a 16 tooth pulley actually. So next up, assembly of the Y-axis idler, which lives over here on this part over here. So M3 washer, M3 times 25 screw, the washers. This is M3. This is not going to work with gloves on at all. And the idler bearing. So this is actually a really nice idler. Just take a second to appreciate that. So you've got the machined or turned aluminum smooth pulley, more or less. You've got one bearing in the center pressed in. You've got the shoulders rolling along or moving along. That is what a belt idler should look like. That's really, again, what it should look like, what a good idler should be. Let's hope that this fits really well in here too. And let's see if I can assemble this thing correctly. Washer, screw. Tighten the Y-axis idler. Use the pliers and the 1.5mm hex key spanner. Hex spanner. Okay. Tighten the screw gently. So how do I? Okay, so this one doesn't have any sort of any spacers on the bottom that would centered in this part right here. So basically we just have the screw washer, and we're screwing this in from the left side, though it shouldn't really matter. Ooh, this is tight. And then push it right through and down all the way. So that's all there's to it. Mirror bed. Cut up a door mirror. Actually, I'm currently using the glass from a throwaway picture frame. Here's the problem. Now, mirrors actually tend to be a bit flatter than regular picture frame glass, but I did actually have a look into a few different picture frames, and the glass on there is super thin. It's typically like 2mm thick glass, but it's also really bad quality glass most of the time as well. So if you ever take a look at it, it's usually wavy and non-flat, and like it's just super cheap stuff. Plus, you know, the 2mm stuff just likes to break like nothing. So you can't really recommend that. Who else uses PEI? I bet Lulzbot does. The Mini has it, the TAS 6 has it. Wonderful. It's pretty much the same solution as is here, but the Lulzbots use a glass sheet underneath. So they're not printing, or so that they're using glass with a heater PCB underneath. Okay, so we've tightened this. Next up, Y-axis motors. So here comes the power. Y. PEI is awesome. It's by far my favorite bed surface because it's reliable. It works extremely well with most surfaces or with most filaments, and it's just so well, I don't want to say easy to use, but so uncomplicated to use. You don't need to apply it every time like with hairspray or I'm actually putting this on the wrong way. Like with hairspray or any other adhesives that you actually put on top of your bed. You just apply it once, and then you have your settings ready to go, and you don't really need to do anything to your surface every time you print. Plus, the good thing, or the awesome thing with PEI is typically your prints are going to come loose once the bed cools down. So you're not going to be dealing with stuck prints that need to pry off your bed. I mean, the PET print we just did was maybe a bit of a bad example because wrong settings, mostly. But at the moment, gently. But typically PET with ABS or PLA is just going to stick while it's hot and then completely come off once it's cold. So that is awesome. Yeah, Lexan, or I don't know the exact pronunciation of that. That is Is it polycarbonate? I think it is polycarbonate. Polycarbonate, same chemical group as ABS, so ABS will fuse to polycarbonate or Lexan sheet if you print it slightly incorrectly, and then your sheet is basically ruined. As is PMMA. PMMA is also very similar to ABS when it comes to adhesion properties and chemical makeup. Okay, juice. We did that. Next up, Y and stop. So we are moving through slowly. So this over here is the part that we still need to do, and this is the part that we got done. So not a whole lot of progress yet, but I'm hoping this is the slower part right here. End stop. We need the end stop. So Bottom parts. Nope, that's the stuff. Yes, the assembled Y carriage is fixed. That is all done. Now for printing PLA on this one, yes, I could do that. Of course, it's going to make some noise. I'm just looking for where to put it. I guess I could put it over here on the shelf and get a camera on that one just so you've got something going on. I guess, yeah. Let's make some space. Because really, I do need the desk space for working on the kit version. So since we are going to do oops, where's my mouse? My mouse is gone. Whatever. So since we're going to do some PLA prints, as Joe suggested, Rapunzel Silver. That one, yeah. Two things I want to know from you guys: what filament should we be using? So we've got, you know, all those wild PLA colors. We got some. I don't want to try carbon fiber filled, but we've got conductive PLA. We've got more ed. We've got T glazes. All sorts of stuff. Which one should I use? Which color should I use? Rapunzel Silver does look pretty sweet. So let me know if that's something you want to see. Also, what model should we print? Something that's going to take maybe around 5 hours or so, because this is going to take a bit more. Let me know. Okay, Rapunzel Silver. That seems to be pretty much the consensus there. Which one was that? So we've got two spools. I actually don't know which one was the Rapunzel Silver and which one was the regular one, because it does not say on the spool. So there's your lighter one and your darker one. The lighter one does have all this metal particle stuff in there. So I guess that's the one that we're going to be using, right? Looks good, so I just have to move the camera back here as well. This one is going to be the one that we're using. And also, what model should we be printing? Elephant by Leaf Fab Shop? Print a Joe bust? Okay, I will need to disconnect this camera real quick. That might freeze it up. But we're going to have it back in a second. I'm hoping I'm not crashing anything here. But as always, no risk, no fun. There's that. Now, power, let's just check chat. Samples on the G-code. Yeah, but do I really want to print just samples? I guess that's what I'm going to be printing anyways, but yes, I will fall over the tripod, I know. Benchy with a close-up. I feel like I'm printing too many Benchies. There's the frog. There is an Ada Linda on the SD card, so I am actually going to print that, because I think that is a really beautiful print if it comes out right, and it should work. It should work beautifully with with this silver. Is it PLA? I think it is PLA. Yeah, it says PLA on here. With a silver PLA. Okay, so just need to get the camera hooked up, or it would be all for nothing. And before Tom falls over the tripod, well, I'm already falling over other stuff, so that is somewhat realistic. Let's check. So that is, well, that's working. This stuff is working better than expected. So much better, actually. Now, of course, the only problem is we're going to be losing the close-up on the build, but I guess that can be excused, I suppose. Let's see if we can get this one to show. Maybe not the best angle for the LCD, but the one that is practical. We'll see. Okay, we'll adjust it afterwards, and now let's give you the SD view. Or the LCD view. So we're gonna change filament. So that's in unload filament. Preheat the nozzle. Okay. Quick tip there. Maybe if you have a unload the filament setting, heat up the nozzle automatically. That shouldn't be that much of a problem. Okay, this isn't gaff tape. I know this should be gaff tape, but shit. Yes, I did tether a full-on DSLR. That's a Panasonic G7, awesome camera. Because I do want some control over the image I'm showing. There we go. There's one. I know this is duct tape, and it's probably gonna ruin my floor, but well, all for you guys. There we go. That's good. So while that is heating up, I'm going to just quickly move on with the build. Yeah, G7 looks identical to the GH4. I'd actually say that G7 sometimes looks, I don't want to say it looks better, but it's an awesome camera. It's by far my favorite video camera. Plus, it does 4K. If you didn't know, all my videos for like the last half year or a year or so have been shot and uploaded in native 4K, all the way from the camera, from the G7 to YouTube. So if you wanna click that 4K or even that 1440p button, you're gonna get much better quality video even if you are only on a 1080p monitor, because YouTube will be delivering some extra bitrate to you. Okay, so now we've got the Z end stop connected in there, so that those M2 screws actually fit really well. And I do believe I've got this one, yes, lined up correctly. All right, so that one is heated up to 40 degrees. Whoops, sorry about that. Unload filament, and that's it. worked better than expected. So that one only gives it a very slight push backwards. Yep. Okay, what's not? So, when someone's complaining about their filament manufacturer actually crossing the threads on here and getting the filament tangled up, you know that first moment when you remove the filament, that is the most crucial one, because if you get these loose, if you get these coils like, you know, going loosely like that, and if you ever cross these two right there, you're never gonna get that cross out unless you unload all the like 10 or 20 turns of filament off to the side and then rewind it properly. So that's like for your filament health, that is super crucial, super critical. But for now, it looks like we managed to pull that off. So for the load filament procedure, I'm actually not going to use the load filament. I'm just going to push it in by hand. And let's see, print from SD. Castle, Batman, Marvin, dual color, gear bearing. So there is supposed to be a Adelinda on the SD. Ah, there it is. Okay. 6 hours, 200 micron layers. Well, sounds good. Sounds good. Let's push some more in here just to keep that fed. Tweezers. Oh, too late anyways. Get over here. Yeah, raise the printer for the build. We'll see about that. Did I clean the bed? I did not. It's wow, it's sort of warm right now. I think it should stick nonetheless. Because PPI should be pretty good on that front, but just to make sure. Because it's too hot anyways. Let's get this one on the front off as well. Come on. There you go. That's cleaned. So how should we yeah, didn't miss much. How should we set this thing up? No, I don't think we should have the LCD in here. Something like that. Maybe, I think that looks good. Really bad idea to push on the bed while the mesh bed leveling is running. That is a good point. That is an excellent point, but it seems like the i3 Mark II is stiffer than we thought. And it's actually doing a wonderful job with the consistency of the first layer. So yes, the matte mesh leveling is using the sensor. So quick question, I'm gonna grab some more stuff to drink because I am running relatively dry. Yeah, it's fine, guys. It's fine, guys. Yes, mesh beveling used to be a manual process on the first printer that I. That looks perfect. On the first printer that I tried out mesh bed leveling on, it actually it was still a manual process, and I switched back to using the traditional matrix compensation, basically. So, quick question: which one for the build? Which one would you like to be the main camera? The one that you're seeing right now, like the one overhead? Let's pull that up to the full screen, or have me in the corner and focus on the printer. So I am going to use Nightbot for that and see if you guys can. Yeah, okay, hold on. That didn't work well. Poll new main camera. And that should be overhead or printer. Nightbot? I just want to try out Nightbot. So head over to that straw poll page. I'm gonna refill and check the results after that, and we'll adjust accordingly. Whoops. We need that. Yeah, that is pretty squished. Where's the poll? Scroll up. I should be able to do just poll results, right? Okay. We are printing the Adelinda Dragon from, well, what's her name? Awesome Designer. That is looking pretty much perfectly. The feet are a bit squished, but looks pretty good. Yes, I do have two printers. I do have the the ready assembled one over here, already going. We did print a replacement part for it because one thing was broken during shipping, and I'm assembling a complete second one, a complete kit version over here. So, so if we're gonna do poll results again, Filamentum likes 200 degrees. It's 210. Well, first layer temperatures are really not that crucial. So I'm actually going to give you guys a bit more depth of field. How much was... What? Alright, I'm gonna switch back over... Whoops. Hold on 1 second. Hold on. So I'm going to switch over to the overhead camera as the main one again. The A-cam over here, maybe make the printer a bit bigger in the corner. Right there, because you don't need to see my face all the time. Or maybe even have it, we could do that, have it on this one. And add the B-cam right there and right there. That should work, right? Is that good enough? I think that should work out perfectly. Why does the assembling of the kit take so much time? Because I have to entertain you guys as well. I have to satisfy my viewers. That's what it's all about, I guess. It should take 4 to 5 hours, 4, 5, 6 hours, depending on who you're asking. But overall, I don't think I'm doing a very efficient job of assembling it while running stream, while trying to print things on the ready-built one. Yeah, so 3D printing donated €1, so thanks for that. You're awesome. I got a Prusa i3 too, looking the whole live stream. So 3D printing itself donated. So wow, that is a great honor. Yeah. Anyways, let's get on with the build. I guess that's what he came here for. Printer seems to be doing just well. There seems to be a bit. There seems to be a slight bit of infill versus perimeter separation. Okay, now of course I've taped the camera down, so I don't know if you can make that out, but okay, we're gonna just leave it printing. There is a bit of a gap between the infill and the what was I gonna say, the perimeters, but it should be fine. Yeah, so tax-wise, again, I do have to point this out. This is not a Chinese Prusa i3 kit because, you know, there is only one Josef Prusa genuine kit, and this is it. Plus, of course, the ready assembled one. So since this one is being shipped from Prague, from the Czech Republic, we do have this thing called the European Union, so we don't pay any tax when we are sending products from one member state to another. So that's kind of cool. So if you're anywhere inside the, well, not the European Union, but the European business zone, whatever it's called, you are tax and imports free for everything you import and export. So these wires go behind the motor, below and over here. Like that. And that looks good. Yeah, the price on the Prusa web shop actually does include tax, so sales tax per se. So not like when you're buying from Ultimaker where you're paying 1,899 plus sales tax, which is like 20%. Then yeah, that too. No, the 739 and 999 for the assembled one is exactly what you're gonna pay. By the way, is the noise from the printer bothering you? It is sitting on a rather flimsy shelf, so that is amplifying it a bit. Yeah. Okay, so dual over this way, so that's gonna sit in here. It is important that the orientation is like this, so we've got the marker over here and the... I should zoom you guys in. Nope. There. The marker is over here, so we're orienting these properly. Basically with the motor towards this side. And that is rolling smoothly. Switch it to silent mode, but probably not while it's running. Ah, I can switch it to silent mode. Look at that. That's silent. Well, that is high power. But that was easy. So that's definitely an awesome addition to the firmware right there. And it is much quieter now too. It's not just what the microphone's picking up. It's really, really quiet. So head of the zip tie facing out. So you do need to make sure the zip ties are actually oriented properly. That is interesting. Cork feet. Well, the printer already has. At least on the inside, the printer already has felt feet. But I don't think they're doing that much for actually dampening the noises from the machine. Lowering stepper current would be, one explanation, but the question is, wouldn't it need to also lower accelerations or the jerk setting, what Marlon incorrectly calls jerk? Those would need to be lowered at the same time. So I'm guessing it would need to be a combination of all of those. Yeah, kit versus assembled one. I generally recommend getting kits because you just like you guys are saying, you are learning so much about the printer itself and how it functions and how everything fits together, and just learn to keep an eye out for the things that for the specialties of this machine. So if you've got the time to do it, if you want to do it, I would definitely recommend getting the kit. Plus, it is a bit cheaper, so that could also be an argument as well. The assembly looks like it should be really easy to follow for the part that I've seen. I guess the rest won't get much more complex than that. But yeah, I would always recommend getting the kit. Yes, the y-axis movement does cool down the bed, as with any moving bed 3D printers, but it kind of really isn't an issue if you have the right bed design. So unless you're using a very weak heater on a glass bed, for example, then it might cause some issues. But with this one, with the PCB heater, which has which has relatively powerful heating traces on the top, so the side that is oriented towards the print, as well as a massive copper plane on the bottom, it shouldn't be much of an issue. Plus, it's not moving so much that that would actually create airflow or any sort of wind that would constantly keep it cooled. Okay, that's that. So I'm still waiting for the step where we actually align the idler and motor to the exact distances from the corners. I'm hoping I did not skip that. I did not, apparently. Yeah, okay, so here's the idler and motor mount adjustments, so we're going to do those in a few minutes. Why motor pulley? So again, this one is a 16-tooth GT2 pulley. Two screws. Don't tighten it yet, we'll get to that later, so we're just going to place that on here. And run the belt through the idler, which is still completely loose, by the way. And then as a loop into the bed. Let's see if I can get the loop length right again on the first try. Manual reading. I do read the manuals, guys. Come on. Or do I not? I guess I should use pliers so that, like it says in the manual. I'm trying to get you guys like a second close-up view, because only having the overhead seems kind of limiting. So let's see if we can get the webcam in here again. I guess that stuff over here you don't really need to see, so there. That looks okay. Not the most professional thing, but that looks decent. So now you should be able to see some stuff that I'm doing down here on the printer itself. There we go. Okay, so the question is, do we... How do we get this tightened in here properly? Let's try the pliers. I don't know, that still seems a bit too loose. So we're just gonna give it one more tooth and that should really tighten it up. Assuming I can find the exact position again. Get that one tooth closer, and that should really tighten things up. Okay, so I feel like this belt holder is not my favorite part in the build. Again, yeah, hold it with pliers, but how should I get in there with pliers while holding it? There's so little of the belt left here. I guess I could. Yeah. I guess I could take the other one out again, the one on the opposite side. Okay. But it seems like this one should be okay there. This is definitely not my favorite part. I mean, from it breaking during shipping to like having to jam the belt in there. Yes, it doesn't use screws. Yes, it is a very simplistic and minimalistic part, but I really have preferred seeing something that is a bit less tedious to assemble. So even though this stuff down here isn't really lined up yet, let's just loosen these up a bit so that we can get the angle error out. This is roughly the twang we're getting. It's not a lot. It's like, it's a twang, it's there. Yeah, the red blinking LED in the corner of the heated bed, that is the heating indicator for the bed heater itself. So whenever that is on, the heated bed is routing power to, or the printer is routing power to its heated bed, basically, reheating that. Still tight. Adjust the Y mount. Okay, so this is the step that we need to do anyways. Yeah, basically adjust the idler so that the belt is straight. Yeah. Very little extra facing towards the motor. Okay, so let's check that out. So there's the side that's pointing towards the motor, and there's the little lip that's hanging over there. Let's try that out. So we're hitting a cable up here. So yeah, that is, you probably won't be able to see that very well, but the little lip that's standing up there is just barely, you can hear the click maybe, does just barely clear the motor, the pulley on the motor. So we should be good there. Okay, let's adjust these guys so that we can have them all in line. So basically what we want to do is we want to line up the belt with the belt holder down here. One. So now that the motor and the idler holder are under tension, it is actually quite difficult to get these in position and tensioned up correctly, or lined up correctly. Alright. Yeah, we can kind of move it around by hand, but it's still kind of hard to just push them around. Basically, what the way I think would be, or is going to be the easiest, is just to line it up with the idler itself, and then adjust it on one side, and then adjust the other one accordingly. So apparently, I did over adjust it already. Okay, so that should be in line. I mean, this doesn't have to be precise to the last micrometers. Belts always have a bit of slack and tolerance towards the left and right. They can always, compensate for a bit of an offset, but if we can try to get it close, why not? Yes, that is a Nope Dragon. I did not drill out the holes. I do not believe the manual said to drill out the holes, though Joe will probably lynch me if the manual said so and I did not do it. Like I said, the one thing that I think is happening here is that the tension from the belt will actually keep the will keep it tensioned against the threaded rod and keep it from moving all too smoothly. So, but for now, I'm going to call this good enough. That's one. Okay. And that should be all tight and good. Very well. Okay. So that is moving smoothly. Got the motor engaging. Now the only thing we need to do is tighten up the pulley on the motor itself, and I'm going to do that flipped around again, just so I see where it will actually line up. We've got the set screw on the flat spot of the motor, which you probably can't see on any camera angle, but that's okay. We're just going to tighten it up. Push it back a tiny bit to make sure it's not pressing against the motor housing, and we should be good to go. And I'm also going to tighten up the other one, though I typically remove these. So there we go. Yeah, getting the belts tight. This one feels good. This one feels like it's just tight enough. I definitely feel like a different design of this holder would make this process a lot easier. I actually did like the one on the. I actually did like the one on the Atom 2.0 build, where we've got two interlocking parts. Where can I show this best? Probably, cameras are hard. Two interlocking parts, each one had one end of the belt, and you had a screw between them that just slides them together and tensions the belt like that. So that should I don't know if you could see this over here in a future revision, maybe that would be a good upgrade there, just to make the design a bit less tedious. And I mean, screws don't really cost that much, anyways, or at least some sort of a tension over here that would yeah, that would not require you to insert this under tension. Okay, so let's just double check the manual again to make sure that we're not missing any steps, because I know we're invisible, because I know someone's gonna be angry with me if I miss some. So Y motor mount is adjusted, got that. Belt has to be in the axis with the belt itself. Yes, tighten the nuts gently. Tighten the nuts gently to avoid damaging the 3D printed parts. Yes, I did that. Okay, cable management. That's what we're gonna do next. Zip tie, zip tie, zip tie, zip tie. Okay, can do that. Let's do it like that. Okay, so these get just tied to the frame, or to the 8mm rods. There is a bit of a problem with this, as the PVC insulation does get pressed into the threads, so you might end up with a short in the long run if you move these around a lot, or if they get hot. Just something to keep in mind and to keep a lookout for. I mean, on the stepper motor or in an end stop, it's not going to be much of an issue, but if this were a heater, I wouldn't zip tie them to a threaded rod like this, just for reliability's sake. Why is it printing while he is building? Well, magic, I guess. Magic, I guess. Well, one way or another. Okay, got those zip tied and wired up. Avoid cutting the wires. Yes, I did that. So next up, leveling the y-axis. Place the assembled y-axis on a flat surface. Check that every corner is touching the ground. Let's do that. So it recommends to actually tap the corners to check if there's any gap between them, because it would, clap down on the table like that. But these look really good. These look really level like that. So next up, felt pads. These right here, just 4 felt pads with a sticky side on the bottom. That go directly onto the y-axis corners, or feet for that regard. That's one. Disassemble video in reverse. Well, that would actually be a lot quicker than the assembly video in regular speed. You can actually see the extruder type on the printer video feed. It is a direct drive extruder. I believe it is it's a direct drive extruder. There isn't much to them. We are going to see later on in this stream what sort of hot profile it uses, but overall, direct drive extruders are like, the dime a dozen. There is not that much of a difference between them. Okay, felt pad installed. Step 36, all done. Doesn't that look like sound good? All done. If it were in focus, all done right there. So congratulations, you finished assembling your i3 MK2. Not quite. So we've got the y-axis assembled, and next up x-axis. So this is where we're gonna see the X carriage, but not the extruder itself yet. All right, let's set that aside. So YouTube saying something like, "Oh, the stream was ended." No, it was not. There we go. We're still going strong. I believe I ran out of RAM or something. I don't know, but yeah, OBS crashed. OBS Studio didn't like something I did. I don't know. It might have run out of RAM or something. No idea. It crashed. We're back. I believe I lost most of my scene settings, so I am going to have to re-establish that somehow. Let me just get me sorted out again. ACAM Suze. I have to pay for the connection. Well, it's not my internet connection. Internet connection is actually doing pretty darn well, but this was it was just OBS giving in, crashing downright. Up. That should be okay. That should be back. Webcam's working, printer's working, audio is working. Hopefully, RAM upgrade already got 8 gigabytes. That should be enough. Resolution on the overhead web. Let's just double check everything again while we're at it. I guess that should. So this is like the more macro setting. Okay. So that should be okay. Audio isn't working. Audio should be working. If audio is not, well, I guess it's no use telling you about it. But if audio is not working, hit refresh, and that should refresh the audio for you. Layer height on the print, 200 microns. That's the default example print that was included with the SD card, or on the SD card for the printer itself. So yeah, I mean it does look pretty good. So. How often do I use my printer board? Well, it is doing a great job as a stand for the Fabricator Mini. I do use that one all the time when I'm like out on the road and just need a printer that works. That thing is like, you know, with a steel frame, you toss it in the trunk. You don't worry about it. Auto calibration, auto leveling, you know, just always works. But of course, if I have other printers available, I'm not going to print on the very cheapest, or on the almost cheapest one that I have. So while I'm in the studio, not a whole lot actually. So right, I'm kind of worried that we have 2 nuts left over. There are 2 M8 nuts left over from the previous step. So I don't know. Oh, but on the same token, we do have a bunch of zip ties, so I'm just gonna call these spares, extras, and keep them just in case. The y-axis subframe does look pretty solid, so I guess that that should be okay. All right, so you guys also have spares, so we should be good on that stuff. Okay, next step. Which window am I in? My mouse stopped working. OBS stopped working. Tech issues all over again. There. Where are we? There we. There we are. Okay, next step: getting the necessary tools for the x-axis assembly. So that's printed parts. Again, your baggie just for the x-axis. And your fasteners for the x-axis. Yes, there is a PTFE tube in the extruder, but it doesn't reach all the way down into the heated parts. So it does qualify as an all-metal hardened, but it has that PTFE guidance, at least in the cold part as well, and that's mostly useful for the area where the hardened transitions over to the extruder body. So that might create a ridge, and that Teflon tube just takes care of that and smooths it out. I guess that's what you need them for, right? Yes, there will be a review of the Mark II, of both Mark IIs, but I'm hoping they're going to be the exact same printers. So, yeah, it's not going to be next week. It's not going to be the week after next week. It's going to be probably 2 or 3 weeks out. So many other things to do. Yes, Atom 3D. Comes first, and then this one, a bit of other content in between as well, because I don't want to keep on doing review after review. It might get stale, you know. No, they are not sugar-free. I checked that they're 77% sugar. That's what that's the real deal. Okay, we need all these 3 plastic parts. So these parts are actually as orange as the little webcam on the down there. That frame. That frame is showing the most accurate orange. It is a really, really bright orange. It's like it's almost fluorescent light. So yeah. Streamer will end early. Check the Amazon reviews. What on Haribo Goldbeeren, on the genuine Haribo Goldbeeren? These things are awesome. Yes, I do use analog calipers. These are like 20 buck dial gauge ones. They're pretty okay. They've got a bit of backlash, but they get really nice readings. Plus that they're super easy to read. Yes, these are actually fluorescent orange. The printer is in silent mode right now. It was really resonating with the shelf, so we so we tuned them down a bit. We tuned it down a bit. So we need the 2 longest remaining smooth rods. And basically it says to prepare the rods by carefully sliding the linear bearings on the rods. Prepare the rods. So basically oiling them up. Oh, now it's really going well. Look at that. Now these are really sliding along well. Maybe. These are super loose, and you know, on the fresh one, they're really tight still. I don't know if it's like a wax coating on these rods or something. Oops. But this gets worn off pretty quickly. Yes, oil from the bearings. There is usually a bit leftover shipping oil and stuff in here. I guess that takes them off. And I hear the oil is also like not carcinogenic or anything, so no worries with, you know, your fingers getting on the gummy bears as well. So yeah. Now rod ends. We're just gonna press an Elm 8. Whoops. We're going to press Elm ATUs into each end of these. There's that. There's that. These slide in really easily. Okay, let's make sure these are aligned. Not good enough. Which type of oil is the best? I actually prefer grease, thicker grease, because it doesn't distribute as much outside of the printer. It actually stays with, or outside of the bearing, it stays in the bearing the best and actually lubricates and sticks to the balls as well. Machine oil, I believe for sliding parts, yes, but these are bearings. These are actual bearings with bearing balls in them. So I believe a grease would actually be better, but I might be wrong. You can press on the flat surface for easier insertion. Okay. Insertion was easy. Okay, now here we go, inserting our nuts. Should have shipped more Haribo? Well, we'll see. Are those packs actually? Are those actually included as a default? Those semi-big packs? Okay. Insert the square nuts. So these just get inserted into the ends over here. They just drop in. They're pretty loose, so no worries about stripping them, and or stripping them. No worries about misalignment them. That was what I was going to say. So the thing with hexagonal nuts, the regular normal ones, is typically if you insert them in a slot like this, they have less, they have shorter corners to actually ride against the plastic. So these square nuts are actually much more suitable for inserting. No, WD-40 is not great for greasing rods. WD-40 is a solvent and a rust remover and a cleaner, but it's not a lubricant at all. Okay, we've locked these two square nuts in place. So insert the rods into the fully printed parts. These actually go in here. Ah, that is interesting. So these screws right here, they actually reach through to where the if I can align this here, you can just barely see the screw threads on the back here. So these actually push against these rods and push them basically towards each other, which is kind of interesting. I do know that okay. I do know that some printers suffer from these actually pulling towards each other. I'm not going to insert this for now. From pulling towards each other and bending the z-axes. But this looks kind of interesting, you know. I'll have to see how these are actually used in the assembled version. Yes, the video will be available later on. It will be a regular YouTube video unless YouTube messes up the entire audio-video sync. Like it did last time, or time before that, which one was it, the Dynamo 3D stream. I believe I had to restart that one a few times. Or no, the very original one. Which one was that? The Hobby King Fabricator. Yes, Fabricator Mini. That one was very, very laggy and delayed and had audio and video out of sync and everything. Okay. So that fits. Perfect. Let's press on the other one right here. Those rods are 8mm, yes. Okay. Let's fix that. There we go. The good thing is these 8mm rods aren't like super tight in the ends right there, so if you need to slide them out, you can always do so. But they aren't as loose or so loose that you would actually have you know, have them wobble around. There you go. Yeah, so the Tavo guys, Tavo Tarantula and such, they've actually been pretty aggressive and pretty annoying with their marketing and their you know, just pressuring to get a review and to get you to look at their machines. So far, I mean, I haven't looked into them, but it looks like a very average i3 Chinese version. Again, without having actually looked in depth at the machine itself. Okay, so that works. We've got the bearings on here. Next up, preparing the X-end idler. So we've got the aluminum idler again. We're gonna need the M3x18. So these are apparently all M3x18. And we should have the bag to double check that, so let's just do that. M3x18, okay, so there's only one type of M3 or longer M3 in here. We should be good. Now with the what I just realized with the LM8U bearings, there was one single LM8U in the X-axis package and one single LM8U in the Y-axis package. They typically come in pairs, you know, in those little baggies you just saw. And basically what that means is they open up one of those bags, put a single one in this bag, and put the other one in the other bag. It would have been much easier just to have these, in the full dual package, and then you know, have the user separate them. But instead, which I really appreciate, they separated them and made them and assigned them to their respective jobs in the X and the Y. So you get the exact right amount of LM8Us for the X-axis, and you get the exact right amount of LM8Us for the X-axis as well. That is awesome. Yes, so the webcam's image, that is actually more accurate in the end. I've tuned down my... Ooh, I guess I shouldn't tighten that much. I actually did tune down the saturation, contrast, and everything on my main cameras. So this one and the one on the printer right now, this is basically the raw look I'm getting when I'm shooting my videos, because I do like that maximum control. But last time I also realized everything that was like bright was completely blown out. So this is, again, what you're seeing here and what you're seeing on the printer is the raw color from the cameras. What the webcam is showing is most accurate to what I'm seeing. It is a bit less less reddish. It is a bit more fluorescent, evenly. Yeah, it is more reddish than what the overhead camera shows, and it is a bit more yellowish than what the webcam shows. Okay, got the X-axis and idler assembled, so there's a little idler in here, right there, and then the belt is going to feed through this side over here. No, I fixed that. So this one goes on like this. That should be the correct that I swapped out the bearing and that. So now zip ties. It is again important to keep these oriented correctly. Let's just move this one a bit further over. So basically with the zip ties heads towards the double bearing side. Where is that going? Okay, so this one is actually curling up quite a lot. As you can see, it's coming out up top here. But I guess again, it's kind of impressive to see the stock print quality on the machines that are pumping out these parts day and night to be that high that these long zip tie holes actually come out that flawlessly. Okay, so that's that. Now I am, yes, Joe, I'm seeing that. I do have to assemble this one the other way around. Get in there. So with the flat sides facing me, I'm gonna have this one drop in place. There you go. I know. Okay. I guess it would work if you just put it the other way around. Just have to adjust a few offsets like that. PC air cleaner to get the print off the heat bed. Yes, that could work. More sugar. These need to be all the way down here, or up here, depending on which way you look at it. But all the way on the sides here and there. The manual does take note of that these need to be very properly aligned. And of course these do need to be tightened up. You can get like specific zip tie pliers or zip tie guns or whatever you want to call them. I've used one of those before, but they're like super unimpressive. They're basically supposed to be like a one-stage zip process that tightens the zip tie and then cuts it off flush, but super unimpressed with them. Of course, I only use the cheap one, but this just gives me so much more control over how I'm positioning the zip ties and how much I'm tightening them. Let me check back on the print on the print back here. So there is this one oozy bit over here, right there. I am not sure where that came from, but I guess it's we can call that good. This is we're printing a frog. It's like a really tame little cute frog, big eyes. You know, just wait for it. It's gonna be an awesome frog. This is, yeah, like I said, the big cameras pick up the color a bit incorrectly, but where's my mouse? There's my mouse. That's not how it's set up. There you go. The webcam does show this one right here. Does show the colors the most accurately. It is a very vivid, very bright orange with the facing towards the opening. How do you stream with 3 cameras on OBS? Well, you basically, just show you real quickly, basically buy one camera. There's the first G7 with the Samyang wide-angle lens. Then you buy a whole bunch of these HDMI capture things, which are a pain in the ass to use. Then you buy another camera like that. Then you buy another. There is the blue ring. You buy another HDMI capture thing. Then you buy a webcam, and you plug that all in. Spend about 5 hours configuring everything, and then maybe it works. That's how you. That's how you configure that. Really simple, overall. Just keep in mind you can't use any old mirrorless SLR for this. You actually have to use one that does live HDMI out. The G7s I'm using actually do 4K HDMI out, which I don't have the money to buy capture cards for. If I did, I would be streaming in 4K. But these also do very good 1080p live out. So we're good on that front, I guess. Foam pad on the ceiling. Yes, there is foam pad on the ceiling. There is a carpet actually. Here, let me see that over there. This is a full-size carpet on the wall. There are some more carpet strips over there where the printer monitor is in front of. There are more foam pads on the ceiling and on the side in front of me. It's basically just for audio echo dampening, more or less. Why do my hotkeys not work anymore? Come on! You can zoom? No, this one. There we go. It's a mirrorless camera. That's all it is. It's a Micro Four Thirds camera. If you're interested in all the gear I'm using for streams and for regular content, I do have a list on that on toms3dp.org. That's toms3dp.org/my-gear, my-gear. Okay, got the motor in there, got the wire in there. Let's see, next up the pulley. Okay, so the pulley will be positioned on here with the, what is this part called? With thicker part facing away from the motor's body, and then adjust it so that we're gonna have like a straight line through the first X end down to the idler on the other. So I'm just gonna eyeball that because that's what it says to do. Right there. Why didn't I just buy 4 A7Ss? They're kind of more expensive. So, tangled roll of filament straight from the manufacturer. So, I'm gonna say it again. I just said it when I unboxed the spool. There is no such thing as a tangled roll from the manufacturer. It is always your fault. That might sound harsh, but that's the way it is. The manufacturer does not have any way of spooling, of rolling up a spool that would create like a cross between two paths. Yes, they can spool them loosely and then tighten them up afterwards, but that very rarely happens. And that wouldn't create like a super tight lockup where one filament strand would actually pull up on the other that much. They would fix themselves over time actually. So the most common tangles happen when you let go of the end of the filament and actually have it cross underneath another string or strand of filament when loading it into the printer or when unloading it. So yeah, like I said, the manufacturer can't really mess up the filament winding on their own. Okay, so end stop right there, and this is kind of cool. There's this, if I can show you. Okay, webcam won't focus. There's this notch, you can barely see it. This notch right here that basically tells you where the switch of the end stop is supposed to end up. So we can align those two up and then screw them in. Is Haribo suitable for vegetarians? No, it is not. There's gelatin in there, and that is neither vegetarian nor vegan. So yeah. Sugar-free Haribo. That's gonna be the new meme of the stream. These hex wrenches, the included ones, are just the standard type with no ball end. At least these this little set right here. This 2.5mm one for all the M3 screws that does have the ball end on them. But in general, these are just the straight end ones. Okay, end stop is mounted. We push that towards the center of the axis. So it's telling me to double check that this one actually triggers. And it does. Because there's actually still a little gap between that. That's exactly what you want. So I believe that should be, well, except for cable management. Okay. Let's wrap these two together. And let's get going. Yeah, Angus has reviewed i3 clones. I have also reviewed a i3-ish printer. I wouldn't call it an i3 clone because it's not. It's like an original design. The Malian M150. No, it's such an awesome machine, and you know, clones are always, wherever you buy them or whichever one you buy, you're always going to get a different machine. So you would really have to review all of them to get the complete picture. Yeah, Angus was here, but you know, Australia. I don't think anyone from Australia is still awake at this time. It's like 4:30-ish a.m. So spiral wrap on the cables right there. Don't be nervous that there isn't a belt. We'll get to that later. Okay. So there doesn't seem to be any sort of strain relief on the motor cable right there, right on this point over here. Let me just check on the production machine. Nope. There is not. So that would definitely be that would definitely be a critique, a criticism from me. I would definitely put some sort of a stick-on zip tie hook or anchor somewhere on this motor and tie the wires to that first, because if you do directly, you know, wrap them up to the motor like that, you do strain the solder joints inside the motor directly. These motor wires are soldered directly to the copper wires inside the motor, and those solder joints do like to break. So yeah, you can fill up the motor's outlet with hot glue as suggested, but the hot glue does like to melt. You know, it is after all a thermal glue, and that will melt and soften as the motor heats up, and very often the motor will heat up so much that the hot glue will not do its job that much anymore. Yeah, so it is 4:30 here. You know, by traditional estimates or yeah, any estimates really, we should be done building this thing, but I do blame it on you guys. Okay, so that is the x-axis done. Right there, get a good view at it. Again, the Prusa research labeled motors, that is pretty sweet. Fortunately, this camera does not focus very well, so yeah, that's the axis done. No belt yet, but the carriage is on. Not even halfway yet. So Z-axis assembly. Let's get the next baggie. Now check if the carriage is backwards. It is not. At least I don't think it is. We're gonna see later if it is. Standard tools for a 3D printer? Well, basically any standard tools you'd use for any sort of electronics or mechatronics or, you know, for any sort of maker occupation, more or less. Because it's the same tools either way. It's a bunch of pliers, it's a bunch of screwdrivers, it's hex wrenches. Just your basics. A 3D printer does not need specialized tools. You typically don't need an oscilloscope to work on it. You typically don't need any fancy electronics gear like that to keep your printer in good shape. And then of course, like the slightly specialized stuff, like those spatulas for taking off the print of your bed, if you want to do it that way. But in general, not really a whole lot. Yes, the Atom was done. I think it was like 1:30 a.m. or something. So yeah, we got that done, but it sure was a long ride. Okay, so there are 4 longer screws hidden in here. Just gonna pull those out before we mix them up. So these are M3 x 12, and the other ones are M3 x 10. So yeah, careful with that. Builds are very slow but careful. Well, I guess Joe might disagree there. Slow, yes. Careful. I try most of the time. Tighten them gently. Yeah, 4 to 6 hours, that sounds realistic. Like I said, doing it on stream, doing it, answering questions, interacting with you guys, trying to fry some sausages on a heat bed, that all adds to the build time. That all adds to the build time that I get on stream here. Typically this isn't a super involved build. Yeah, those 4 to 6 hours do make sense. I guess you can build them faster. I guess the guys, yeah, there's a comment from Joe. The guys at Prusa printers do build them a lot faster because they're the exact same kits you're getting. Maybe laid out a bit differently, maybe not packaged like that, but yeah, same parts. Yes, these are the parts with the right orientation. So basically, you need the hole for the Z smooth rod pointing towards the outside of the frame. Tighten them gently again. No superhuman force required. Yeah, unfortunately, that sausage frying experiment did not go well. I think YouTube DVR might allow you to jump back to the point, but yeah, it didn't go well. The bed gave up. The heated bed on my Cerberus Reborn, I had it up to 200 degrees. At least that's what it reported, but fortunately that was the end of it, and we got a huge blister on the bottom where it peeled off the aluminum. And yeah, once it's not transferring energy into the aluminum anymore, it is just heating itself up, and that really gets up to an insanely high temperature insanely quickly. These are perpendicular, mostly. Okay. We got these installed. Next up, the Z-axis Z-screw covers. So these, I guess, cover. These cover the motor bearing on top, as opposed to keep any dust or grease out. Let's try that. These are not going on well. So there's the end part, the end nut that needs to go. There we go. All the way down onto the motor. Yes, it does use 1.75 millimeter, but you could use it for. You could convert it to 3 millimeter, but you would have to print a different extruder body. That would probably be the best way to go about it, because I mean it's all open source. It's a standard, and I am sure there are other upgrade, side grade, mod parts available for it. The MK2 does not have an aluminum bed. It does have a thick PCB heater bed, basically FR4. 3 I believe it's 3 millimeter. It does have the 6 millimeter thick aluminum bed and the aluminum subframe. So, or the bed subframe. So everything that's carrying the bed is that 6 millimeter thick aluminum. Oh, that's working surprisingly well. So the frog is printing at 210 degrees. That is just the default setting. The sample basically that was on the SD card. Supposedly the filament, from what chat is saying, the filament does like 200 more. But I don't know, guys, that looks pretty good. That looks extremely good right there. I don't know, I don't think we got any sort of quality issues there. 220 might not be too high for PLA. The thing is, thermistors, pull-up resistors, all have tolerances, so what reads as 220 on one printer might just be 200 on another. So if your PLA needs 220 to print well, then use 220. And yes, as with any filament, I would actually recommend not being in the same room while it prints, just having some sort of vent. I've got the window open over there. To just keep the particle count down and to give yourself a bit of an easier time to breathe. I think the frog is turning out pretty well. Yes. Wait. What? So there is a left and right motor. It actually says to make sure that these are on the right sides. I'm a bit confused as to why you have one that is dedicated to the left and the other to the right. But if they say so. So which side should we have the wire coming out? Okay, so towards the back actually. Okay, that is right. Left. Yeah, lower versus high temperature filament isn't really an indicator of quality. It's just, you know, it's how the individual filament was set up, what sort of additives are in there, what sort of base polymers they're using, and you know, good versus bad filament really isn't that easy. That there's no black and white. Some filament is always going to be better for some jobs, while other filament will do different jobs better most of the time. I mean, that there is the odd one out that is just, you know, really bad, but usually it's going to be it's going to be, you know, good for its own job either way. The orange parts are okay. Now I see why. Now I see the difference in. Now I see the difference in why there's a left and a right motor. Oh, that's the one I wanted. So we've got different length cables on there. Is this one out of focus again? Maybe better. We've got different length cables. One is coming loose, and the other one is configured with a much longer motor cable, basically. Yeah, so someone posted about Tallman 3D filaments having those weird spots where your filament diameter suddenly goes up in the middle of the spool. Again, odd ones out. I do believe Tallman does make relatively good filament, but stuff like that does happen. Of course, it shouldn't end up on a customer spool, but yeah. What's going on? Yes. There are washers included here. Good thing I've got that detailed webcam set up, right? Or nobody would have been the wiser. So I think the estimate on 6 hours is pretty close over here. I mean, it is sliced for this exact printer and probably timed before that file name was made. So those 6 hours should be pretty close. We're at 1 hour 36 right now. So who's seen the? No, it's a frog. Come on. So who's seen the frog last weekend stream? Any recurring visitors? Okay, so one of the recurring themes seems to be people going to bed and then coming back after they've taken a nap or taken their daily slumber. Yeah, surprising amount of people did see that and did get the meta, so... Yeah, I've got the same window open again. I'm hoping maybe we can get another visitor today, but I would have felt bad for the frog if that one was like in the Kellerschacht. That's what it is. You know, in the light thing that comes down to this basement room. So, question from chat. So, how do we switch from ABS to PLA? Basically, swapping out filament while you're what? Sign the frogs. Okay. When you've got PLA in your extruder and want to switch over to ABS, or the other way around, well, you know, PLA isn't gonna. PLA is not going to bother that much if you heat it up to 230 degrees. Yes, it's gonna get a bit liquid. It's gonna run out of your hot end, but it's not like going to carbonize instantly and block the entire thing. So basically, just heat it up to 230. Push the filament in, push the new filament in, and should be good to go. Not enough ventilation. I've got the window open. Might not be enough, but yeah, Frank. So the motors with the spindles. So these black things right here, you're referring to. These just scream off. These are 3D printed lids that sit on top of the bearing right there. So I guess that they're just some sort of a dust cap, but they basically, you know, you screw them on all the way and then they sit on there. Nothing really too spectacular. Yeah, pizza unfortunately does not get delivered here. I'm like, again, in the middle of nowhere. Very rural area, so you know all the big sites that you could order stuff at, they don't deliver or deliver to the wrong city apparently. Yeah. All right, so got that and M3 washers. It did say in the manual. Okay, so let's grab the X-axis pre-assembly. So we've got, oh wait, only two? No. Okay, so there's a slot. There's a slot back here where this one right here, where an M3 nut will sit in, and then a yeah, another spot right here, essentially, where you can just drop one in. That's that, and the one in the back here. I'm gonna do that with the pliers. There we go. 1, 2. Now these actually came with the motors. These Delrin, I believe they are nuts. Yes, these are 8mm 4-start lead screws. And they seem to have a around 8mm pitch, I believe. Okay, so these go on like this. So the little extended part here goes into the bore of this printed part, and we will be using the longer M3 screws to tighten these down. So that's interesting. So these actually have 2 holes, these that have an M4 thread, and 2 through holes that look like they are for M4 screws. So I'm going to use the ones that have the M4 thread in there, because that might give me a tighter fit. Well, we can measure. So these are 4 starts. So each one of these is going to be 1/4 of a rotation. So that's 2mm. Wow, you really can see that scale here. That's 2mm on each. So if we take 4, because again it's a 4 start, we end up at pretty much exactly 8mm. Please, guys, do not order pizza. It will not arrive. We tried, it don't work. Okay, so that one's on. Let's repeat for the other side. Yeah, unless you guys have drones that would deliver stuff here, it's not gonna happen. Sorry for the disappointment. But you know, Germany, Neuland, 2016, it's like, it's not gonna happen. Yeah, so what was the question there? Yeah, printer sizes actually. Oh, I should be using the long ones. Printer sizes. Why are we? Why are we still stuck at like 8 inches or below? Well, there is a relatively easy reason, and that is if you print stuff that is larger, it's going to take forever. Print times go up to the cube. I mean, if you scale up a part just equally by the factor of 2, you're going to end up with a print time that is 8 times as long. So yeah, you're quickly moving from it's half a day print to well, it's going to take half a week. So that's just my thought process of why printers are so limited in size. Plus, you're gonna use a lot more material, and that also costs money. Whoops. Current print time is 1:45. Okay, so next up we are going to insert the Z-rods. And it appears these don't get locked in or anything at all. These just get pushed in. Because all it says is, you know, insert. Over here as well. And there we go. And these rest against the motors, which is okay. Yes, and of course, for larger printers, the entire topic of having a reasonably or suitably stiff frame does get much, much harder the bigger you go. Okay, so these will get assembled like this. Tighten parts to the frame. Okay, so that's going to be the last. Alright. These are going to be the last parts that sit up here. Okay, but for now we can attach the x-axis to the main printer frame. Let's get these on here. And you do want to be pretty careful with these. Don't want to crank them in at an angle that would kill the bearings and likely bend some stuff. So, in case you're still wondering what sort of pitch these lead screws are, let me just demonstrate. You know, you can actually push these down by hand, so they are really, really steep. So that will explain why they are so fast. Okay. All right, and lastly, no washers. The Z end holders for the smooth rods, and I guess just a rough capture thing for the spindles right there. So these do have a springy element in the center right there. Yes, we're at 4.12, so chapter 4, basically, Z-axis assembly step 12, placing the Z-axis top parts. And these are really, really tight, so takes a bit of force to get them on there. That's good. So I'm going to slightly adjust this down a bit. There we go. Okay. Now, so flexible shaft extruders. I was actually asked to review one. I believe I forgot to follow up on that, but basically, it's a concept that we've seen or that has been tried with not only with deltas but also for a few other geometry choices. So basically, any sort of concept where you get your extruder motor away from the hot end without actually connecting a pressurized Bowden tube per se. So either it's a rotating shaft that goes like along the x-axis and then spins like this and drives the extruder gear right there and has the motor on the end, or it's some sort of an H-bot belt setup on the one extruder motor on the side and one X motor on the other side. That has all been thought about and experimented on, but there was always some sort of trade-off that had to be made, and mostly it was not worth it. So yeah, we're gonna have to see what else pops up that might actually be viable. You know, the flex shaft extruders might be something great. I don't know, I haven't looked into them. Of course, they do create the issue of where does the torque go. So unless there is some sort of a counter torque drive, so where you have one rotating Bowden shaft that goes one way and one that goes the other, so that the torques actually get cancelled out. I would think that that a typical Bowden effector would not be too stiff enough to take up those forces and, you know, stay accurate at the same time. 30 delay. It should be better today. I switched YouTube over to the low latency mode, and people did comment it was rather. It was much better today, but we'll see. Yes, these slide because these have an 8mm pitch, so yes, you can really easily slide them just by hand. Guys, please stop posting porn in the chat. Ah, but first layer porn is okay. Okay, we are supposed to do some cable management. So, from this perspective, basically the webcam's perspective is kind of off, but we should be sliding these up here. This one over here, and then basically they... what? So basically these two meet up at this point right here. Like that, and then this one gets zip tied to the bottom all the way along here. Okay, that makes sense. Zip ties. Yep, that is a proximity sensor. That is a custom-made one, as Joe said. It's a 5-volt inductive sensor, I believe. But the special thing about it is, yeah, 5-volt, and it's an 8mm sensor, so it's a really tiny, thin one instead of the common 12mm ones. It's a space. I don't know how accurate it is. I guess it is very accurate if they're using it for auto bed leveling and mesh leveling and XY calibration, that sort of stuff. But yeah, custom made, really small, really tiny. Nice stuff. Alright, got the wires sorted out there. The probe also triggers on other metals, so the bed has a lot of copper in it. It's the copper heating traces that basically make this function. It does not have any sort of aluminum, it's just got the regular copper clad on either side that a PCB has. I want to just slide this up a bit. There we go. I'm in love with the Z-axis already. Yeah, so really smooth, really steep, really smashing those colors down. But essentially it is time to assemble the Y-axis into the frame. So the idler goes towards the front. This my right side is the front, so it should drop in like that. How many printers did I build in the last years? Depends on how you calculate, but at least like, whoops. In the last year, probably around 10 or so. Because I did build a few for BQ, so that does count, I guess, while we're still working there. Oh, that's slightly lifted up. Okay, so the question is, the assembled machine does have these. Let me just show you. So the assembled machine does have these frame corners right here, not sitting on the ground. It's got like a 2 millimeter air gap between the surface the printer is sitting on and the start of this part. So it's actually assembled like that, more or less, with a gap in between. There, so there's the gap like that. Mine kind of looks like it wants to sit flat on the desk, which from a stability standpoint I would say makes more sense, because you're actually transferring forces into the table here instead of going through the threaded rods. But I think they should. The frame is supposed to be above the ground, so I guess yeah. So that's also what the manual is showing. It's also yeah. Basically, it's telling me to let this one drop in as far as possible. So that's, the manual is actually showing it upside down, which doesn't make any sense at all, because it kind of, would drop out on its own. So what I'm gonna try to do is I'm just gonna put something underneath these edges on the frame. For example, the two 3D printing handbooks, and have them, create that spacing like that. That actually gets it pretty much all the way in, which is exactly what I want. Yeah, that's really nice and tight. So I'm going to tighten these up like that. frame sits on the table, it will be noisy as hell. So yeah, I don't feel like putting this one upside down is gonna be that great. But like this, these are perfectly you know, bottomed out on the aluminum frame. Okay, yeah. So comparison between the Hephaestus the BQ Hephaestus 2 and the Joe Prusa Mark II. Yeah, so a bit of a backstory because I don't want to get any false impressions here. I did work for BQ beginning of this year, and I did get fired in April this year, so you might say I'm still a bit salty about that, and I am, yes. But that aside, as much as I can be neutral on that matter, just the fact alone that the Joe Prusa i3 has a heated bed is a huge advantage in just how flexible a machine is and how powerful it is overall. So that would be one of the things I'd have to give towards the genuine i3. Also, all that, you know, that entire stuff. The entire stuff with auto leveling and auto slant compensation, that is really awesome to see. The only thing, okay, it's standing on the wire there. The thing is, though, both machines have that. Well, the genuine i3 has the auto slant compensation, while the BQ machine does not. But the BQ machine also has an easier assembly on the subframe, since it uses pre-cut and pre-cut smooth rails all the way instead of threaded rods and manual adjustments. So it's a bit of a different target group. So the Hephaestus 2 is a bit of a more how do I say it, designery, non-makery machine. It's a bit less open, you know, no printed parts, all aluminum milled and stuff. But overall, I think the Prusa Mark II is the more powerful machine. Heated bed, E3D hot end. I haven't tested it, but I don't think it's gonna outperform the Hephaestus 2 when it comes to flexibles. But I don't think it's gonna outperform the Hephaestus 2 when it comes to flexibles. But it should still be able to print flexibles, right, Joe? So yeah, in general, I would buy the Prusa one over the Hephaestus. Hey, Niels is there. Hey, Niels. You sucker. You know, guys, Niels is sitting on the beach right now. You know, got his feet up in the air. You know, sipping on the beer. Yeah. But happy for you, man. Enjoy your much-deserved vacation. Yeah, why did they fire me? I think BQ is going to be kind of pissed if I talk about that. But it was entirely their fault, basically. That's all I'm going to say. I did work at Harman Becker before that, automotive supplier, designing car amplifiers for BMW, basically, as a hardware engineer. So that was that. Okay. My nuts are tight. That is good. It is oriented correctly. So now we shall insert a belt. Right there. So we are going to need some more parts for the X-axis belt. It's interesting that these things are the X-axis belt is in the section for the Z-axis assembly and not before that. Well, let's just see where we're standing as far as parts go. axis, that's the LCD. So we do have another belt. That should be all we need, right? The Hephaestus, I can actually show you what sensor it has. Because there is a box with EQ stuff here. Did I? Hold on. Up here. Apparently I can't find that now. Wow. Okay. Well, I was going to show you the Hephaestus 2's Z probe. It's basically it's a little custom-made PCB, a little L-shaped PCB that wraps around the hot end, and it's what's that clicking? Yeah, and they're saying basically it is a custom-made PCB inductive sensor with better temperature compensation than what you typically see on the industrial-style end stops. What they're saying is the temperature compensation is not smooth on the industrial probes. So if you have a slight temperature change, it might jump into a different compensation range and give you completely false distance readings, which I have not seen on an actual probe, or not observed on a probe yet, but apparently it's a thing. Okay. The flat part of the GT2 belt, longer one. Longer one? Note the belt is knocking out of the X important guide the X belt along the X and I line. Okay. Yes, you can use a micro switch for I keep switching to the wrong camera. You can use a micro switch for a Z end stop, but you're also going to need a servo or some other way to drop the switch down once you need it, and to retract it once it is done probing. And I'm not a huge fan of those sort of setups because they are mechanical, and anything that is mechanical can fail, especially if it involves something like a servo or a C-car servo and some sort of linkages. Those aren't, I don't think those are like the best choice of parts for being around, you know, the heated bed and the hot end, and for that sort of application. Plus they aren't super accurate or anything, so yeah. Jay Crowder, when using an SSR for AC heated beds, how do you protect yourself from touching the live side? Well, you just be careful. Just be careful. Just don't touch the parts that have your live wiring on there. Or put some tape over it. Or some SSRs do come with covers, so yeah, just be careful. No belt going out of the X carriage. Ah, okay. Now I see what that means. Solenoid, yes, solenoids also work and are supported by some firmwares. Okay, so this part of the instructions, it could be a bit clearer. So it says make sure there is no belt going out of the carriage, and then a little arrow. I thought that was how you're supposed to push this one in. But it actually means there is supposed to be no belt sticking out from this edge over here. Now this webcam isn't really focused well, but this bit of belt over here should not be sticking out of the carriage, and it looks like it's not sticking out at all, or not sticking out enough that it's going to cause any issues. Now we're going to guide this around the pulley. Come on. Yeah, so as far as SSRs go with DC beds, I would never recommend using an SSR with a regular DC bed. It's just, why would you do that? You can use a MOSFET. It's much cheaper, it's much simpler, and more efficient. That's basically the entire deal there. A DC-DC SSR is most of the time going to be much less efficient than just setting up a MOSFET properly once. So really, yeah, I don't see why you'd want to use an SSR for that. Just go the extra mile, do MOSFET, be happy. I just got looser. Nightbot is my bot. I ordered him here. I set him up. He's cool. So the links he's posting, he is, are the real deal. They are links to my channel, basically, where you can get subscribed to regular weekly videos. Just in case you stumbled on this channel or on this stream through YouTube's amazing suggestions, and might not be familiar with what I normally do, because I do usually make 3D printing content, guides, reviews of this exact stuff. So that is a legit link for getting subscribed. Also, the stream tip page is also very, very legit if you want to. Nope, that's the wrong button. If you want to send me a tip for coffee, beer, or whatever, or for just being entertaining to you, you can, I'd always appreciate that. Yeah. Tight enough for a tight E yet. So it depends which side you pull, but and now it just kind of got loose again. Did this one settle? Oh, okay. So here's that is interesting. Okay, now I can did I miss a step? Now these end screws here on the X-axis idler end, they are kind of interesting because they push in the smooth rods and push these things outward from each other. So the question is, do I need to tighten these now? Do I need to adjust these in any way right now? Because it feels like the belt is actually pulling these inwards and untightening itself that way. At least on the middle of the. Okay, that was too tight. Or was it? At least towards the center of the link right there. But actually that feels good. Also belt is tight. Okay, so that should... You can completely leave them out on MK2. Okay, so I'm gonna untighten these just a tiny bit because it does feel better if I have them tightened. Okay, that feels smooth. Belt is tight. Let's move on. Okay, so is this printer any good? Well, see for yourself. I think that print quality is pretty good. Okay. Congratulations, you have just assembled the Z-axis. You can continue by assembling the extruder. Next chapter, 5. Yes, the extruder head can be replaced with any extruder you want. Switch you back onto this view. I can show you on the webcam right here. This is what the actual printer itself is. So you've got these 3 mounting holes to which you can mount anything you want. You can put a completely different extruder on there. You can add completely different hot-end extruder tool head choices. You can put a laser on here. You know, whatever you want. Basically, the only limit is the main board, which I guess that's the box. That was the box I was looking for. So, Rambo Mini, that's what it is. So this one is a 454. Okay, this one is a 4 extruder motor board, so 4 stepper drivers right there. So you are limited to X, Y, Z, and an extruder. But you can always put a different board in here. For example, the regular Rambo, which is a 5 motor board, or any other main board you would like. So yeah, that's the quick answer on that. Okay, so I guess for now we can move the printer frame out of the way. And yeah, one more thing I should note, this is, let's say on here anyway, this is the real deal from Ultimate Machine. You probably can't read that, but this is not a China ripoff board. This is the real deal, again. Just like everything else about this printer. Okay. I feel like I should grab some more to drink. My throat is getting sort of dry, so I'm going to switch you back to the big printer view for a second. I'm going to refill my water, and next up we are going to assemble the extruder for the Mark II. Alright, be right back. This is supposed to be green tea, but I guess it... I don't know. Let's hope that turns a bit greener in the end. Okay, alright. Something is wrong with that frog, yes. No, actually. What would be wrong with that frog? Just get you guys a view of the other side as well, because it does have... Should be able to move it, right? Yeah. There you go. It does have another side as well, just to mix things up a bit. There you go. Focus real quickly. There you go. And this camera does need a new battery. This one's gonna freeze up for a second and it should come back on its own, hopefully. why does it keep resetting its ISO? We're back. Okay. It's an itsy bitsy tiny spring right there. So print time is at 228 right now. So this green tea is like more of a yellow tea. Okay, let's move on. Extruder. So I guess that that's what E-axis refers to. Let's get back into this view. E-axis, that's that baggie right there. Frog layer height is 0.2 millimeters, 200 microns. At least that's what the LCD says. Right there, if you can read it. 200 micrometer, 6 hours. That's the idle in the frog. 28%. That is interesting. I'm guessing this one will go a lot faster in the upper layers. That's good. Okay. Would be a Taurus a good test for a 3D printer? Well, the problem is with test parts for a 3D printer, they only test like a very, very slim, cross section of what you actually want to see on a 3D print. So a single part is never going to get you a complete image of how well your 3D printer is tuned in, or how good a 3D printer works in general. So what I like to do is I like to print a whole bunch of, hands like that. What do you do with them? I always like to print a whole bunch of real world items, because like stuff like 20mm cubes or 10mm cubes or a torus or ball shaped thing or anything like that, always only test that one exact part. Same with the 3D Benchy. Well, the 3D Benchy is a whole lot better already, because it has so many different challenges on it. But the Benchy also has one problem, and that is it's small. It's only testing print performance on small things, on like really tiny objects. So a printer that does go fast but uses rather comparatively low accelerations is never going to get up to its full speed. So yeah, what good is a test that only tests a really tiny object? You want to get in really close? Well, I can just zoom you in. How close do you want to get? Is that close enough? Is that close enough for you? So we're doing all Zoom stream now. I mean, I can send you guys in a bit. I guess the 10 times zoom is kind of overkill, but something like that would probably work. You can get the focus right. That should be better. Oh, okay. Yeah, I've got the webcam. The webcam is going to do that once I get the parts sorted out and get going on the part of the build right here. Okay. So I guess that would make a better B-roll shot like that as well. I've got black bars. That's interesting. That should be good. Okay. Yeah. The thing about the Benchy is the Benchy guys actually tell you do not scale the Benchy. That is, against the code of printing it, because you want that comparable print. You want that print that always has the exact same parameters used. So scaling it would change some of those parameters and change what the Benchy test says about your 3D printer. So that's by design. It was supposed to be small enough so that most printers can print it in a reasonable time frame. Usually it's around 1 hour, and still include as many tests as possible. Okay, so I placed my nuts in here. I placed the M3 regular hex nuts in here and in here, and then the 2 slide-in nuts on the slots over here. So that's done. Slide the extruder body on the nozzle as shown in the picture. So I believe that is hot end, the hot end that is being referred to here. So we're taking... We need to drop stuff in here too? No. Am I missing a part? Oh, okay, that's just that perspective. Okay, so we are sliding the hot end in all the way. So this has got a... This is the filament hole up here, so it's slightly conical where the Teflon tube will sit in. So you basically slide it in at an angle and then push it down with the wires facing towards that. Okay, facing this way basically. So there you go. There's the hot end installed. That fits pretty well. Make sure the cables are on the side as shown in the picture. We got that sorted out, yes. I guess the reason for printed parts is not just having, having the wrap roots. Of course, that does play into it as well. Having parts that people can reproduce by themselves, for themselves, and modify them by themselves. But as Loadspot is showing as well, having a print farm can actually be more economical for you if you have a mid to low sized volume for the parts you're making. Sure, injection molding is super cheap per part, but unless you like doing super high volume, it's also not super cheap. I showed the extruder to the monitor. Is there a camera? Is where a camera? There's a camera. Yes, that's a webcam. Top not insertion. Okay. So we're going to prepare the, whoops, we're going to prepare the extruder cover and drop in 2 more nuts into these long holes over here, one over here. So yeah, the one critique I'd have with the build manual is that the images are very, very small, and it's kind of hard to make out the details because often you'll get, I'd have to turn this one on. I'm going to show you here. Often you're getting these pictures that have a lot of white space around them, or up here that just are basically white space and the actual part only shown very, very small. So that would be, I guess, a very easy layout fix. But of course you can always follow the online manual. Yeah, you can always follow the online manual to get the full high resolution images of each of the steps and of the included parts, of course. So we have inserted 2 nuts there. And we have already inserted that nut. Okay. Got that, got that. Okay, so there's the M8 times 18 and there's the nope. There's the M8 times 25 screw. Mind the correct orientation of the cables leading from the extruder heater. So we're going to assemble the heater cover onto the, yeah, like that, with the wires facing away from the solid plate here. So these just drop in like this. Wow, and that is pretty close to the heater block, dare I say. So if you look down here, there's actually no. There is actually a very, very small lip that goes almost all the way up to the heater block, and I guess this is where the part cooling fan will sit. But it's pretty tight to the heater block. I don't think it's going to actually be an issue, but interesting to see nonetheless. Yes, it is a 12-volt machine. It's got a webcam set actually sitting on a 240 watt 12-volt supply that powers everything. So, yep. So this one gets the 18 and this one gets the 25 millimeter screw. The parts are actually fluorescent orange and neither cameras show it relatively accurately, so they are not quite as bleached as the small webcam shows, but they're also not quite as yellow as this or the printer camera show. The big cameras, the 2 G7s, are tuned down in their color saturation. That is the default setting I use to record things for regular content, to give me the most leeway in post to correct colors. If I left it on default, it would just blow everything out by default and give me nothing to work with in post. So yeah. No, the webcam is relatively good. Yes, I guess I could try to get this one. Yeah, but see now that's not better either. Now this one is showing it yellowish as well. So I'm gonna, wow, what can I use for reference? So that should give you, oh yeah, that should give you some reference for the white balance. But it's still, even if I tweet this out, this is more of a peachy color, I'd say. Let's just tweet this out. At Tom's3DP, that's the Twitter handle. Does this work? So sample. There you go. Yeah. Twitter @Toms3DP does have this image, so you can watch it on your own, look at it on your own screen. I think, at least my phone screen is not showing it quite as saturated as the actual part is, because this thing is mostly 100% saturated, at least to my eyes in this sort of light. Okay, got the cover on, tightened that up, done. Thanks for the link, Tiger, Taller. Yeah, I do have fluorescent light. I can get the high quality LED panels that supposedly have a very accurate color reproduction, but then of course I'd have to tune all the white balances again. So I guess now on that is roughly what it looks like, at least if you're looking at the webcam. That is roughly what it looks like. The other cameras I'd have to adjust the white balance to show up accurately. Alright, extruder motor. That is actually the last motor we're picking out of the motor box over here. That's all of them done. Silicon packet. There you go. Motors cleaned out. Yeah. Yeah, so I guess this is going to be really tough to reproduce color-wise. I'm gonna color correct the review, which should be out in like 2 or 3 weeks. I'm going to color correct that to be as close to what it actually looks like. My editing screens are factory calibrated; they are not calibrated for the individual ones. They are factory calibrated per unit, but they aren't wide gamut. I think you need like a wide gamut screen to actually or to accurately see these colors at all. Okay, that is already too tight. That's with the hopped section facing away from the motor. So the hopped gear on here is relatively dull, actually. It's nowhere near as sharp as the E2D hobgoblins, so that's not going to pick it up. Well, that might. This one to focus. There we go. Okay, so there's the hopped gear. Not quite as sharp as a hobgoblin, but it should do the job pretty well, and in fact it is doing its job pretty well, so we should be good there. Let's focus. Let's stop you from swinging. Don't tighten the pulley at the moment, we still have time for that. Yes, and we need to align this to the filament path anyways. And nice little detail here, the pre-cut Teflon tube from the Harden actually pokes through the exact right amount right there. I would have... yeah, I would have liked seeing like a tapered cut on this one, where it actually reaches around the hop bolt a bit more. But, well, I'm just going to have to see how well it deals with flexible filament. This should be okay, this should be decent at least. M3 times 20, that's these. Wait, well, what am I doing? M2 times 30, so that's the long ones right there. Mount the motor to the extruder body as shown, so with the this way and then this way. With the motor cable facing upwards. Okay, that makes sense. And these aren't the 30s. Aha. These are the 30s. I guess I could have used the packaging, but well. Yes, you will not be able to see these colors on any non-calibrated, non-white gamut screen. I mean, it gives you guys something to talk about. It's entertainment, right? I mean, I guess I could change the white balance on my cameras and stuff and try to get it right, but then everything else would look wrong. Okay, that's tightened up. Okay, so now we are going to line up the hopped bolt to the filament feed, so right there. Often, you know, what you can do is you can just poke something through here and use that as a visual guide. But typically, you are if you don't have the filament inserted yet, you can actually poke through a hex key like that, or in this case, it is actually loose enough to allow it to poke through. So this one looks pretty good right there. A bit, yeah, right there. So that should do it. Tighten this guy up, and we should be perfectly set right on that spot. Yeah, speaker reviews a bit hard. Android iOS discussions, yeah. Yeah, so people writing about Dell Ultra Sharps. Yes, I do have a Dell Ultra Sharp here. Again, on its side, can totally recommend these 1080p U2414H. Again, factory calibrated. 99% sRGB, whatnot. Awesome monitor and not too expensive. Plus the U2515, the 1414p version is also a very, very awesome screen. You know, just in case you want to get a new one. And if you do, please use the Amazon affiliate links as listed in the video description. I would greatly appreciate that. Shameless plug right there. Actually, let's check back on this one. Frog is doing well. Ah, so it's actually hollow on the inside. The material is Filamentum Rapunzel Gray or Rapunzel Silver. That does look fabulous. Oh shit. There. Okay. Right. Where was I? We were talking about color calibration. I was trying to assemble an extruder. Awesome. That's why these builds take so long. Because we get hung up on topics that have nothing to do with what we're trying to do. But that's the fun of it, right? Okay, 2 more drop-in nuts up here. So this is where the where the idler is going to sit in. Right there, we're tighten against. So right there. Next up, idler shaft with bearing. This looks like the part we're going to need for the idler shaft. That is the that is a 3D printed ABS part actually. Should be sort of in focus. And let's just see how well it fits in the bearing. So I guess this in here plus, okay, so there's a little ridge on the end. I'm going to put the washer on first. Oh, it goes on either way. And the bearing, and this actually fits surprisingly well on the bearing. Stock color from Dell, pretty darn good. All the screens I've seen so far, it's pretty darn good. And that just presses in here like that. Top camera out of focus. Maybe it's slightly zoomed. Whoops. Ah! So it's slightly zoomed in. Ah, there we go. That should be better. Okay. So yeah, typically you'd see like a ground down linear shaft and a 608 bearing, a skateboard bearing in here, but this does seem to work pretty well, unless the printed part cracks, which I don't think it will. Yeah, same idea. Got the bearing in the center plus the shaft sticking through it. Seems to work well. Okay, assembling the idler, place the shaft with the bearing into the idler. I did that. So we're going to need the M3x40 screw, a washer, the extruder spring, and another washer. Okay, and then repeat that twice. Length of the spring should be circa 13 millimeters when compressed. I feel like I'm missing something. I feel like I'm missing a screw through the extruder body. Did we already screw that in? Did I, what? Wait, what? So this one doesn't get these... What? Don't forget to have the idler in place. Okay, so this screw up here shouldn't be in here yet. I messed that up. Last Frog Eye Kids gave me a restraining order. Tough luck on you, man. This one should have gone down here. That's better. Now I'm wondering why we haven't inserted this screw yet. Well, we're gonna see. Square nuts are still in place. And let's repeat that for the other one. Thomas Sullivan, thank you for watching that advert. That helps out the channel a lot. Yes, it's 30 seconds of your life you'll never get back, but it's like 5 cents that YouTube will pay me for advertising fees. So thank you for not using AdBlock. 18, so that's a bit more than that. Okay, and that's that assembled. So we're screwing anything else to this hole up here because there is no screw in here yet. Ah, when you attach it to the printer. Okay, that makes sense. Alright, next up we are going to add the print fan. I kind of like how everything is Prusa research labeled. So this one is actually a Prusa research labeled print fan. Just like the stepper motors that are apparently laser engraved or custom made with the Prusa research label on there. And you know, these also don't feel like they're just stick-on things. I'm actually going to pull this one off because I'm interested if there's anything below this one, and there is actually not. I know there's the bearing stuff underneath here, but this is actually the original sticker that came on the fan. So awesome detail work there. So if you're saying, yeah, you don't want to watch ads, they do have YouTube Red in select parts of the world. YouTube Red basically giving you ad-free YouTube plus the ability to download YouTube files for offline viewing. Unfortunately, it is not completely available everywhere. For example, Germany, like, you know, not. So yeah, if you have the chance of using YouTube Red, that is definitely a good way of, you know, getting an ad-free experience, plus not taking money or not supporting your favorite content creators. 3 times 32 pieces, 15 print fan. Okay. So it's these. Screw the fan to the extruder using the spanner as shown below. So that is actually from this side. We're getting quite a few wires on here. And I don't want to bend this one out of shape, so I'm going to place it down here. Right there, and these screw through the fan, no washer, into the nuts we dropped in earlier. Hoping I didn't grab an M3 times 18 nut screw. Oh, look at that! I grabbed a 18mm one. So that's unfortunate, having the two sizes in just one bag. You do have to measure them out, but I guess it's like building Lego. You do have to take care which parts you're using and which are the correct and wrong length ones, even if they look similar or alike. No, the Prusa MK2 does not use a 32-bit system yet, but it uses a Rambo Mini with the good old Mega 2560 on there, with a modified version of Marlin, modified and optimized version of Marlin on the board. There we go. Yeah, obviously, I mean, that fan now has like an unknown origin, but I mean, for a part cooling fan, I would trust Joe to make the right decision on, you know, quality control and that sort of stuff. And even if it fails, I mean, it's not going to be a huge deal. Yeah, Joe. How are you doing, man? Still stressed out? I think this one is gonna work pretty well when we're done. If not, I'm just gonna swap this one with the assembled one and say I built that one. Nobody's gonna notice, right? Has an unlabeled fan? I don't think it does. Nope, it's got the exact same label because the label is actually not on this side you're seeing. The label is inside here, so there's the label we just tried to peel off. And this side over here is actually clean, so yep. Okay. Got the fan on there. So next up, the fan nozzle. That's a black part. I believe this is the orange part right here. Yeah. That's an interesting fit. Okay, so the manual shows this fan nozzle that basically guides the air towards the nozzle. Technically, as a black part, this is a fully fluorescent orange part, as it is on the ready built one. This is the one that says hot. Basically, that part right there. This does fit rather interestingly on over the radial blower right here because it has a there we go. It has a nose on the side that clips into this side over here, and then it has a screw hole that screws to this side over there. So let's just see how that fits in. Okay. Okay, so we should still give this one a bit of room to wiggle around. To not tighten fully at this moment. Yes. You see these important steps always have these red triangles next to them. It's like, you know, they're not part of the regular manual, so I keep reading over them. Which is, you know, den Wald vor lauter Bäume nicht gesehen is what we'd see. You didn't see the forest for the trees, because, you know, it's right there. They tried to make it extra big, but then it stands out and it doesn't look like part of the regular manual anymore. So there's that. I'm just going to measure that again. We should use a 20mm one, and that is a 20mm one. Right there, and on it goes. So this is the first M3 screw I'm tightening that does not have a dedicated nut to tighten into or to tighten against. This one is just screwing into the plastic part right over here. No insert, no thread in there, just the plain plastic part. So yeah, I guess for this part it doesn't really matter. It doesn't have any forces that it needs to transfer. So it should be good that way. Unless we're cracking the plastic down here, but it does not look like it. And it is really tough to screw in here. I should use the long side of the wrench, but that would take longer, so yeah. Okay, so this one should sit all the way flush against the nozzle shroud there. Okay. I was planning to have Bratwurst mit Sauerkraut und Semmel, but unfortunately the printer broke. Well, well. Okay. That's that, and that should be the extruder actually pretty much finished up. So one thing I kind of want to show you is this hexagonal hole over here. So you've actually got the hot end down here where the, I guess we still need to mount that. There's the hot end fan that's going to be sitting on here. And then up here you have this big hole that gives you like really good access to the hobbed bolt. So if you ever get stripped filament, you don't have to completely disassemble this lever and pull it off and clean it out that way, but you can just go in from the side and clean out any dust on that side. So that's a neat little solution. Plus, I mean, this area over here is not going to be used for anything else, so good use of the available space there. Gently tighten the screws holding the fan in place. Okay. Ooh, and also belt versus lead screw? Depends. What are you going to use it for? I mean, for an XY axis, lead screw is always going to have some sort of backlash which you need to compensate for, either with expensive anti-backlash nuts or with software, and either one is sort of like a clutch on top for, I mean, for a Z-axis, sure, go for it. But either one, I mean, the belt for Z-axis is rarely done, but should also work. Yeah. All right. So this sensor, Prusa 3D Pinda probe, Pinda probe. Someone who should go look what that stands for, the Pinda probe. But this one is definitely, this one is definitely not the same size as the traditional ones. Just for comparison, again, for all of you who weren't here like 8 hours ago, this is your regular 12mm inductive sensor, Chinese NPN, whatever, and that is the Prusa Pinda. So it is that M8? It might be M8. I think it's M8. It's not M6. It's M8. Okay, this is super tiny compared to the traditional standard industrial probes. So yeah, also lengthwise, just for comparison, it's about half the length. So that is really, interesting at least. Also, this is a straight up 5-volt probe. So this plugs directly. This plugs directly into the Rambo, so no level shifters or resistors or anything needed. Joe, can you answer that? If these are available from your shop on their own? Oh God, the jokes are real. Oops. The jokes are real. Yeah, I mean, if you can get it on your own, it would be nice, just to have it on any other print. I mean, having it on 5 volts already adds so much to the usability of this sort of probe, and having it smaller as well. It's evolution. It's where stuff should be going. Okay, so this one goes by removing one of the nuts. Not yet available. Too bad. But by saying not yet, I guess that means it will be available at some point, which is great. Mount in place, secure with nut. That's easy enough. So this tab up here should be roughly flush with the end of the clear plastic part on top. Ah, okay, so this nut actually drops in, so we do kind of have to wiggle this in. There you go. And that should be roughly at the right height. And now we can just lightly tighten it down so it doesn't fall out. That should be good. Now a wire loop. So this one loops in front of the outlet for the hot and cooler. Bigger detection distance. Well, if you do that, I would be interested in how these perform as far as reliability goes, or accuracy more precisely. If the larger sensing distance does actually reduce the repeatability of the probe, especially once you factor in thermals and environmental conditions, because that's kind of what I'm worrying about with the 8mm sensors, whether or not they are going to be less accurate than the 8mm ones. Yeah, so there you go. Prusa i3 Mark II, your ideal source for any sort of components. I mean, it even comes with M3 nuts if you want some, if you want to buy some of those. Come on. I guess I should be using a wrench, but who uses a wrench these days? Okay, so there's that loop completed as instructed. With the end of the hook right there. Okay. Next step, step 23. Shit. Yeah, that is looking perfectly. I gotta say, that is one of the best print qualities I've seen out of any printer right out of the box. Even with, you guys are saying 210 degrees is too much for this sort of filament, but that's good print quality if I ever did see some. So, yep. How to OBS Studio. Nope. Yes. And this one shouldn't be tightened yet, because, you know, some people say I don't read the manuals when I assemble these, but I actually do, and it actually does say do not tighten these yet. Right there. No need to adjust or fully tighten at this point. Yes, I did learn it as wrench, but then again, I am sort of US influenced when it comes to my English skills, so that might not be the best indicator of what the truly correct way to say it. Yes, there is no Z banding on the print. After all, why would there be? It's stepper what? It's stepper motors with the integrated lead screw, so there is no way, no physical way of any sort of Z banding being produced in the first place. Get cables from the mixer, we slot in the extruder body. Okay. Out the back, then put the fan. Okay, so this motor cable gets guided to the back like this, and there's actually a slot that gets covered up by the hot and cooling fan that will hold the motor cables in place, and once you mount the once you mount the fan like that, it gets locked in place. That is a nice design detail, gotta say. So 18mm screws, that's the only ones that are left. Again, no nuts or threaded inserts, so that looks different from what we've been seeing so far. And these actually look really long for what they are. Let me just remeasure them. And these are 18mm screws. Okay. Yeah, thin nut with a lot of play. That does work sometimes. It does work, well, quite often actually. But you do make a trade-off with that. You do often get more inconsistent Z layers because as the rod actually moves in the nut, the threads will shift the nut up and down as they press against them. So it's not that easy. You know, the easiest way is to just keep your Z spindles free of any sort of wobble or eccentricity right from the start. Okay, I am going to get a cordless drill with a bit, because that's going to be a lot of screwing. This stream is not sponsored by Bosch. I actually already talked about comparing this to the Festus i3. I don't know the exact timestamp, but you might be able to scroll back to it and see that entire discussion. Yeah. Oh yeah, colorblind. That is a good point. Maybe have the arrows patterned in different ways, or at least different thicknesses. That would be something, I guess, that would make it easier for colorblind folks to assemble this. Okay. Note the correct orientation of the fan. Yes, I did that. Follow manual. Use a hex spanner. Yeah. Technically, I mean this counts. This is a 2.5mm hex bit. Okay. Fan screws were gently tightened. So the 3 screws that are left, we're going to need for the next step the M3 times 40, M3 times 30, and the M3 times 18. Okay. So I need to grab the frame, and we're going to attach this to the X carriage that is already mounted on here. Now that I'm thinking about this, I mean, this is like a genuine, wrong side, this is like a genuine signed by Joe Prusa MK2 built by the built on the legendary 15-hour, hopefully not, live stream. Is this like a collector's item now? That would be quite interesting. Hey, Nightbot is at it again. So again, just to reiterate that Nightbot is my little helper bot that I set up. Anyone can use it on Twitch or YouTube streams, and it just helps you keep your chat clean and, you know, send out messages like those. Want to help me pay for electricity and get your cool sponsor badge shown on screen messages out. Yeah, that's it. All right, mount this here. So the one thing I'm noticing is that there's like no pins or anything that hold these two together in place. There's, you know, two smooth surfaces that just mate with each other. So I guess we're just gonna have to find out where each of these wires belongs, more or less. Yep. So longest one up there, then these. Okay, so the long M3 times 40 screw actually goes down all the way through this slot. Nope, that's not it either. Let me just go check where this sits exactly on the assembled one. Okay. This actually just sits straight up flush with the top edge like that. So the wires right here go between the... What? Ah, okay, so they go out. That is interesting. So this wire guide actually has that function. So whoop, I'm pulling on stuff that I don't want to pull on. Come on. Ah, there we go. So this wire slot right here actually takes the wires that come from this position over here from behind the fan. These two wires right there. Takes them, guides them downwards and then towards the back. So because the belt is going through here like that, it actually guides it, you know, away from the belt and, you know, in a safe spot over here. So that does look pretty nice. Okay, so yeah. Okay, so I guess I do need to just push this one in and then push it up like that. Oh yeah, that feels good. And then this one over here. We'll go through the slot over here. Okay, I'll show you how all this fits together in a second. There's just a lot of wires needing to be managed in the exact right places at this very moment, so... There we go. Okay. This one does seem to go in. Yes, the parts are 3D printed. No, they are not 100% infill. And if you get unlucky during shipping and get the exact revision that I'm getting, you might end up with a broken part. That's why this stream is already going on so long. Well, part of it, I guess. Also, I'm interacting with chat more than I'm building the printer. So this is one of the parts that came broken on the assembled one. I grabbed the replacement part from the kit version, and now the kit version has a printed replacement part that was the first print on the assembled machine. So we all good. But yes, I guess that's just one of the risks of 3D printed parts. They're not quite as strong when it comes to abuse, but you know, under normal use, a 3D printed part will hold up just as well as, you know, an injection molded or CNC milled part. But when it comes to like abusing them and, you know, putting forces on them that they were not designed for, then yeah, the 3D printed part might fail earlier than the injection molded one. XY skew compensation. Haven't used it yet. The only compensations I did on the assembled one was the auto bed mesh leveling, and then started printing. But from what I've read on the topic, the skew compensation actually works by works to align the works to align the X and Y axes by probing a few special points. I believe it's this, and somewhere over here. It might just be this point over here, I do not know. But it senses those 3 points with the inductive bed sensor, and then yeah, basically calibrates how far your X and Y axes are skewed relative to each other. So in general, a pretty good system. PCBs are manufactured really accurately, so yeah, awesome system. And it literally doesn't have any downsides. While on the Z-axis compensation, people might tell you, oh yeah, you're getting like resolution artifacts and stuff. This kind of compensation does not have any downsides at all. And yes, I mean technically yes, it does have a few, but those are so minimal that they don't really matter. Just to be. What? So apparently the fan cable from this guy right here, from the part cooling fan, also needs to be routed alongside the Pinda probe wire right there, which I don't think has enough space for the second wire. So I guess I'm gonna check how it's done on the ready built one. It actually does go through that space, so so the manual actually tells you to mount this thing first and then route the cables, which does not work, so I guess I do have to undo this one again and route the cables properly this time. Okay. Yeah, as always, wiring a 3D printer is not what I enjoy about the process at all. It's like, you know, if you could get these with like 3D printed properly, 3D printed inductive parts in, or inductive conductive parts in here that just, you know, snap together as you assemble it, that would be awesome, but I think we're still a bit too far out for that to happen. Okay, it did fit. There we go. You see that on the webcam. Webcam is blurry. Perfect. It did fit. Fit in there. Now both cables are pretty tightly in there. But I mean the routing on the back. Turn this thing around for you guys. The routing on the back does look pretty clean. Well, there. Does look pretty clean. So there's this one bunch of wires coming out this side over here. That's the motor and hot end cooling fan. Just routed out here. Then the Pinda probe and the part cooling fan over here, and then the bunch of wires for the hot end. I guess these go. Yes. These do go in this slot down here, which is, I guess, the next part we're going to be assembling. Okay. Arrange the cables from the extruder upper part and from extruder upper part neatly in extruder cable holders. Okay. I guess that's what you want me to do, like that. Tighten the extruder in place. Oh, now I get to tighten it. Wow. Okay. Take one piece of filament that came with a part. Nylon 3mm, about 50 centimeters long. Okay, so that is exactly what I expected this stuff to be. So there were these two parts of what looks like filament and what is actually filament included. That face in the XKH, oh, that looks creepy. That does look creepy. Wow. So there's some filament included, and it's actually what I recommend doing if you wire up your printer yourself, to grab some sort of flexible filament like this nylon, like this 2mm nylon, to stiffen up the cables and to basically enforce your and minimum bending radius. So this one will get tied to the cable hose, cable, whatever. The cabling thing that comes off the back here, and all these wires will get tied to it, so you're not going to have any sort of sharp bending corners on your cable thingy. What is my favorite printer? So I guess that question goes towards what is my personal favorite printer, and it doesn't really, go towards. Do I get to cut this open? I don't know. It doesn't really go towards what is the best printer, because that's always like a different story. Best and favorite, not necessarily the same thing. So for me, my favorite printer, I believe, is still the printer bot plate, because it's small, because it always works. It's cheap-ish, and it's just a good design overall. So wrong hole, yeah. It's just a good design overall, and I feel like it's a really nice machine. It's by far not my best 3D printer, but it's what I feel is like my favorite one. Unless, of course, I end up reviewing this thing so positively that it completely blows my mind, which might happen, which is a complete possibility. So for that part, the i3 would actually take that crown away from the printable plate, but we'll see. This is not supposed to review. This stream is not supposed to be a review. This stream cannot be a review. because it takes time and actual work to form a real opinion on any product that is as complex as a 3D printer. I can hear the printer behind me squeaking. Oh yeah. Now if you put it in the right hole, it actually fits much better. But it's still kind of tight. There's that. I shoved that right up its nose. Perfect. So I believe that should be as far in as it goes. Yep, don't want to bend it, so that's good. Frog is coming out well. Push it all the way down. I managed to get the right one. Alright, so let's mess up this guy a bit more. So fan and motor, we're gonna shove that thing right through here. Like so. All the way down. All the way down right there. That is step number 1. That looks painful. Double check the orientation of the zip tie. We got that wrong. We got the zippy part to the oriented towards the outside. Okay, so this right here, it's giving us 2 options. So let's just see if we can get that exposed somewhat properly and focus on properly. 0.5. There we go. Okay, so cable management option 1 and cable management option 2. So without you guys actually knowing the exact options, I'm gonna put it up for a vote because I can do that. Haha. So poll new management. Kill management hive. So yeah, that should be something you guys can decide. I have no idea what option 1 or 2 is. You guys probably have no idea what option 1 or 2 is. So that should be an awesome poll, right? Oh shit. So I need to look. Do I need to read the manual? Are you telling me I need to read the manual? Come on. I thought we could have you guys participate. So if I would actually read this stuff. So if you have a connector on the thermistor cable, this option is for you. If you don't, go for option 2. So there is a connector right. Why you know where to? So as you can tell, there is a connector right in here, which is the thermistor connector. So we need the option 1. Let's see how many of you guys were right or wrong. Huh? 17 to 10, so kind of close, This is a full E3D V6. It's not a light 6, it's the full-on V6 all-metal option. So no messing around with like PTFE tubes going bad or anything. That better? While handling the thermostat with the connector, make sure it's still connected. Okay. Okay, this is sort of interesting. I guess we're gonna... So you've got this zip tie going all the way through, so that means we slide in the connector like that, sort of like that, right? And then pop the heater cable on top. And actually get this zip tie back up again. So, okay, so that's one zip tie for the entire wire management. That is interesting. Okay, so that should be good. Now the only thing left to do is actually routing this one over here. Good. Put them through here. So now we've got all the wires bundled into the center right here. You know, this creepy face is really it is really getting on my nerves. I do have a feeling that was integrated like that on purpose. Maybe. Alright, so that's tight in there. The hot end also looks good down there, even though this one isn't like all in the slot, but it can't be all in the slot like that, so. Ah, right. This one tight. These are all coming out of the center right there. These are all coming out of the bottom right there, so we should be good right there actually. Printer I would definitely tell people to stay away from. That wouldn't be a single printer, that would basically be just all the Chinese i3 printers. Not because they are all bad. There are definitely some in there that are actually good value and print great and work awesomely. The only problem is, you know, especially the ones on AliExpress that you get like as an i4 or Prusa i3 improved version or something like that. You never know what you're gonna get. If you look at my review of the Malian M150, which is definitely like one of the which is, you know, definitely one of those more or less Chinese knockoff printer things. You see a few of the things that can go wrong, and with something from AliExpress, you've got changing manufacturers, you've got changing design philosophies, you've got changing engineers, and each and every one of them are going to make their own mistakes, and they're going to add up, and eventually you're going to get a printer that burns your house down. It's not like that hasn't happened before. So when you buy a 3D printer, buy something that has a brand name attached to it, preferably, you know, a brand name that has been around for a while. That would be my only recommendation. Don't buy like no name, super low budget stuff that seems like it's a good deal. So this is gonna get a zip tie. So the extruder, or the hot end wires down there, get their own little wiring nook. Pin the protector assembly. Well, we can always print that if we need to. Wrap the spiral wrap. Okay, so what we're gonna do is we're going to wrap this around, and then I guess I'm gonna put a zip tie right around this position right here. So these two are still offset quite a bit. So we should start with the spiral wrap up here, and then add these one on like that later on. So that is the largest and longest spiral wrap. We've got two of these, and we're gonna grab the longer one of them. Maybe right there would be a good place to tie these two together. Spiral wrap versus braided sleeving. They both work, obviously. Spiral wrap is easier to use. It's not as nice as braided sleeving. But you mean the fact that you can just apply it afterwards does kind of make up for that. Yep, it's 3mm nylon. It's actually 3mm nylon filament. Awesome to see that. Like I said, that is what I recommend in my wiring video as well. Just to put some sort of filament in with your wires to keep them from kinking, to keep them sort of straight, and to give them the strain relief at the end here. You see how that stays mostly perpendicular to the point where it's mounted. That is because there's that nylon filament bundled in, so it keeps the wires from kinking and failing at those stress points. Yep, good point from Joe. Braided sleeving does require a lot of work if you ever want to change something, because you can never, you can't. So pulling wires through it is kind of tough. Pulling wires through it when there are already wires in there is basically impossible. So when you want to change a wiring, if you want to swap anything out or modify anything, you always have to like pull everything out, redo the heat shrinks on each end, and then You know, it's a mess. Alright, that is a nice black snake that's going down here. That looks solid. Okay. And tighten the wrap cables and the spiral wrap. So I guess I'm going to add one more zip tie down here, just to keep the spiral wrap in place. Okay, perfect. So that is a bit tough on the end stop over here. I'm just gonna snip off a tiny bit right over there so it doesn't bump against the spiral wrap. Yeah. There we go. And now that clicks in just about perfectly. It's right over there, there's the end stop. That works well, and on the other side as well. I don't think it's ever gonna go all that way over here, so yep. Perfect. Triple check the X-axis end stop. Yes, I just checked that it clicks, it works. Next up, assembling the LCD. So the LCD is an add-on unit. The LCD is an add-on unit that sits in the front of the printer, right there. So I guess we can assemble that separately and then add it to the printer later on. I don't know how you ended up here watching this sort of video. I don't know how any of you ended up here. Alright, LCD assembly. We still have a heated bed actually, that we are going to install eventually. So there's the LCD baggie and the LCD frame. Right there. Good. Look away for a second and stuff tries to escape on you. There's the LCD. There's the button assembly, or the assembly, haha. There's the push button right there, so it goes down to a clicky button on the PCB, but it's just a cutout part, or a non-connected part on the frame right there. Perfect. And the two clips, then some wire clips to hold the flat band cable to the frame, and that's it. And of course the LCD knob. Yeah. Oh, there were screws in here. So long zip ties, 4 of them, 5 of them. There's one screw and the other one is somewhere down here. somewhere. There it is. Yeah. There were only supposed to be 2 screws in here. Near fire, are you guys talking about bratwurst? There's 1, 2, and there's also 1, 2 labeled on the other side right there. And these just plug into the Brembo board. And actually I'm going to take off this protective film right there. Wow. Because it does get stuck in the underneath the, let's call it the shroud right there. Okay. Preparing the LCD support for assembly. So, yeah, this is a relatively unspectacular text-based display. So it's not one of the fancy graphical or even a color display. It's just a good old, what it is called, 60 something, 2004. So 2004, 2004 displays. 20 characters across 4 lines down, I believe. I would have liked seeing at least the graphical one. Joe, do you know why this one is just coming with the regular text-based one and not the graphical one? I don't think they're that much more expensive, if at all. Yeah, these are the buzzer. Actually, it might actually be turned off on this one, because I did not hear it buzzing so far. Much more power, as in processing power, I guess. That does make sense. Okay, the exact system there. Directly into the cutouts of the LCD covers. So press the LCD's control with the LCD support into the LCD cover as shown in the picture. That's this nose over here. So there is a tiny nose that clips into everything. Press it as deep as possible. The LCD controller must click on the support in the center of the I guess just like that. This will match over here, this will match here. There you go, there's one, and then this thing just snaps together. So that's pretty easy. It's a pretty painless way of mounting it. And that does feel good. So just 2 more screws to set everything in place, and those just go into the holes on the edges of the PCB right there. There's one. And there's 2. All right. So that's in there really solidly. Plus no forces on the LCD like we saw on the Adam live stream last weekend. Okay. Perfect. Plug in the cables, so these already came pre-connected. So next up, securing this to the printer itself, and I'm actually going to slide the zip ties in here before we attach it to the printer. Frog is starting to have wings. Oh yeah, there's like little stems of the wings. Why did my screen go black again? This is so creepy. So there has been some discussion under one of my YouTube videos about why we aren't pre-processing Delta G code on a computer and then sending those pre-processed motor coordinates basically to the 3D printer, or storing them on an SD card and then having the printer read those off. So I guess you guys are going to have an opinion on that, on why that would or wouldn't work. And I do have a theory why we're not doing it, but I want to hear what you guys are saying first before I, get you all mangled up in that. So why are we still running the actual Delta processing on those poor little 8-bit CPUs? It's not a trivia question. This is a, maybe you guys know more than I do. And apparently, I don't know how to assemble this thing. Every printer already needs its own G code. So that's kind of a moot point. Why is that one so tight? Octoprint does mount the printer's SD card, it's just not. Wow, that is tight! But it's still accessing it through the Arduino and its SPI SD interface and such. Okay, so the dimensions seem to be slightly off for this one. Switch you guys back. So these clip onto the 2 and 8 rails down here, these clips for the LCD unit, and the distance on the 8mm rails actually seems to be less than what the holes are cut out for on these down here. Yeah. Okay, just quick intermission. But I guess I should be able to just zip tie it on. Yeah, so my point, I did some quick math, I believe it was yesterday or the day before yesterday, about how much bandwidth we would need to actually stream pre-processed motor coordinates for a delta at any sort of decent speeds, and it came out if we were actually going to stream every single motor step and send the full coordinates for the 3 motors for each motor step, or the 4 motors actually. It will come out to something like 650 kilobytes a second, and a typical Arduino can only read about 250 kilobytes per second. You know, if you have anything else running on the processor, that's and if you have a file system on your SD card, which is probably what you want to do. So 250 kilobytes versus 650. I'm sure you could get around that with some very hardcore optimizations to either read more or to reduce the bandwidth required for that. You know, just do interpolation between every 4 steps or so. But still, that would create enormously large files. Still, even if you said like you only have 100 kilobytes per second, that would be 6 megabytes of G code per minute you print. So I guess you would be running out of SD space pretty quickly with that, if you manage to read that quickly or optimize it as much as you need to. Okay. Mr. Not Sure, thank you for your compliments. I do respect my fellow YouTubers. Barnacles was probably there first. I don't know. But thanks, man. On the question of subscribers, have you subscribed to my channel already? Nightbot will be happy to remind you about that every now and then. If you're a random YouTube watcher wandering from the vast spaces of the internet, please do consider checking out my regular YouTube channel with some, you know, higher quality and faster paced content than I can create in the live stream. But yeah, if you aren't, get subscribed. So itsy bitsy wire clipsy right there. So these little how to camera, these little plastic clips, they grab the flat band cable on this side and then clip around the 8mm rods on the other. And then these go all the way to back here. Will I test a tungsten premium nozzle in the future? I have not heard about tungsten premium nozzles yet. I do have a coated nozzle, I believe, nickel alloy plated or something like that. So those are something I'm definitely going to be looking into. I have nickel plated hot ends and heat breaks, so those should be quite an experience. Supposedly they print easier, that they require less force to push everything through, and they also last longer. And oh, there's the subscribe hint from Nightbot. So click the link, get subscribed. Thank you. Yeah, I do have some nickel plated nozzles and heat breaks. Supposedly they are good for carbon fiber as well. So that's something I will be trying out. Okay, what? Power supply and heat bed assembly. Spool holders? Okay. I guess we're gonna assemble the spool holders. And the rest of the parts are actually just spares. So we've got all the part bags done, which is awesome. But that also means we are going to assemble the electronics pretty soon. And the heated bed. Let's see how well the heated bed works out. Alright. Spool holders we're going to put on very last thing we do. So we've got the heated bed wire cover, which is exactly what you can see right there blinking to the left side. That is what goes over the heated bed or over the heated bed's connectors. And 4 times 10. Okay. And unfortunately I will need to take the webcam away from this position right there, because now we need the power supply. It was sitting on the power supply most of the time. Right. There. Hard nozzle for a wood fill. I think that was already answered a second ago. No, you do not need a special nozzle for wood fill because it is non-abrasive. Wood is not a very aggressive dust, because that is what it is. You know, wood fill is basically PLA with wood dust. So, yeah, again, you do not need a hard nozzle for that. So the power supply, that's interesting. We need 2 M4 screws. I wonder where those went. They are probably hiding inside the power supply and the heated bed bag. Yeah, metal fill might actually be good with regular nozzles as well. It kind of course, depends on the exact filament you use, but I'd actually be comfortable printing metal fill with a regular brass nozzle. Of course, as always, that is not legally binding. If you ruin your brass nozzle after printing a metal fill, that is all on you. I take no responsibility for that. The Haribo Goldbeeren as well as the Haribo Softbeeren, those actually came with the printer. So one came with the assembled one, the other one came with the kit. Yeah, I guess that's not really the best replacement for actual food for me, but what can I do? I've got them here. I can chew on them. What am I even doing here? Guys, nobody's telling me. I'm doing this all wrong. Again. It's time for this build to get finished. Because this one actually gets screwed to the frame like that. Okay, that makes much more sense. Okay, now let's get the... Let's get the Z-axis out of the way. There we go. That is awesome with those high-pitched lead screws. You can just push them around by hand. Plus, they move really fast if you use them regularly, or in a regular way. Controlling it through the software, your Z-axis can just go super fast compared to like 8mm threaded rod, which is something people use and I've used, but it's not really like a good linear drive in the first place. Yeah, you know, E3D does ship Haribo Goldbeeren in their hard-end kits, but you know, this is like 5 times as much as you get from E3D. So props to Prusa there, keeping you sugared up. So M3 times 18. And this is actually the... Yep. There we go. So there's the front of the printer, and we're connecting this part over here on the power supply Y connector, basically. Screws, washers, nuts. Now I know what that squeaky noise is. It's not the printer itself. It's just the filament holder up here. No camera shows that. Yeah. Yeah. Unfortunately, no pizza for me. Living in the middle of nowhere. Can try, but you will fail. I can tell you that much. It's not like I haven't tried, but pizza just does not. My webcam. Pizza does not arrive at this house. It just disappears. It doesn't arrive. That's a frog, guys. Seriously, don't you see that is a frog? That's like the froggiest frog I've seen all day. It's also the first frog I've seen all day, but it's a frog. All right, stop calling it a dragon. That makes it uncomfortable. Let it choose its species and family itself. All right. After all, you know, it might identify as an attack helicopter. Okay, so let it choose what it wants to be. So the fan is working at 100%. Yes, I can pull you guys back and give you a view of the LCD real quick. So I believe this is the fan setting, the part cooling fan setting right there, 100%. We are on 4 hours 21. We are 59.35 millimeters tall. Heated bed at 55, hot in at 210, and 51% of the print. Of the file at least, and supposedly it's a 6-hour total print, which I'm actually not so sure about. Oh, that's print speed. Okay. I mean, you can see how often I use these simple LCD screens these days. So mostly it's more complex stuff. So it's either well, actually most of the time I do use something like Octoprint or just like quick SD card prints, because I really don't watch my prints that much. The first few layers, usually, yeah, I'll have a look at them, but then afterwards I'll just keep it going and see what the print looks like afterwards when it's done, because that's most of the time, if you kind of know what to look for, you can tell which settings to change just by looking at the final. God damn it. just by looking at the final print. Yes, so because silent mode was brought up just now. Squeaky, squeaky. Silent mode was just brought up now. Let me just give you a quick comparison again, because this printer has a regular and a silent mode, which I believe reduces the stepper current and accelerations and stuff. Let's change back to regular. High power. I think that is a very audible difference. Especially once the shelf here starts resonating. This is like a 20mm thick MDF. Oh yeah. Let's switch it back to silent. I think, you know, the silent mode is the way the printer kind of wants to be used. I'm gonna have to look into what the actual print quality looks like with the silent and the regular mode. But I mean, so far, at least on the silent mode, I guess the quality does look pretty amazing, right? Orange printed parts are ABS, or at least some ABS-like filament or material. Okay, so we've got the there's my webcam. We've got the power supply. Let's back up a bit. We've got the power supply connected to the Y-axis bar, which in turn is connected to the 10mm threaded rod subframe. That's just one connector right there to keep it from wobbling around. Alright, so that is connected. Guide the low voltage cables from the PSU holders under the threaded rods to the other side of the frame as shown in the pictures. So that one goes down here. So by the way, this right here, because it was asked quite a few times already, let's just bring it up again. This part right here, this is the power supply that comes on the genuine Prusa i3 Mark II. Regular, you know, no name brick power supply right there, and then on the bottom here it's got this 3D printed shroud, so it covers up all the high and low voltage connectors of this power supply, provides a 3-pin IEC socket. I guess whatever you're seeing on the overhead camera is the same thing, I'm sure, on the webcam, but anyways, providing the socket, providing a fuse, providing a nice decorative triangular element right there, and an on-off switch. So while building this printer, you will never be at the risk of you know, touching 230 volts, miswiring anything that is high voltage, mains voltage. So that is, I think that is pretty neat. So it feels like we are sitting on some wires somewhere. Just get this all out of the way. Here, there. Okay, so this printer is definitely rocking back and forth now a tiny bit. I believe that is because the connector down here actually ended up pulling this corner up, which I hope it didn't. So. I don't know, it does feel slightly loose this way and slightly, it's also slightly loose that way, so I guess that's just the felt pads. I'm hoping this thing down here didn't screw with this alignment too much. Well, we're gonna see. I mean, it's got a whole bunch of auto alignment features anyway, so will it matter? Probably not. Okay. Tie the low voltage cables to the threaded rod. Okay. So So I guess that is the last thing we need to do. That's sitting on the LCD, which I'm not comfortable with. But basically just tie these to these two large threaded rods, keeping them out of the belt, hopefully. So Jerry just said, do not praise it for its print quality because it will bring shift delay. So are you actually referring to the silent mode, or is it like a knock on wood thing? Oh, these came out. Okay. So far, I think it is holding up pretty well. Yeah, the whoops, how to use a zip tie. Shit. So on the discussion on genuine Prusa i3 and i3 and whatever you want to call it, I guess it's less of a don't size it, the LCD cables. Okay, I guess it's less of a don't steal my design, but more of a don't use my name for this. Because after all, the Prusa i3 is a brand name. It's something that people associate with something, and I think Joe Prusa and his team have worked pretty hard on establishing the i3 as, you know, something, as a brand name, what it is right now. So the problem I'd see with that is not that people clone the machine and sell it as their own. The problem I see is that people basically freeboot on the name and the recognition and the brand that Prusa and his team have built up with their printer for their you know, printer type, and other companies just basically take that name, take a similar printer, and call it you know, call it the same, and basically transfer that image to their own printer. So that's the bigger problem I'm seeing there. Yeah, so I guess that is why every component has the Prusa Research name on there, whether it's the motors, the fans, well, the frame. Well, the frame just says Prusa, but that's what I think is the bigger issue right there. Okay, check the power switch. 220, we're good there. This is very important. Okay, prepare the heat bed. So we are going to attach the heat bed to the carriage, and that should be really simple because we don't need to do any sort of adjustment. Okay, so that's sitting on the... I see. That is sitting on the screws that are poking through from the belt tensioner. Okay, so all these screws go in the corners and on this one extra point. Nope, just in the corners and then the center one separately. Will this print chocolate? Not out of the box, but you could put a chocolate extruder on it if you wanted to. You could definitely do that. After all, it is an open platform and you can remove the extruder and harden and put any other components on it that you want. Just double checking I'm orienting this properly. So because this printer has so many auto calibration adjustment mechanisms, this bed does not have any adjustment points on its own, so it's just being screwed to the aluminum undercarriage with stiff bolts, which is actually the way I prefer my beds tightened, and my nuts being held in place. Just completely stiff, no springiness, no flex in there, because this assembly is going to be close enough to, to level basically. So that's interesting. So yeah, I don't see any reason why you'd want to add springiness to your heated bed, especially when it's a moving bed like this one. When you can do that little tiny amount of offsetting you need, when you can do that all in software. So this does make for a better quality print in the end. This is the wrong hex key. Check on the frog. So I guess this is where all the little tiny moves come in. The LCD just said 51% a minute ago. Now it's saying 55. So I guess the neck does have a lot more of the perimeter structures, which are high detail, high polygon, or basically many tiny moves. So that is going to be a lot more of the file, a lot more of the moves percentually, just judging the number of moves compared to infill moves, which are just long straight moves. Take one line or two lines of G code and then a very long time to execute. So I guess at this point the progress on the LCD should go a lot faster than it did in the beginning of the print. Yeah, it is not proportional to the to the layer height, because the firmware does typically not know how tall the print is going to end up. So it is usually just a percentage of the file size. So we're at 56% right now. Right there, 56, 4 hours 38 into the print. It is estimated at 6 hours, so I guess that is somewhat realistic, even. Just look at that. 2 more screws to tighten up, and then it's on to the electronics basically. So these 2 screws that go through the newly printed Y-axis belt holder actually reach all the way into the hot end, into the heated bed. There we go. So that should be that part tightened up. Hot end temp is usually not due to the part cooling fan. That one should be mostly consistent. Then again, it's only oscillating like between 208 and 211 degrees, so it's not too bad, but it could use its PID loop. Slightly retuned, definitely. Okay. So here comes that heated bed cover. Now this one also has that little hole for the. This one also has that little hole for the. Let's put it this way. For a nylon tube for the nylon filament to fit in. So this one actually captures the wires up there, keeps the solder points from being exposed, and provides a wire strain relief. Nice all-in-one part right there. So that's what the second nylon part does. Come in. This one fits a lot less tightly than the one on the extruder. As that, there is a zip tie divot in here where you can just zip tie around, so keep that from coming off, and the screws on like this. Inserted. Let's get this one in here. So this last screw actually just screws straight through the heated bed into the heated bed cover. Just have to slightly lift it up. I'm lifting it by the heated bed. Yes, I know. But again, this is 3mm F404. This is probably one of the strongest parts on this entire printer. FF4 is actually, structurally speaking, an insanely strong material, so no worries. How do I feel? We're already at 10 hours. Well, we're almost done. So, but also that is what I said on the Atom 3D stream as well. And that one was 15 hours in the end. But I feel like we are getting really close here. We've got most of the parts assembled right here. We've got the heated bed in. It does look like a 3D printer. The only thing left to do is guide this wire down to the electronics bay and install the what's called mainboard, which means we're almost there. We're almost there. So next up, the spiral wrap. The spiral wrap, this last little part here actually goes into the strain relief part on the heated bed. connector. So there's the nylon tucked in, there's the power wires coming out, and there's the thermistor. So these go together like that, and then the spiral wrap goes around all of these. Okay, so that slides in like that. And now that that's in place and really nicely strain relieved, we can put a zip tie around it and fix it on place. Just to make sure the thermistor wire is not under any real stress. No, that's looking good, and it's also not dangling down. Right. There you go, that gets wrapped and we should be good. Okay. There you go. So the filament part right there is actually a bit longer than it needs to be. It sticks out quite a bit, and it actually says do not cut it, you need the full length, which makes sense. So that is secured in place. Perfect. Check everything is correct. Here comes the tedious checking part. Take a look from the printer from the top side and make sure that the lines on the heat bed are perfectly parallel with the x-axis rods as shown in the picture. So, let's do that together. Because I have a near perfect overhead camera, we can check that when we push this thing down, Yep. What just fell out of that machine? That looks like an LM8U ball. I have no idea where that came from. Well, I know where it came from. It came from an LM8U, but I have no idea which one. Scary. Okay, so that's not crashing into anything. So supposedly that line right there. So this line right here should line up with the x-axis rods, and it seems like it does. As far as I can tell, it lines up well enough. I mean, it's like 0.5 millimeter off on this side over here. If they are not in parallel position, use the 17mm wrench to adjust the M10 nuts to get it correct. You will have huge troubles correcting or calibrating later on. So the question is, does this actually get corrected by itself, you know? Because that is one of the exact, one of the precise features that this Prusa should have in there. Yeah, calibration XYZ will tell you if it's too much. So I guess, you know, I know it's slightly off. I know this side over here, this side of the heated bed is slightly skewed towards this direction over here. So I'm just gonna leave it like that and see what the calibration says, because that I'm guessing it will report how much it is actually off. Okay, this is extremely important. Apparently it is not. Last finishing touches and done. Assemble the spool, hold it to the top frame, almost there. You're one step before you're finished. We've got no electronics in here. How are we almost done? Well, I do need these to be adjusted to the exact spool I'm going to be using, so I'm just going to put them somewhere for now. Electronics assembly. Something smells like cinnamon buns. I'm getting hungry. It might be that printer. I'm hoping it's not. Okay, getting the necessary tools. We still need the wrench. We still need this wrench. We needed that for each step so far. And the 2.5mm hex spanner key thing. And a few more printed parts. And this is now, for real, this is the last bag of printed parts that we need, so. There we go. Plastic right there. So, little hinge parts like there, and then a cover that fits together somehow like that. Okay. This seems a bit too dark for me. Let's make this a bit brighter. There's that cover. Okay. Let's see what we have to do. M3 nuts, 5 pieces in the nut traps. There's the spares bag. Am I missing some parts? Did I lose some M3 nuts? Ah, there they are. Okay, so there's another bag of fasteners in with the actual electronics itself. Okay, preparing case, insert 5 nuts in the... I'm getting food delivered. Yeah. There we go. Don't mind these, you know. Just some casual food. Okay, insert some nuts. You know what? I'm gonna try to do some chewing and screwing again, as I did last time, which worked pretty well. So I'm gonna shut up and screw these together while I'm chewing at these tasty-looking cheeseburgers. What's that? So these nuts are pretty tight, and again that that tip with having an Is that actually a nut cover? Doesn't look like it. Having the tip with using a long M3 screw to insert them does seem to work out pretty well. Well, unless for this one. There's the ale. Leitungswasser. Yes, just regular tap water as always. This last one seems to be a bit loose overall. Alright. So, nuts are inserted. I might have dripped a bit on the manual there. Let's keep that clean. 5 pieces. So this one is also... No. The last nut trap is over here. So that is a... That's also a hex nut trap? It appears so. That nut is in. What? Oh, so, okay. So I guess, I mean, the good thing is I can always check out what it's supposed to look on the finished machine. So basically there are 2 screw holes right there. Here. Just 2 screw holes over here that the electronics case will screw directly into. So just like, excuse me, just like that. We still don't have any sort of electronics installed in here. So I guess that should be one of the very next steps. That's a long-necked frog. Oh, we also got the webcam going? Yeah. Yeah, the nuts seem to be holding it pretty well. So I don't think I'm gonna need electrical tape unless they start falling out in a second. That webcam's auto exposure is completely screwed up. Yep. Nightbot is like an auto moderation bot. If you do watch Twitch streamers a bit, you will have seen him definitely. He's like, you know, one of the most standard, one of the most widely used moderation features on Twitch particularly, and is you know, just now coming over to YouTube. This one is on here pretty solidly. Okay, now, to be honest, these pictures right there, these ones, same issue as with my webcam right now. You're basically seeing all black. And the same on the ones on the next page. They're pretty much all black where the important stuff happens. So, as it turns out, I should have been feeding these wires through because it has because it has. So the manual again is multi-step in this point. So it says attach this frame right here. But then on the next page it says, okay, attach the frame to these screws. And then it says, okay, while attaching the frame to these screws, actually feed through the wire right here. So maybe, you know, be a bit clear about at which point you actually, you know, get to screw everything down. You know, when the manual says, okay, you should now attach this, I should be okay to go ahead and finally attach it to the actual screws that he pointed out 3 steps earlier. Just a little, maybe that would improve things a bit. Note. Yeah, Moore's greetings to Stare. I know, greet the kangaroos for me. I'm surprised you're still up. Isn't it like 7 a.m. or something over there? Okay, so we got the X motor and end stops wires tucked in there. And now we can tighten it down. In the next step, use the highlighted hole. Okay. And that is some black part that gets mounted to some hole right there. So I'm assuming it's the longer part right there. And it gets screwed on with the tab facing towards the bottom, but I can't really tell. So use this screw. It appears to be the lower one. So I'm just going to try the screw down here and see how well it works for me. Yeah, so at this time of day, usually, you know, you get all the time zones together. Australia is getting up, Europe is like on the couch at night, US is like in the middle of the day. Yeah, so I do welcome viewers from all over the world. And that does not seem like it's fitting. Perfect. Apparently this had the pancake bot. Yes, I would approve of that. Oh, so it is the smaller piece. Okay, so that is a definite problem with the manual. The images aren't that great. They are pretty dark at times, and for example in this case I couldn't really tell if I was supposed to use this part or this part because it was all black in the manual's pictures, and as it turns out the smaller one was the one I was supposed to be using. Okay, that looks better. That really looks better. You guys keep asking about cetal glass. I don't know what cetal glass is or what that refers to. Okay, so that works, and we can install the top one when the time comes. Nightbot is a bot. It's my bot. I set him up. He works for me. He transfers my messages to you guys, so I don't have to do them. He also mods a bit for me. He all does it for free. He's kind of a great guy, you know? Do what he says, please. Yeah, so before I get into this last juicy burger, this heated bed is only FR4, so it is only resin plus glass fiber, so there is no aluminum in there. There is no glass in there, well, except for the glass fiber, okay? But it is all FR4, it is all glass fiber composite, so yeah, I guess that is a good thing. It's all one material, so it's not going to warp, hopefully, as much as you'd have on a glass FR4 aluminum composite thing. But it's all one material. It's 3mm thick, so it is, yeah, it should be massive enough. And as you can tell on that guy, it is definitely holding up very well and keeping the layers very consistent. Okay, so the instructions are actually telling me to rotate the printer like that. So you're now all rotated up. I think the webcam is gonna, have some sort of a, whoa, stay here. The webcam is going to have some sort of decent view on this. And the orientation should be correct, like that. Yes, so we can get at the reset button right there, which you can just barely not see. There we can get at the reset button right there. Got the USB up there, and then, you know, wires out here and up the bottom where necessary. Well, that didn't work out so well for the nut. Yep, the FR4 bed does have a PEI layer on top, which gets everything to stick to it really, really well. So apparently PET actually sticks to it too well, as we discovered on the first print of the day. But that's okay. You can always tune down the temperature to make it stick less well. Maker's Knees? Is Angus back? Is he awake again? I mean, he was here the first 2 minutes. But, I mean, obviously, bedtime. Alright, I'm calling it good enough. Wait, California is already awake? Holy crap, it's getting late. Okay. Next up, electronics and wiring. So I don't know how much you can actually make that out, but the 3mm filament that we guided through the entire wrapped tube actually has a nice holder part right down there somewhere, where you can just push the filament in and have it secured that way to the electronic space. That was good. And we're gonna push that all the way in. That is some really nice strain relief right there. That works. I'm not following the manual right now. I should be. Let's unplug that and get back on track. So right there are some cutouts for a zip tie. So, oh, there's some droopy infill right there. So that was why it was a bit hard to push through. One. I'm still amazed that you know my tech is holding up that well, that the cameras are still in sync, that you know everything is still functional. That is amazing. So got that. Extruder cables now for the big bag, for the big bad cable snake from the extruder. This one also has that same sort of hole where you push in the 3mm filament or guide filament. So I'm gonna do that right here. This one actually goes in pretty far. And then these tuck in like that. It actually looks very clean. Yes, so that is actually a nice point. Someone who knows a bit about what I did in the last few years. Spiros Georgakas, probably butchered that last name. So it is on Thingiverse or something, I believe, or what's the one called from Ultimaker? Imagine. I designed a filament diameter sensor and a compact one that would sit on your 3D printer, that would sit directly on a 3D printer in front of the extruder. And that concept actually worked out pretty well. It was a lever balancing a magnet against a basically a magnet sensor. And that would give a very, very accurate reading of the current filament diameter that was being fed into into your 3D printer basically. So yeah, that was a concept that did also that did kind of work. I did get very fast, very accurate readings out of it. I had a microcontroller in there, so it could do an analog or a digital or I2C output. Unfortunately, at the time when I was developing it, the software wasn't ready. Marlin didn't support any of that. Marlin didn't support an analog or digital input. So that project has been on ice for like the last, I don't know, long time, for the last 2 years or so. I've recently seen that the the most recent model does support analog filament diameter sensors, so that should actually be something that we might be able to look into in the future. Yeah, so layer height on the frog, 0.2 millimeters default slice print that came with the i3 on its SD card. So I didn't change anything about that. I didn't slice anything for that. So that is exactly how it came from the factory. Nope. Right there. Yeah. Plus, I designed the original concept for my homebrew filament extruder to give me a feedback for how the extruder was performing at that very time. So I did have very strongly fluctuating filament diameters and was able to compensate for that in software and basically adjust the extruder accordingly. It was around that time when filament quality did get much better, and filament availability also got much better. So you wouldn't have to, or continuing working on that filament extruder didn't really make sense, because why work on it and build everything yourself when you can buy filament for less than it would cost to actually run and maintain that extruder, and end up with a supply that is like good for a long time. So I basically scrapped that project completely. And these days, most filament is, if it's good diameter, it's gonna be consistent. So you don't really need one, actually, I think. Yeah, so there's Nightbot again. Thank you, Nightbot, for automatically spamming those messages. I do have a Patreon account. I do have a YouTube channel where you can subscribe. I do have a stream tip page set up where you can say your thanks basically live on stream and get that cool Twitch-like, hey, this guy donated $5 to the stream pop-up. I'm hoping that is working. It should be working. And I am hugely grateful for anyone who decides to throw $1 to my way, either on Patreon or through the stream tip page. I mean, if it's entertainment for you, that is awesome. So both of these should be identical. I don't know, my hands are kind of in the way. What if I plug them in like this? Oh yeah, that's better. There's the power inputs, two pre-wired power inputs from the power supply. There's the two power outputs, one to the heated bed and one to the hot end. The blue wires obviously go to the E3D hot end. Then the 4 motor channels, X, Y, 2 Z motors, 2 individual outputs, and the extruder. And then we've got the pinda probe already plugged in right there. We've got 2 more end stops. So this one is the Y-axis. And that is Y max. So I'm hoping I should plug this into the correct one. Let's better check the manual. So let's do extruder thermistor first. Okay, so there's that. There's the red with the yellow and green marker. Over here, then we've got the white connector, which is the heated bed thermistor that goes on the exact opposite end. I know, my hands are like all over the place. Okay, so the blue marked one goes to the one next to the cap. Yeah, and this one goes over here. Now this is the only connector that you could plug in backwards. So it is being connected the exact same way as the other fan. So this is the fan 2. I believe this is the part cooling fan. That goes in like that. The spool is squeaking again. Yes, it is. That should be good. So the print counter is on 5 hours 27, and it's saying 69%. So 6 hours might be a bit unrealistic, at least on the silent mode, which might have slightly lower accelerations. Yep. Someone's saying fix your stream tip pop-ups. So actually 8 years 93 from Jats.mt. You rock, Tom. Keep up the good work. Thanks a lot for that donation. Good work on the burgers as well. Get out of here. Also €4.46 from Donnell Bullock. Even though I have already built mine, I'm enjoying the stream. So thank you. I'm happy that you are. I can't tell now. Happy that you're enjoying it. Happy that you're along for the ride. Do I still have like mayonnaise or something in my beard? Probably not. The tip alert or the stream tip pop-up. It might be slightly my fault that these didn't show up. They should now. They were in the background. I'm sorry for that. But thanks for the donations anyways. Okay, so we've got all the little details wired up. Got the 2 fans, got the 2 thermistors, power outputs, power inputs, motors, end stops. There's one end stop missing. That's the X-axis end stop. That is this. That what? Okay, so there's the one. Okay, X-axis end stop. Always double check your connections. So these all go to the min. Oh yeah, right. If it's in the back, it is a min end stop, I guess. Okay, that is all connected up. Now the LCD cables number 1 goes to the outside connector and number 2 to the more inside one, with the noses pointing inwards. So right there, you probably can't see anything again, and right over there. Now if you mix up the if you're trying to add an LCD display to your own 3D printer and mix up the 2 connectors, you connect Exp1 to Exp2, nothing bad should happen. I've done that a few times already, entirely on accident, of course. And so far, you know, all the LCDs I have still work. So, oh yeah, I can see that the frog cam is running out of height, and it's also running out of battery. So just one quick second. While I pop a new battery in here. So this is like the 4th battery for that camera already. There we go. I don't have a power supply for that camera yet. I do have one for this one, so this one keeps going strong. That one does not have the plug-in yet. Plug-in power yet. So the stream tip pop-up did work. So Tolev, good job, Tom. Thanks for that. Question: where can I buy the Pinda probe? The Pinda probe cannot be purchased yet. So as far as what Joe's been saying, they are not yet selling it, which I guess indicates that they are planning to sell it, but they are not yet low FPS. Oh, okay. I will quickly reset that camera. Wow. I think I know what it is. Exposure? Oh yeah. That's better. Cameras are overlapping too. Yes, that's better. Okay, so we got everything plugged in. Low FPS was actually not the computer breaking down. Low FPS was entirely on the camera side. So I did turn up the exposure instead of turning up the ISO. So we ended up with a 1/10 of a second exposure, which, you know, if you do the math, is not enough for a 25 frames per second stream. So obviously that ended up a slightly bit choppy. Okay, so the last thing to do is to press a few buttons to make magic happen. the last thing to do is to add this hinge. So this hinge cover has, whoops, just real quick. The hinge cover has two parts. It's got this one plastic part that we already installed with a hinge pin down here. Then the main hinge door fits on, and then this upper hinge up here gets screwed on. Yeah. Let's get this one on real quick. And I think, congratulations, you have just assembled the whole original Prusa i3 Mark II 3D printer. I think that is literally the last screw right now. Unless, of course, you want to count the one that holds this cover together. Where is it? There it is. Okay, this is literally the last screw that we are inserting into a 3D printer today. There is the cover closing up slowly. Oh, this is tight. I'm hoping I'm not squeezing any cables here, but it does feel good. Okay, that's the printer. Finito. That's the printer completely finished and done. Maybe get these wires tucked in on the bottom here, so that they don't fling around or tend to sit on them. But that's it. That is it. All right, so we did it. How long did that take us? Yeah, how long in total? I don't know, probably longer than the 4 hours that was recommended or was suggested. Let me get you guys a different camera setup. I'm gonna try to untangle this one while I entertain you with a print. Just because I feel like I need a second mobile camera. Let's get the tripod up in here. Now I might need to quickly unplug some of this to yeah, okay, so I'm gonna have to turn up this camera for a quick bit, just so that I can rearrange a few things around here. Camera goes on the tripod. HDMI cable goes into the camera. And now all we need is power to the camera. Okay, so that should start right up again. Hopefully, maybe not. There we go. Okay, so calibration cube versus the finished dragon. Yeah, I don't think you can tell so much from just a simple cube. All right, so there's that camera. There's the other printer back here. Let me man. Let me man our main camera and get you guys some better views on the printer. I guess, I mean, you all know what it looks like already. Oh, I'm running out of USB cable length here. So there is the finished thing. Holy crap, I'm dropping stuff. It's getting hot in here. There is the finished printer. I mean, I guess it looks exactly like the pre-built one. I mean, wouldn't it be a shame if it was a completely different thing? But it is essentially the same machine, right? It's got, of course, I mean, it's got the genuine Joe Prusa signature on there. So this is like the signature edition, I guess. There's that slender black frame, and of course, direct drive extruder with the original Prusa i3 extruder motor on there, plus genuine E3D hot end. Genuine E3D V6 all metal hot end. Yeah, the MK2 heated bed with the auto XY calibration feature stuff. And in fact, that is exactly what we are going to try out next. So let's get some power to this printer and see how it smokes. So 279 on Amazon. That is not the genuine i3. So I have to. Oh yeah, I didn't see the chat. I am terribly sorry. Okay, so 279 is not the genuine Joe Prusa i3. That is some Chinese Prusa copy. This one is 739. You'd have to look that up on Prusa3D.org. Yes, Prusa3D.org. That is the official domain for the genuine Joe Prusa original i3 Mark II. 739 plus, if you want it assembled, you can get it for $9.99, ready to rock. So Joe Prusa is getting sort of nervous. Again. I don't know, let's just plug this guy in. And it's powered on, and it's powering on, and there is no smoke, there is no noise. And there is the first, whoops, I'm losing my HDMI capture. There is the first run wizard. So let's go through this one together. Yes, let me just rearrange some audio and camera stuff so I can read chat. So we are going to set this one to the only real choice here. There is no German, so I'm going to go with English. Printer has not been calibrated yet. Run calibration G-code to adjust Z height. Okay. For that, I believe we do need the SD card. And to repeat myself, for that we're going to need the SD card. For that, I'm going to have to find the SD card. Which I put somewhere. Yes, there's a USB port. That's no use. No, it is not plugged in yet. SD card, where did you go? I need to follow the assembly, the instructions in 6.3.1. LCD assembly. I mean it. I am guessing it should take me through the process on the LCD pretty well. If I can find that darn SD card, where did? There's the other parts. Now I could of course steal the one from the from the other i3, but that one is printing, and I hate to have to cancel that print. That is incredible. Did you guys see me unbox one? I'm missing an SD card. I'm definitely missing an SD card. I'm not sure if I box one or not. There's the spare spec. There's a spare card somewhere right there. The question is, which bag should that have been in? Left steel rod slotted incorrectly. Yeah, it is. So, first cardboard box you open. Well, it will probably appear sometime in the future again, unless I put a cardboard box somewhere where it has disappeared from. I'm looking for an SD card, or for the SD card. You know what I'm going to try to do is I will try to find the SD file, the Prusa file, the calibration files from Prusa themselves. I guess they should be online. I'll just switch over to the Dragon again to give you a bit of an overview. So if I open up the handbook, it will show me where to. Oh, the handbook. So the actual. Oh, this one, not the assembly manual. The actual handbook. Okay. Safety instructions, printer assembly, first steps, increasing the adhesion. I mean, this is all stuff. Oh, okay, so handbook chapter 3.5 or 6.3.5.1. Yeah, okay. Let's go. I was thinking you guys were referring to the assembly manual, so let's go through the handbook together. Just so you guys have kind of an idea of what's happening here. This is still looking good. And that is looking overexposed. There we go. Okay, so basically, what we're supposed to do is first steps. Okay, unboxing, assembly, setup before printing. Place the printer to a horizontally stable position. Best place is a workbench, we got that. Attach the filament holders, we got that. Attach filament to the holders, we don't need that yet. Plug in the AC power, did that. Check the firmware version, that is 3.06. So let's check the firmware version. In the support menu. I'm thinking this is, if it is older than 3.06, upgrade to the latest one from our website. So I am guessing 3.07 is fine. Okay, calibration flow. Let's move on. Kit, start, self-test, calibrate XYZ, load filament, first layer calibration. So I guess we should do print surface preparation. We're gonna wipe that right before the print. Self-test kit only. I'm just walking through the manual as instructed. So we are at 6.3.4 right now. So the purpose of the self-test routine is to check the most common errors when assembling and connecting electronics to help indicate any possible errors after assembly. Oh, okay, so that's the overlay up there. This should not be necessary on the assembled printers as they are pre-tested, okay. Initiating this routine performs a series of tests. Test consists of heat bait and hot end proper wiring, XYZ motors, XYZ end stops, blah 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 blah. Okay, so this is, I guess, in the calibration self-test. So let's do that. Checking end stops, hot end. So I guess it's slightly heating up the hot end to see if the thermistor reacts. Checking x-axis, okay. Looks interesting. Click self-test error, please check. Motor X and stop Z. Okay. Check that motor and end stop on indicated axes are properly connected to the Rambo electronics and not swapped with motor end stop or different axes. Axis causing the problem is indicated on the LCD panel. So I think that is an awesome way to go about I do have the screen turned over here. That is an awesome way to go about that first setup routine, to have that self-test. That can be one of the most frustrating parts of assembling a 3D printer, you know, spending like 10 hours. Oh wow, that thing is tight. Spending like 10 hours on building the entire thing and then spending another 10 hours on figuring everything out. So, even though, I mean, I would like to be printing right now, having the self-test like that is, in my opinion, important and pretty awesome. So let's check the end stops right there. So it's basically telling me X and Z is somehow messed up. So I've got the X-min, I believe, connected to the correct one. So it's saying motor X end stop C. It might just be that the Z end stop is a bit too far down. So let's just push this guy a bit. Let's move. I guess let's move it through the interface now that we have the chance. Interestingly, though, it's saying all of these are okay. So that's the reset button right there. Just figured that out. So can I not move this guy yet? Alright, I shall turn it off and move it very, very carefully. just to make sure we're not triggering the Z end stop already and causing an issue on the self-test, because as it stands now, the wiring does look good in my opinion. So let's try that again. So we're going to do calibration and self-test again. Calibration now, come on. Ah, that's better. See, when the probe was actually triggered, at the moment when you ran the self-test, it did accidentally trigger that probe. So I guess it thought it was getting some bad reading right there. So heat bed, I guess, is just heating up a slight bit and then checking if it responds, and I can feel it heating up ever so slightly. Move the extruder up. I don't know how much lag you have, but that was like 5 minutes ago. But what I can move up actually is the camera. Right there. So it's kind of fascinating, you know, to just see two printers working, one in the back there. If I can get it to focus, one in the back there with the other camera in front, and then this one right up here. So right now it's still doing the bed check. I guess the bed does heat up quite a bit, and I would assume it has some sort of reasonable limits for how long it should take to heat up to a certain temperature. And this is mildly warm. This is like 30 degrees right now. Self-test okay, even though it is out of focus. It is still out of focus. Self-test okay, that is exactly what you want to see. So let's move on. Let's just go by the manual to make sure we're not messing anything up there. Self-test okay, so calibrate XYZ. It does come with the PINDA. The purpose of the XYZ calibration is to measure the skew of the XYZ axis and find the position of the 9 calibration points on the bed. We're carefully as to not touch the print bed by the nozzle, so I do not know if I need to adjust the sensor first, but I think since we adjusted it to the reasonable height, we should be good on this front. Okay. So let's go for the XYZ calibration. Okay, so that's the exact same one we did last time. Wow, the spam is real. Yeah. Okay, so I actually need to move around to this side. Read the bold red text. Place a sheet of regular office paper, for example a checklist chip with every order, and hold it on the nozzle during the first round. First 4 prints being checked off calibration. If the nozzle catches on the paper during the process, power off the printer and lower off the PINDA probe slightly. See the PINDA probe response diagram in 6.3 blah blah blah. The paper will not accept. Okay. Who has mod in chat? I modded Arthur Wolf last time. Because he was around for the entire time. I gave Joe Prusa mod rights for this one. Because it is essentially his 3D printer. His 3D printer live stream, so I think he should have the power to take care of the trolls himself. Plus, I'm mod as well as Nightbot, but Nightbot is kind of dumb. Okay, let's try that again. So I guess I do have to still move these manually, right? Right? No? Okay. I'm dumb. Okay, I might be just worn out, but there we go. So that's moving up. I'm just gonna. I might have, you know, click when done. Okay, so that's done, I guess. Please clean the nozzle for calibration. Yeah, we never had that dirty. Are the Z carriages all the way up? I guess the frog print is sort of in the way. But yes, these are all the way up as far as I can tell. And that was too slow. So the timeout on the LCD could definitely be a bit longer because we just basically had a timeout while checking if the Z-rods were all the way up. Yes. Okay, now the instructions are saying if the nozzle catches on the paper at all. Okay, so right now it is probing for the calibration points for basically these points here on the bed, which you can see because the other camera window is on top. So these points on the bed, it is searching for them. It is just looking for where they are, and it is very, very carefully moving the nozzle down as it does so, because you want like the minimum risk of having anything tear into the PEI sheet. So, okay, it seems it has found it. They actually can't go higher. They do run into the. Okay, that's good. They do actually run into the screws and completely jam themselves up there. It looks like there's a bit of space in there, but they are, trust me, they are all the way up there. So this one is actually looking, or the first one was actually looking pretty good. I did not feel the nozzle catching on the. I did not feel the nozzle catching on the bed. So that's pretty good. Yeah, so about discounts, I mean, ask any 3D printer manufacturers, just ask him up straight, hey, are you going to sell your 3D printer to me cheaper than you're selling it to other people? And most of them are going to stay pretty quiet about it. So I mean, I can totally understand not wanting to just throw out the discount codes left and right, particularly because this is like a relatively new 3D printer yet with a huge demand. So I think they are selling more than they can handle right now. Is that catching? It is not. Okay. So far it is looking very, very good. I mean, of course, this auto calibration does take a pretty long while. We're on point 3 of 4. But you can tell the machine is really, really careful, trying not to damage itself. The Atom, actually, I think it was a spare parts kit that you could get with the discount code. If anyone still has that, it should be good until tomorrow, I think. Let's try to get that in a better view. So I don't know if these are actually the points that the sensor searches for, but you can definitely tell in the heated bed. If I move you guys over here a bit, you can definitely see that there are these little points where the PEI sheet just looks ever so slightly different to the rest of the print bed. Oh crap! Oh crap! So like right there where it can't focus. Right there, you can see that round little thing. I think that is one of the calibration points, and that is exactly the point where the sensor will calibrate against. There you go. Okay. So right now it's doing the full search. So it's doing 0.1 of 9. It just found all 4 bed points, all 4 calibration points in the distributed all over the bed. It was like a quick first calibration, and now it's doing like the main calibration event. So I am happy so far that it did not run into the PEI sheet and damage that. So yeah, pretty awesome. All right, Skydiver, thanks for the heads up on the tungsten premium nozzle. I think I can like do a nozzle shootout with that, comparing genuine nozzles or genuine hardened nozzles from E3D, comparing the coated nozzles, and yeah, the tungsten premium nozzle, I guess. And apparently I did miss a few donations the last few minutes, so from AT Racing, keep up the good work. Thanks for the 45 euros. 10 euros from Toy Life. Congrats on another great build, Tom. Thanks for that donation. For the Frog, Deadeye 0 at 15. Dingaboy 2 €68. Go get that pizza, you've earned it. I just had burgers. I did really enjoy those burgers. And Frank 5 euros. Thanks for that donation. No message there, but always appreciated. Alright, so I don't know if I should like make this window up here a bit smaller, because it is seriously getting in the way now. That is the webcam window. Okay, so there. That's what the that's what the job is doing. So it's basically scanning the points where it's trying to probe, and you know, moves along the bed as precisely or as carefully as possible, and detects when the sensor basically goes from the detection point to a regular sensing point or sensing area. James Beam, did I miss you? You could be Jim Beam. Sorry if I missed the donation. Let me just pull up the full tips list. Anyway, thanks for the coffee. I guess that should be enough for Starbucks coffee at least. Even though, you know, Starbucks, especially the German version, isn't all that great at all. Okay, calibration still going on. Yeah. Huh. Thankfully, this is only a one-time process, more or less. So yeah, this is, I mean, it's dumb calibration, but it's the smartest calibration you've ever seen on a 3D printer, trust me. No other 3D printer I know of, and I don't think any other 3D printer on the market at all, does this sort of XY screw compensation. I mean, most of them don't need them if you don't assemble them as a kit. And also the entire mesh leveling is pretty new still, so I don't think any other printer does it yet. The question on mesh leveling, this is not yet mesh leveling. This is the XY and Z calibration to make sure that the X and Y axes are actually all lined up. And you know, the best way to do that is to measure where these points on the bed are, and if these are a square, and how far out of the square they are. With the mesh leveling itself, it actually probes a bunch of points and then compensates for the offset or tiltedness of each of those tiny squares inside the bed. So yes, if you did have a bowed bed, your print is going to come out just as bowed. Obviously, I mean, there's nothing the calibration can do against that. But that bow is, you know, the bow you have in any sort of heated bed is usually much less than what you'd get from just thermal contraction anyway. So if you have a print and take it off your heated bed, it will warp on its own. It will slightly deform on its own anyway. So I don't think it actually makes anything worse. It just makes sure your bed can be something like this FR4 bed that might not be perfectly flat like a milled aluminum sheet, and still get you good adhesion all over the heated bed. Smoothie Ray does mesh leveling? Yeah, I think it does. Yes, I think it does since a somewhat recent update. Why don't they use a laser for bed leveling? For Delta? Right, I do have that in use on my Delta actually. It is getting late. It's like 9:20. You know, streaming all day does wear you out. I am actually using mesh bed leveling on my Zabriskie born Delta. I completely forgot about that. Improving bed calibration 0.9. Improving bed calibration point. Okay. Can it reduce the zero with each layer a little so it ends up with a perfectly flat top layer? Well, it would also end up with a completely with not only a scoot but a completely distorted print, and I don't know which one of those would be the lesser evil. So yeah, so this is I believe this is actually the mesh bed leveling or matrix bed leveling. No Nightbot is a bot, as the name says. Nightbot is a full-on. Ooh, is a full-on automatic process. Okay, so XY scoot severely. Scoot will be corrected automatically. Okay, so it's basically telling me you suck at assembling 3D printers, but you know what? I'm fine with that. I'm gonna correct for that, which is, I like that mentality. Okay, self-test okay. Alright, so we did manage to complete the calibration process. The printer is already pissed at me because I assembled it wrong, or I assembled it imprecisely. You may consider to realign, let me just get to focus. You may consider, where is it? There. You may consider to realign the XY axis as described. Still, the firmware will correct the screw during normal printing, and as long as the X and Y axis moves freely, the printer will print correctly. So, no matter how imprecise you use some of the printer, it will still print well. So, that is kind of cool. Well, that is actually really cool. Someone asked what sort of hardware this is using. This is using a good old Rambo Mini at Mega 2560 based. So none of the fancy 32-bit boards even. Okay, if calibrate XYZ gives you calibrate XYZ calibration compromised, front calibration points not reachable. We got that. Okay, so calibrate Z. Calibrate Z is a part of calibrate XYZ, so there is no need to run it after a successful calibrate XYZ. So we did that. Perfect. Next up, mesh bed leveling. You can use it to check the pin probe alignment with the calibration process, calibration points. However, it is not necessary during the calibration process, as mesh bed leveling is a part of the calibrate XYZ and calibrate Z routine. So that was what you saw as the very last step there. Calibrate Z, it already did that. It already did the mesh bed leveling. Loading the filament into the extruder. Let's do that. And I think we are going to start out easy again. We are going to give it some PLA to print with. Let's see what we have here. White, red. I feel like this red would be a good option. Or the other silver. Let's do red. Red. I think red shows up pretty well on camera. This is Atom 3D filament from last week's stream. This is a super bright red. So let's try that one for. Let's try that one for the first print and for the filament loading procedure. You can get the G-codes in the 3G objects folder from the driver's package, Tom. Question is, I probably still need to. Oh, that is a lightish red. I probably still need to adjust the Z height for the Pinda sensor. First layer calibration. Okay, so that's the actual G-code that we are going to run first. Main v2 calibration.G-code, so where it lays down a line, and then we can adjust accordingly. Robert, good luck on that divorce. Because we all know which decision you need to make, right? Okay, let's get this one loaded up. Okay, now here's something I'm noticing. Let me just boot up the camera. This spool is too large for the filament holder. This is actually bouncing back and forth in the holder. So I guess that's either not the filament we're going to be using, or we will be using a different filament holder. Okay. Yes, no layer curling on the frog. That is pretty awesome. What to do? Let's just see if we have a different filament over here. Now, you know what? We're gonna load this, but we are going to put it on the big filament holder over here and use it as intended. Just pulling the filament through half of the studio, which should be just fine. Unless it flips back on me. Just like that. That was what I was trying to avoid. Yes, the spool is too big for these filament holders. They don't extend out far enough. So we're just gonna drag that in from over there. So let's get the autofocus back in here again and switch you guys back to the main view. So let's do preheat for PLA. I wish there was a quick option to just preheat the extruder without the heated bed, because I do want to heat up the hot end, but I don't want to heat up the bed as well, since I only want to swap in a different filament. Just get that in here. There we go. Preheat the nozzle. Yes, okay, I'm preheating the nozzle. $482 viewers and only 399 likes? Use the LCD, yeah. So, question is, does this not have a? Yeah, I just turned up the print speed apparently. Does this not have a way to move an axis around? Ah, there it is. Okay. So there's something you guys will be able to see that a bit better. So it is preheated for PLA, so now we can do load filament. It's already in there, and yep, it's just pulling it in. So if everything went correctly, there should be red filament coming out of the nozzle any second now. Still extruding, still pulling it in. There it is. Baby's first step. Little red ooze coming out. So does it keep extruding? No, it stopped. Did it? Yeah, it stopped. Okay, so that's the load filament process right there. Now we need an SD card. Let's just use this 16 gigabyte SanDisk SD card. Please maximize the window where you're currently working. Okay. Alright, let me just find the G codes that we need for the Prusa drivers package. Okay, so the question is, where do we get these files in the drivers package? Please maximize the window where you're currently working. Yes. Got the STLs. Drivers, manuals, others. Oh, there's the G code. Okay. So right here on the Prusa 3D site, you can. Let's get you minimized, Niels. Yes, I did install the drivers before, but what Joe was basically saying, you can also get the G codes on the drivers page right there. So you can get stuff like color, print, you can get the simplified 3D settings, curious settings, that sort of stuff. And of course the calibration G-code, which I just downloaded already, so that's that. Let's transfer this over to the SD card. And we should be good to go in a second. Okay, I'm hoping this SD card is properly formatted for the 3D printer. I have a feeling it's not. It might be formatted with exFAT, but if it's oh yeah, print from SD, can't read that. It can read that. Okay, so we've got the. That's the ACAM. So we've got the calibration. It's not a dragon, it's a frog. Okay. We've got the calibration Z code loaded up on the SD card. The printer can read it. So what it will do right now, or up next, is it will lay down a bunch of lines like that. And the center one should be properly squished down, and the ones on the outside should be somewhat too tall or too low. So we're just going to wipe this down with some alcohol, even though this is very... Ooh, I can feel some waviness going on. Even though this is warm already, it should still take the grease away. So print from SD, get the calibration G code going, heating, and let's see what that does. Let's see. Okay, so we are hot. We are at 55 degrees on the heated bed and 207 on the hot end. That is hot enough. Let's move this guy a bit over here so you can get, so you're not getting blocked by the frog print. Okay. Can we pause this? Okay, Joe's getting pissed at me for not reading the manual again, and I can already see this is sort of too tall. Go to the LCD menu and choose the Live Adjust Z option. A new menu will show where you can tune the nozzle height live during the test print. That is amazing! While the printer is ruining itself, you can live adjust the 3D printer print height while it is printing. Holy crap! This printer is like nothing I've ever seen before. So we're gonna go resume print, and we're gonna say live adjust Z. So this one is still sort of too tall. I guess if we do negative, it's gonna move down. If I need to adjust more than a millimeter, then it might be too much. Okay, so it's looking like this might be a setting that works, but I can see the Pinda sensor actually almost dragging over the bed already. This is a setting that is still sort of too high, so I guess I need to adjust the sensor first. All right. You know, I'm sorry if I'm not following all the precise instructions in the manual in the handbook. You know, I am trying to go just by ear, by heart, by what I know, but I should have known. This is nothing like what I'm used to. So yeah, these are just not procedures I am familiar with. This is like nothing I have ever seen. So the Live Z adjust actually went up to 1.08 millimeters or so. So what we actually need to do is we need to adjust the Z sensor, so the Pinda sensor, 1.08 millimeters upwards. Wow, that camera view is crooked. That should be better. So I shall grab a wrench. And wrench this one up a bit, at least. What? Running it again and lower it more. Well, I could lower it more, but like I said, the Pinda sensor was almost dragging on the part already. So I don't think I need to lower it more. It would actually crash stuff into each other. You know, I don't think I should let that happen. I don't think I should let the probe crash into the print, but I don't know. Yeah. So if you look at the height right about there, I can see it's about a millimeter further down than what the instructions said. So, you know what, guys? I'm just gonna lower this thing. I'm sorry, Joe, if I'm ruining your Sunday night. Yeah, phone's not ringing yet. So 1 millimeter should be about 1 turn. This looks like a standard M8 thread. So what I'm gonna do is I'm gonna pop this thing out. 3, 4, 5, 6, 7. I'm actually gonna overcompensate slightly because it's always better to have the probe further up and then compensate downwards instead of having the probe too far down. Yes, okay, I need to put the probe up. Yeah, there you go. See, we're all on the same page now. And now I'm going to tighten this thing down. We should only have to slightly adjust it in real time. It's gonna be fine, Joe. Relax, relax. Okay, some thread lock on that would probably be great in the long run. Now detail where the probe is. Yeah, I can show that from this angle right here. So the probe is focus. Focus, it's not that hard. Let's just put you at manual focus. There we go. So there's the probe, there is the cable, and so like I said, it did overcompensate ever so slightly. Did that actually give you the zoomed in view? Yes. Oh yeah. Too high. While we still have the chance, let's just readjust it downwards. So I guess I should be moving the z-axis up ever so slightly for this to give me a bit of a better working angle. So we did want this to drop down a bit further. So 1, 2, 3, 4. There we go. That should be good. That should be. Let's make it 5. That should be at least good for the auto calibrate. There we go. That does need to go further in, right? Ah, there we go. And it looks like our frog is making good progress as well. Ah, okay. You guys see that? Probably not, but this one also has an LED in there. Glows red when it's not triggered and turns off once it is triggered by anything metal. Okay. Alcohol. First things first. Always clean the bed before trying to apply anything to it, right? Go, so that should be clean enough for the first print even, but just now I did touchy all over the bed for with my greasy fingers. So let's print from SD again. Let's run the V2 calibration again, just the exact same G code, and do the live. I'm hoping this doesn't time out. Printed. Okay, so let's take this one back over here. Go. Okay. So I guess I'm gonna get a view at that area back there. Okay, that is running. The screeching noise is actually the spool holder on the frog print on the other machine that's doing its job right now. Screeching inside the spool mount, inside the printed spool mount up top. It's not the mechanics, it's not the axis or anything, it's just plastic on plastic rubbing, which I guess you could get out of the way with a bit of silicone spray, just to make it less squeaky. Okay, 210 heating. Let's swap over to not yet. Okay, so it's doing bed calibration first. Again, calibrating Z 8, 7, 6, and so on. God, this is exactly what I was told was going to happen. I did lower it. Come on. And it's still too high. Did it not tighten it up properly? Because this seems like it's sort of no. Prusa coming over. Well, it's only 3.5 hours, so I mean he could have stopped by, yeah. Yeah, the bed survived. All fine. Just a little dimple. But I mean, you guys know why I'm approaching this like that, like you know, your dumbest typical user. You know, it's bug testing. At least I can sort of like that. You know, trying to emulate what a printer with no experience would do. It's all on purpose. Trust me. There you go. Waiting for reset, so we actually need to full reset this thing. And let's go straight back to the calibration G code because the bed is still hot and it should be properly calibrated right now. So major props to the firmware, to whoever wrote that, to whoever came up with all those features. I mean, you can tell this was this firmware was written by, or not, maybe not the exact code, but at least the concept of how this firmware should work, how each of the features should work, was really written by someone who, or by a team, more precisely, who knew that there is kind of stuff going wrong. How do we solve this? That's called quality control. That is called, well, we have a German short name for it, a German abbreviation for it. But it's basically it's common sense. It's making sure that the user, even if the user does something wrong, he shouldn't be able to damage the machine or to damage himself in any way. And so far, I've run into a few situations where at least Joe came screaming at me, but the firmware does seem to protect itself rather well for for a 3D printer firmware. I've regularly complained about 3D printers being dumb and not knowing what they're doing, but this does look pretty good. So we've got about a 0.5 millimeter from the probe triggering to the nozzle when it touches down. So I'm just going to go ahead and go into the live adjust Z. This is, holy shit, this is still at -1 millimeter. That is way too low. So that should really reset between, holy crappers. So we are not stuck yet. A bit more, maybe right there. So this G code really could be slightly longer, but it appears maybe right there, minus 0.94 millimeters. That looks good. So that gets saved. Let's just show you guys the results. So we started out at -1. Camera, why do you? Why have it for secondary? So -1 all the way up front here. So barely anything coming up. But I guess the hotend wasn't primed either. Then I cranked it up to 0 and 0 up here as well. So that's obviously completely loosened. Then we moved our way down to -0.5-ish. This is like -0.8. And then we got the -0.9 down here, and that looks like it is adhering well. Okay. So I feel like this should be the last step of calibration, but let's consult the manual just to be safe from the wrath of Josef Prusa himself. So properly tuned first layer, bed level correction. If the first layer seems to be ever so slightly more squished on the right side, you can virtually lower the bed by 20 microns on the right side. Okay, so we do not need to do that. After the calibration G-code, it's a good idea to print a simple object, which means we're going to print the most complex object we can find. Perfect. Securing the probe kit only. Yes, we will do that after the first print. It's going to be fine for now. Just gotta remember it. Okay, so now we can print. Yep. You guys are reading Bible passages to me right now? Josef Prusa, Tom, 6.3.10.2. Okay. I haven't seen a chat input from Calvert Z, my friend. I haven't read chat input from Joe for a while, so I guess he like passed out or something. But I think we're ready for the first print. So, since we already set up SlickVR, let's just switch you guys over here. So that was actually one of the first things we did. We set up SlickVR for the Prusa i3, which actually is only a matter of... you should run the Calibre Z to store a new height map. Okay, I'm going to do that in a second. That was one of the first things we set up, and it's one install file that gives you the custom SlickVR. That is annoying as heck. It gives you the custom SlickVR installation. It gives you